To finish this section, let's quickly talk about timers in JavaScript. And we have two kinds of timers. First, the setTimeout timer runs just once after a defined time, while the setInterval timer keeps running basically forever until we stop it. So basically, we can use setTimeout to execute some code at some point in the future. So let's use this to simulate ordering a pizza. So when we order a pizza, it doesn't arrive right away, right? So instead, it's going to take some time, and we can simulate that. So let's write setTimeout, and then this function receives a callback function. So just like some array methods or DOM event handlers, right? And we already talked a lot about this, and I think we even used the setTimeout function here as an example of callback functions a bit earlier, right? So let's use an arrow function this time, actually, because why not? And so here, let's just say, here is your pizza. And then just some pizza emoji here, maybe. All right. So this callback function here is the first argument of the setTimeout function. And so again, we do not call this function ourselves. We simply pass in this function as an argument to setTimeout. And it is this function who will then call our callback function in the future. And when does that future arrive? Well, that's what we specify here in the second argument. So here we pass in the amount of milliseconds that will pass until this function is called. So let's say we want to call this function after 3 seconds, and so we need to pass 3000. So 1 second is 1000 milliseconds, and so this is basically 3 times 1000. Okay, so let's give it a save, and you see the page reloaded. And now, after 3 seconds have passed, we get this log to the console. Okay, and so with this, we really delayed calling this function here, right, by exactly 3 seconds. And we can also say that we schedule this function call for 3 seconds later. All right. Now, what's really important to realize here is that the code execution does not stop here at this point. All right. So when the execution of our code reaches this point, it will simply call the setTimeout function. It will then essentially register this callback function here to be called later, and then the code execution simply continues. And we can prove that by doing something after the setTimeout. So let's say waiting. And if we now save this, then immediately we will see this waiting in the console. So let's check that. And indeed, we get waiting. And then after the 3 seconds, then this log here appeared. All right. So this is really important to understand. So again, as soon as JavaScript hits this line of code here, it will simply basically keep counting the time in the background and register this callback function to be called after that time has elapsed. And then immediately JavaScript will move on to the next line, which is this one. All right. And this mechanism is called asynchronous JavaScript. And we will talk about how exactly all of this works behind the scenes in a special section just about asynchronous JavaScript. Okay, but anyway, what if we now needed to pass some arguments into this function here? It's not that simple, right? Because we are not calling this function ourselves. So we are not using the parentheses like this, and so therefore we cannot pass in any arguments into the function. Right? Now, however, the setTimeout function here actually has a solution for that. And it works like this. So basically all the arguments here that we pass after the delay will be arguments to the function. So let me demonstrate that to you. So let's say here olives, and then another argument spinach. And so here I can now specify the ingredients. So olives and spinach will be ingredients in our pizza. So let's say ingredient 1 and ingredient 2. And here we can then use them somehow. Let's make this a template literal. Let's give it a save here. And so the waiting once again appeared immediately. And then after 3 seconds, our string appeared locked to the console. And indeed, this third argument that we passed in did now become the first argument or the first parameter of our function here. And then the fourth argument became this second one. And if we passed in even more, we could then get access to them here in this callback function. All right. And that is essentially how the setTimeout function here works. There's just one more detail that I want to show you, which is the fact that we can actually cancel the timer at least until the delay has actually passed. So before these 3 seconds here have passed, we can cancel the timeout. And so let me show you how. Now to build this example, I first want to change something here. So I want to put the ingredients into an array. So let's say, again, olives and spinach. And so how would we then pass in these ingredients here? We're not going to do ingredients 0 and ingredients 1 like this, right? No. Instead, we will spread the array here using the spread operator. And so this will then take the elements out of the array and put them here basically comma separated. And so this now works exactly the same. But now what I want to do here is to say that if the ingredients include spinach, because that's something that many people don't like. So if the ingredients include spinach, then clear timeout. And so now here we need to pass in the name of the timer. And so we can basically assign this timer to a variable. So let's say simply, let's say pizza timer. And so here we can then use that variable, so that timer, to clear it. All right. So again, here we basically stored the result of the setTimeout function, which is essentially the timer. And then we can use that variable to clear the timeout. And then we can use that variable to basically delete the timer. And for that, we use clear timeout. And so now, since this array contains this spinach here, now you will not see the pizza string here printed to the console. All right. But if it did not include spinach, then of course, it would still work after 3 seconds. All right. So this is how the setTimeout function works. And that's actually it. That's all you need to know about the setTimeout function. It's pretty straightforward, right? So let's now actually go back to our application and implement a timer to simulate the approval of our loan. Okay. So when we click this button here to request a loan, then we get the value immediately right now. But typically a bank takes some time, like some days or some weeks, to approve that loan. And so let's simulate that here by taking like 2 or 3 seconds. So what happens when we successfully request a loan is essentially this code here, right? And so let's simply wrap all this code into a function. So curly braces, then function just like this, and then put all of this into a setTimeout. And then down here, give it a save, and then it should be nicely formatted. Okay, and now let's say, well, after 2.5 seconds. Okay, and so let's just see what it looks like in practice. So requesting a loan of 1,000. And so now it's going to take 2.5 seconds. And indeed, the bank just approved my loan here. So that was 10,000. Let's do something else. So count the seconds here. And now my loan was approved. And so then it appeared here in the movements, and it also appeared here in the balance. You saw that? So that makes our application a little bit more realistic. But let's go back now, because we also need to talk about set interval. So we learned that set timeout here simply schedules a function to run after a certain amount of time. But the callback function is only executed once. Now, what if we wanted to run a function over and over again, like every 5 seconds or every 10 minutes? Well, for that, we have the set timeout function. So this one is going to be set timeout. So let's use the set timeout function to basically create a clock that will display in our console. So set timeout, and then a function. And of course, I could have used an arrow function, but it doesn't really matter here. So our callback function, and let's create a new date here. So let's say now, and then new date. Okay, so this is nothing new at this point. And then let's just log that date, so that current date, to the console. And we want to execute this every 1 second. And so here we say 1 second. So let's see what happens. And indeed, once every second now, this should be executed. But it doesn't. And that's because I made the mistake of calling set timeout again. But of course, as I was saying all the time, this one is actually called set interval. So maybe you were already spotting this mistake, but now let's see what happens. So now, after each second here, we get the current time displayed to the console. So what's happening here is that this callback function is now executing every second. Okay? So every second a new date is created here and is then logged to the console. And of course, we could also say every 3 seconds. And then we would get the current time on the console every 3 seconds. You see? So it's adding 3 seconds each time now. But 1 second here makes a little bit more sense. Now, of course, you could print a real clock using this function now. Like you could get the current hour, minutes, and seconds from this now date. And so I would challenge you to do that actually, to take a minute or two in order to build like a real clock that is only logging the hours, minutes, and seconds here to the console. Now, I'm not going to do that here, but I think this would be a nice challenge to train a little bit the stuff that we've been using previously in the section. But for now, this is actually enough for this video. So take this challenge that I just mentioned, and then I'll see you soon in the next video. Welcome back. And this is going to be the last part of this project. So we're almost done here. Now, for security reasons, real bank applications will log out users after some inactive time. For example, after 5 minutes without doing anything. And that's what we will implement in this video using the set interval timer. And let's start with one final look at our flowchart. So the timer appears in multiple places here, and the first one is right here. So whenever the user logs in, the logout timer will start or restart. All right. And then as soon as the logout timer expires, which will be after like 5 or 10 minutes, then we want to log the user out. All right. So basically that's what we will do with the timer, but let's start very simple. So the place where we want the timer is here in this function about the login. Okay, so this here is the handler function that handles the login. And so our timer will start here. Now we already have plenty of code here, as you see, right? And therefore, let's actually create a separate function which will start this logout timer. All right. So let's say start logout timer. And this function doesn't need any arguments. All it does is to basically export some functionality into an external function. So let's write some pseudocode here, basically by writing some comments to say what exactly we are going to do here. So we will start by setting the time to, let's say, 5 minutes. Okay. Then we want to call the timer every second. Then in each call, so in each callback call, print the remaining time to the user interface. And then when the time is at 0, so after the timer basically expired, so when we reach 0 seconds, stop timer and log out user. Okay. And to make this a bit easier to visualize, let's go again here to our demo application. And so the timer that I mean is this one here, which actually starts at 10 minutes. And you see that after each second, a new time is basically printed here. All right. And I'm not going to wait for 10 minutes now, but when this reaches 0, then the user will, of course, be logged out. Okay. So let's basically do everything that we described here. So I'm setting the time for now just to 10 seconds. Okay, just so we see what's going on. Or actually, let's say 100 seconds, so that we have actually more than 1 minute. Then we want to call the timer every second. So basically what this means is to use the setInterval function and then pass in a callback function, and this callback will be executed every second. And so 1000 milliseconds here. All right. Then each time that this function is called, print the remaining time to the user interface. And then this one here as well. So when we're at 0 seconds, stop the timer and log the user out. So we want to print the time here to this label, which is called label timer. So let me just show it to you here in our elements that I pre-selected. So label timer is the element with the selector of simply timer. Okay. So let's go. So label timer dot text content is equal to the time. And so that's this here. So I forgot to write the name of the variable actually. And now to make this actually work, we also need to remove 1 second in each of these function calls, right? So decrease 1 second. And so time equal time minus 1, which is essentially the same as saying time minus minus. All right. So this is the logic of this timer. We start with a certain number of seconds. Right now that's 100. And then each time that this callback function here is called, we remove 1 second from that. Okay. And so this is called every second. And so basically we will end up with a timer which shows the current number of seconds each second. Okay. And now all we need to do is to then call this function here on login. So Well, let's do that here before updating the UI. So start, logout timer. And now let's quickly log in here. And indeed, you see this number here decreasing now. Okay, so hopefully that that logic makes sense of decreasing 1 second every second. Now, where is that? We have too many functions here, I guess. Now, here we go. So again, the logic here is to decrease the timer by 1 second every second. And so therefore, we get this number here going down by exactly 1 each second. All right. Now, we don't really want to see only the seconds. We want to see the minutes as well. So basically, we need to convert this simple number of seconds to minutes and seconds. All right. So let's do that here as well. So let's say the minutes is the current time divided by 60. So that's the easiest way, basically, of writing it. So it's not going to be correct, but it's going to show us what we need to do next. Now here we're also seeing already what happens with this timer after a certain number of seconds. So indeed, as soon as the time hits 0, it will not simply stop, right? We're not telling the timer anywhere to stop. And so it will simply continue and become negative. And so that's what we will have to implement then down here. But let's leave that for later. For now, we just want to display the number here in minutes and seconds. But for now, I will just show you the minutes, just to show you what we need to do next. So you see that we have 1 minute, 0.6 or 0.5 something. So it's decreasing every second, but this number here after the comma or after this period doesn't really make sense, right? So basically what we want to do is to take whatever remains of dividing the time by 60, because that will be our seconds. So let me show that to you as well. So seconds will be the remainder of dividing time by 60. And so that's where, again, the reminder function is very helpful. So the reminder operator, actually. So let's now print both of them here as a template literal. So minutes, and then colon the second. Okay, and this is still far from being complete, but let's take it step by step here. So you see that this number here is now decreasing very nicely. And it started at 1 minute and 40 seconds. And that's exactly what 40 seconds is, right? So let's do this again, actually. And notice down there how it starts exactly at 1:40. So you saw that? And that 40 appeared because that is the reminder of dividing 100 by 60. So let's see it here in the console. So when we divide 100 by 60, then this is the result. But if we do 100, the remainder, then we get 40. All right? And that's because 1 times 60 plus 40 is then again 100. All right? Now here we actually do not want then this value after the comma, right? We are only interested in basically the integer. And so let's cut off that decimal part by saying math.trunc, all of this here. And then we also want to pad this number here with a 0. So for example, right now we are at 8 seconds or -8, but we want to see 0.8, just like in a normal clock. Okay, and for that we can again use the pad function. So let's convert this here to a string. so that we can then call pad start, which should have the length of 2, and pad it with 0. Or just the number is okay. And then the same here. And so now we should get a nice looking clock already. Let's actually start at 120 seconds, which is exactly 2 minutes. So you see now it's a nicely looking and nicely working clock, basically. So a countdown timer that starts counting from 120 seconds, which is exactly 2 minutes. And so that's why in the beginning the seconds is 0, because the reminder of doing 120 by 60 is 0, because 2 times 60 is exactly 120. Right? So 2 times 60 is 120, and therefore there is no reminder. So there are no seconds in our case. Okay? But let's not do it with only 10 seconds, because then we get that negative, and we can then work with that. So what we want to do here is as soon as we reach 0 seconds, we want to stop the timer and log out the user. So if the time is 0, then we need to stop the timer. And we do that by using clear interval. So remember in the last video, we used clear timeout to stop the set timeout function. And now we can use clear interval to do the same with the set interval timer. All right. Now, in order to make this work, remember, we need to give a name to this timer. So let's simply call it timer. And then here we can use that variable to indeed stop that timer. And then we want to log out the user, which basically means setting the opacity of this whole container here back to 0. So here in our login, we did the opposite. So we set the opacity to 100. And now logging out the user basically means setting it back to 0. And here this text content should also be set to something else. So not the name of the current user. So let's copy that. And so here the welcome label should say login to get started, which is basically also the default that we see right now, right? And then the opacity back to 0. And remember that usually when we first see the application, all of this is actually invisible. And let's do that here, actually. So get rid of this fake always logged in. So we did that before to test our code, but now it's no longer necessary. And so this is how the application is supposed to look like in the beginning. So we logged in, and now our timer down here is running. And so let's just see what happens once it reaches 0. And indeed, we got logged out here. Okay, so that works beautifully. But let me log in again here so I can show you something that happens and that we need to fix. So as I log in, it takes quite some time until something happens here. Maybe you didn't catch that, so let me try it again after we get logged out here. So I will scroll down immediately and then I hit enter. So you see, before it was still at 1 second. So it was the value that we had before. And that happened because this entire function here is only first executed after 1 second, right? So this callback function that we passed into set interval is not called immediately. It will only get called the first time after 1 second. But in fact, we want to call this function also immediately, all right? And so the trick to doing that is to export this into a separate function, then call it immediately, and then also start calling it every second using the setInterval function. So let me just show it to you. So I cut the function here. Let's put it here. So we need to give it a name. I'm calling it tick because that's a pretty common name. And now I put it here. And so right now everything is exactly the same as before. But what I wanted to do is to also call this immediately. And so this is how we do it. And so now right away this function gets called, and then after that every 1 second. And so let's try it now again. Let me scroll down here. And you see, this time we didn't have that problem. Now it's simply not counting down, but that's because I did this small mistake here, which you see is very common in development. You will do this also all the time. And well, now we didn't see at the beginning of the timer, but believe me, now it's actually working correctly. However, you might have noticed that we still have a problem, which is the fact that actually we get logged out once this hits 1 second. And so watch closely now what happens when we reach 1. You saw that? And so that's not what we want to happen. This should only happen at 0 seconds, not at 1 second. And the problem here is that we decrease this time by 1 second before checking for 0. So basically the problem here is that in the iteration here, so in the call where the time is 1, right? So here it's going to be 1, and then we decrease to 0, and then we check for 0. And so in this iteration where the time is initially 1, this part of the code still gets executed. And again, because we increase that 1 second to 0 here before this. And so we need to put it after, of course. And so now this part of the code here only gets triggered if the time really is 0 here in this whole function. So now you will see that the logout will only really happen after exactly 10 seconds. So you saw it reached 0, 0, and then we got logged out. Great. So let's increase this here a little bit. And then I will log in as this user. So you see that it's running. And now I will also log in as Jessica Davis, just to see you yet another problem that we have. So you see, it's weirdly alternating between these two numbers. And the reason for that is that right now we have basically 2 timers running at the same time. So 1 timer of Jonas and 1 timer of Jessica. And so that's not at all what we need, right? That's a big problem right now. So how can we fix this problem? Well, basically what we can do is that whenever we log a user in, we check if there is already a timer running, and if so, then we stop that timer. So I believe that is the best solution to this problem. And so what I'm going to do now is to return the timer from this function so that we can then use it here in this callback function of the login and delete it in case that it exists. So let me write that code actually, and then it's going to become a lot easier to understand. So here we will return the timer. And that's important because to clear the timer, so to use the clear interval function, we need the timer variable. And so therefore I'm returning it here. So let's then save it here. So that's down here. And so this is going to be the timer. Now we actually need this as a global variable. So let me put that outside here. So the current account and the timer. And the reason for that is that we need this variable to persist between different logins. So otherwise, after this handler function here would be ready, then the timer variable would disappear. So that's the reason why we have current account out here, and it's also the reason why we need to keep the timer out here. That's the only way in which we can then actually check if it appears. So timer and current account both need to be in the parent scope of this function scope. So let me show you what I mean. So here I will then set the timer to the timer that is returned here. However, if there already is a timer, I first need to clear it. And so let's do that. So if there is already a timer, then clear interval timer. And that's it. So let's think what happens when I log in first as Jonas. So when I log in now, there's going to be no timer, right? So in this situation, there was no timer already, was it? There wasn't, because I just logged out for the first time, and so no timer variable was created. But now, since I did log in, now timer is equal to that timer that I just exported from this function using the return keyword. And so this timer now does exist. And so when I now log in as someone else, so Jessica Davis, for example, then when the code reaches this line here, then a timer will indeed exist. And so then that timer is going to be cleared. Okay. And so now there is no problem anymore. Okay, so now it's running smoothly without any problem. And that, of course, also works when the timer here has a higher value. Let's put it back to 2 minutes. So I can now log in. The timer starts running normally. And when I log in then as Jessica, then the timer gets cleared and reset basically, and it started again from 2 minutes. Okay. So all this might seem a little bit complicated, I know, but it's all kind of a matter of thinking about what we want our code to do. So all we're doing here is to use all the tools that we already know to basically achieve one goal that we want to achieve, which is in this case, this timer here running and being resetted each time that another user logs in. Now, another functionality that we want our timers to have is to basically reset once we do something in the account. Because remember, the goal of this timer here is to track the inactivity of the user. So the time where the user doesn't do anything. But if I do something, let's say transfer money, then we should not get logged out. It should be resetted. But as you saw, we still got logged out even after doing that transfer, of course. So what we need to do now is to also reset the timer whenever the user does a transfer or requests a loan. So these are the only two activities that exist in our application. And so these operations should always trigger the timer to be reset. Okay? So let's go here to the transfer. And let's do it here at the end. Reset the timer. So what does resetting the timer actually mean? Well, all we need to do is to basically clear interval using the timer that we already have, and then start it again. So clear interval, and then the timer variable. And so now one more time, it is important that this timer variable is actually a global variable. So a variable that's outside of any of these handler functions. So we define timer, remember, out here, because we didn't want it to be inside of this handler function here. And that was because we wanted this variable to persist throughout multiple logins. But now it's also important because we need it later for other operations. So inside other callback functions. And in particular in this one now. So clear interval of that timer that was defined previously, and then we simply start a new one. So basically we then overwrite that initial timer that we had before. So start, logout timer, and that's actually it. So imagine that the timer was at 1 minute 30 seconds. So when we do a transfer, that timer is cleared and a new timer is started again at 2 minutes. Okay, and now finally the same for requesting a loan. So let's try that. And now the timer is running down here. All right, and now let's try to transfer something to JD, so the other user, let's say 100. And what happens down here to the timer now? And indeed, it got resetted to 2 minutes. And the same when we request a loan, let's say 100. And then after the 3 seconds have passed, then our loan got approved indeed, and our timer reset to 2 minutes. Beautiful. Great. So our application is now actually finished and feature complete. Everything is working just as in our demonstration, and I think this was a great application to teach you really a lot of different stuff in JavaScript. So huge congratulations for finishing this great application. It's good to see that you made it to this point with me, and I hope that you're really proud of this application that you just built. You can now show it to all your friends and everyone that you're telling about your coding journey, and I'm sure they will be just as happy as you are about this amazing progress. So once more, great job and well done. And with that being said, I hope to see you soon in the next section where we're going to build together some features of a real website. So UI components that you find commonly in normal websites, such as sliders or pop-up windows. So that's going to be really exciting. So I hope to see you there soon. So at this point of the course, you're already pretty good at working with the DOM, but there are still a ton of things to learn. So to do that, in this section, we will build a beautiful website project with a lot of different components and visual effects that require some pretty advanced DOM manipulation techniques. So after this section, you will have all the tools that you need in order to implement any visual component or effect that you can imagine. Now, many of the things that I'm going to show you here could actually also be added to a web page simply by using a third-party library. But you want to master JavaScript and the DOM, right? And so therefore, you need to know how to do things yourself. And so, let's go learn advanced DOM manipulation now. So in this section, we're going to build yet another project. So let's start by taking a look at it. So over the last 2 sections, we built the application for a fictional bank called Bankist. Now in this section, we're going to be building the kind of marketing website for the same fictional bank. So again, that's Bankist here. And so let's take a look at it. Now, of course, all of this HTML and CSS that you see here is already provided for you in the starter files. But all the effects that you see here going on will be built by us throughout this section. So maybe you already saw this section here fading in and moving a little bit. And also notice here what happens with these images. So it's basically lazy loading these images as we scroll to them. So here you saw also this section fading in. Maybe you already also noticed that the menu bar has become sticky here at the top. And when we hover over each of these links, then all the other links get grayed out. You see? And so all of that is done using JavaScript. And also here you get this nice pop-up window. And so again, that's JavaScript. Here we have this component, which is a tabbed component, which is pretty common to see in modern user interfaces. And so you will learn how to do this as well. Then again, this section here sliding in. And here we have the coolest component of all of them, which is this slider. So as we click here, you see, basically we have these 3 slides with these 3 dots, and we are circling through them as we click these arrows or even these dots. So these dots, they work just the same as the arrows. And I'm sure you have seen a slider like this. And so now you will learn one way of building a really cool slider. Yeah, just like this one. And here again, we will have the pop-up window. And of course, if we click here, then we get a smooth scrolling animation to that part of the page. And the same here on this button. Okay, so you see there are a lot of dynamic effects going on here on this page. And so I hope you're really excited for this project because you will learn how to do all of them. And these are for sure some of the most important and commonly used effects that you will see on all websites. And so that's why I decided to include this project in the course so that you can learn how to do them yourself. I also tried to design a really nice and beautiful website, which looks like a real marketing page of a real company. And so if you include this in your portfolio, then I'm sure it will look really cool on your portfolio too. So I hope you like this page, that you like the effects that we're going to implement, and that you're just as excited as I am to get started with this project. So anyway, please open up your starter files that I provided for this project. And so there you have this big HTML file that I will explain you as necessary. Then this huge style sheet with hundreds of lines of code that I wrote just for this project. And then of course the script.js. Now here I already included the code for the modal window because this is actually exactly the code that we wrote before in one of the projects. Remember that? So this is exactly the same. And so if we start our project, it should actually already be working. So let's open up here our console, live server. And so this is the page here. Now I'm seeing this page at, I think, 75%. Yeah, because otherwise it looks really ugly, right? And at this point also, nothing works yet as it did in the demo project because the JavaScript is simply not yet written. And so, of course, nothing works here. And everything looks a little bit weird. So let's go back to 75%. But what should already be working is this pop-up. So this modal window. And again, that is because it is exactly the same code that we already wrote before. Now there are just 2 small changes that I want to do here in this code very quick before we get started. The first one is watch what happens if we click this button here, like in this position. So you see that the page scrolled back to the top. And that is because, let me show you here. So that's because this is actually now a link and not a button. And on a link, when we have this hash here as the hyperlink, so as href, then that will make the page jump to the top. So that's the default behavior when we click a link that has this hyperlink here. And so if that is the default, we already know a way of preventing that default, right? Do you remember how? Well, all we need here is in this function, which is the one responsible for opening this model, is to get access to the event. And then on the event, we call prevent default. So hopefully you remember that from earlier. So let's see again. And this time, the page didn't jump. So we fixed that. And now the second part that I want to quickly fix is getting rid of this old school for loop that we have here. Because now we know of a better way of doing this, which is the for each loop. So we have this buttons open modal, which is a node list. And it's a node list because it's the result of query selector all. All right. Now remember that a node list is not an array, but still it does have the for each method. So it doesn't have most of the methods that arrays have, but for each is one of the methods that a node list has as well. And so let's use that now. So buttons open modal dot for each. And so remember that we did this loop here in the first place because we wanted to add an event listener to each of the buttons. So in our case, that's this button here and also this one down here. So this one. Well, for some reason it's not working right now. But let's first finish this. All right. So anyway, we want to attach an event listener to this button and to this one here at the same time. And so that's why we did this loop. But now we have a better way of doing it, which is by simply providing a callback function here to for each. So each one will be a button. And then on that button, we will simply add an event listener. And so that's simply this part. And so now this is exactly the same as this, but in a lot easier way. So let's give it a save. And that works. And let's check the other one as well. And yeah. So this one works as well. And so with this, our code is a little bit nicer and adapted to this page. All right. So we are ready to get started in this section. And we will do that right in the next video by learning a little bit more about how the DOM actually works behind the scenes. Let's start this section by learning how the DOM really works behind the scenes, and more specifically, how the DOM is organized internally. This will make it easier to understand everything else that's going to follow in this section. So first, remember that the DOM is basically the interface between our JavaScript code and the browser, or more specifically, HTML documents that are rendered in and by the browser. Now, we have written a ton of JavaScript code in this course so far, but many times completely without interacting with the browser. So without using the DOM, right? But now we're back to working with web pages, and therefore with the DOM. And this time we're gonna learn as much as possible about the DOM and how to create amazing dynamic effects. So let's remember what we already know about the DOM, which is that we can use it to make JavaScript interact with the browser. And again, more specifically, we can create and modify and delete elements, set styles and classes and attributes, and listen and respond to events. In practice, this works because a DOM tree is generated from any HTML document. And a DOM tree is a tree-like structure made out of nodes, which looks something like this. And we can then interact with this tree as we already did a couple of times in this course. Now, how does that interaction actually work? Well, the DOM is a very complex API, which, remember, stands for Application Programming Interface. So it's the interface that we can use to programmatically interact with the DOM. In practice, that means that the DOM contains a ton of methods and properties that we use to interact with the DOM tree, such as the query selector, add event listener, or create element methods, or also the inner HTML, text content, or children properties, and many, many more. Now, in the DOM, there are different types of nodes, just as I mentioned before. For example, some nodes are HTML elements, but others are just text. Remember? And this is really important to understand because all these DOM methods and properties are organized into these different types of objects. And so let's now take a look at how the DOM API is organized behind the scenes. So first, every single node in the DOM tree is of the type node. And such as everything else in JavaScript, each node is represented in JavaScript by an object. This object gets access to special node methods and properties, such as text content, child nodes, parent node, clone node, and many others. Now, we already know that there are different types of nodes, right? So how should these be represented? Well, this node type has a couple of child types, so to say. And these are the element type, the text type, the comment type, and also the document type. So whenever there is text inside any element, we already know that it gets its own node, right? And that node will be of the type text. And the same actually happens for HTML comments. And that's because the rule is that everything that's in the HTML has to go into the DOM as well. Now, for the element itself, there is the element type of node. And this type of node gives each HTML element access to a ton of useful properties, such as inner HTML, class list, children, or parent element. There are also many useful methods, like append, remove, insert adjacent HTML, query selector, closest, and that's just to name a few. So again, each element will be represented internally as an object. Now, just to make this complete, the element type has internally an HTML element child type. And that element type itself has exactly one child type for each HTML element that exists in HTML. So we have a special type for buttons, a special type for images, for links, and so on and so forth. And that's important because each of these HTML elements can have different unique properties. For example, an image has a source attribute in HTML which no other element has. Or the anchor element for links has the href attribute, which also no other element has. And so the DOM needs a way of storing these different attributes, and therefore different types of HTML elements were created in the DOM API. And just to make sure that we're all on the same page here, this diagram that I'm showing you here is of course not a DOM tree, right? So this is not a representation of any HTML document. This is just the way that different types of nodes are represented behind the scenes in the DOM API. All right? But anyway, now comes the really important part. Because what makes all of this work is something called inheritance. So what is inheritance? Well, inheritance means that all the child types will also get access to the methods and properties of all their parent node types. For example, an HTML element will get access to everything from the element type, like inner HTML or class list or all these other methods and properties. And besides that, it will also get access to everything from the node type, because that is also its parent type. Okay? So we can think of this as if the HTML button element, for example, is also an element and also a node. All right? Now, this may all seem a bit weird and confusing, but don't worry. We will learn why this kind of inheritance works very soon when we finally talk about object-oriented JavaScript. For now, what I want you to understand is that the DOM API is broken up into these different types of nodes. I also want you to understand that each of these types of nodes has access to different properties and methods, and that some of them even inherit more properties and methods from their ancestors in this organization. All right? Now, we didn't talk yet about the document node type. So, document, which we use all the time in DOM manipulation, is in fact just another type of node. So it contains important methods such as query selector, create element, and get element by ID. And note how query selector is available on both the document and the element types. So keep this in mind because it will be important later on. All right, and now there is just one final missing piece here because the DOM API actually needs a way of allowing all the node types to listen to events. And remember, we usually listen for events by calling the addEventListener method on an element or the document, right? So why does that actually work? Well, it's because there is a special node type called eventTarget, which is a parent of both the node type and also the window node type. And so with this, thanks to inheritance, we can call addEventListener on every single type of node in the DOM API. Because all elements, as well as document and window, and even text and comment, will inherit this method. And therefore, we will be able to use addEventListener on all of them, just as if it was their own method. Now, just to be clear, we do never manually create an event target object. Okay? This is just an abstract type that we do not use in practice. This all really happens behind the scenes to make all the functionality work as we expect it to work. So, in a nutshell, this is how the DOM API works and is structured behind the scenes. There are still some simplifications here, but this is all that really matters. And I really wish that I could have had this diagram when I learned JavaScript for the first time, because I really think that this helps structuring all this information in your mind. Now, if you want to go even deeper than this, there is still tons of material that you can check out in the MDN documentation. And if you ask me, it's all really fascinating. But again, all that you need to know is really in this lecture. It took me a lot of hours to put this one together, but I think it was well worth it. And I hope you think the same. But anyway, let's now move on to the practical part of this section, where we will then finally use many of these things in action. In this lecture, we're going to learn how to select, create, and delete elements with JavaScript. Now, the goal of this lecture is more to be like a quick reference for you in the future, because these methods that I'm going to show you here are actually way more difficult to find and to understand from the MDN documentation. And so when you need some of these methods in the future, then all you have to do is to come back to this lecture and see how it works. And let's start by learning a little bit more about selecting elements. And I'm going to start at the very top of any HTML document. So as you know, that is the document. And so actually we do have a special way of selecting the entire document of any web page, so of any document. And that's document element. All right. So just document here is not enough to select the document element because this is not the real DOM element. All right. So for example, if we want to apply CSS styles to the entire page, we always need to select document element. Okay. Let's just take a look here in the console. And so indeed, that is now the entire HTML here. Okay. And we can also easily select the head and body. So that's just head and dot body, as you can imagine. So this is not visible on the page, and the body is then also the entire kind of visible document. All right. So for these special elements, we don't even need to write any selector. But otherwise, as you already know, we can use query selector. So that's nothing new. For example, we can select the header element just like this, and this will then return the first element that matches this selector here. Now, if we want to select multiple elements, then we should use document.querySelectorAll. So again, we already used this one. And so here on this page, we have multiple elements with the section class. So basically each of these here are a section with the class of section. Okay. And I will actually store this here in a variable because I want to show you something a little bit later. Okay. But as you know already, this will return a node list, and then that will contain all of the elements that are a section, so that are selected by this selector. So these ones we have been using all the time, and in fact, they are the most used ways of selecting elements. Now, as you learned, hopefully from the previous lecture, these are available not only on the document here, like this, but also on all the elements, okay? And we actually use this a lot when we want to select child elements, as we will do a little bit later in this section, okay? Next, I think we also already talked about get element by ID. And so here we only pass the ID name itself without the selector. So this section here has the ID section 1. And so, yeah, we don't need the selector here. That's only for the query selector methods. All right. So I showed you this one because now there are also some others. So there are get elements, and that's elements, so with an S, by tag name. And so let's say we want to get all the buttons. So all the elements with the name of button, basically. So let's actually store this also, all buttons, and then log it to the console. Let's give it some more space here. And so here now you see all the buttons that are on our page. Now, what I wanted to show you is that this method actually returns an HTML collection. So that's different from a node list because an HTML collection is actually a so-called live collection. And that means that if the DOM changes, then this collection is also immediately updated automatically. So for example, if I remove this button here, and I can do that by clicking inspect, and then that will select that button here, then all I need to do is to hit delete. And then if I go back here to the console and try to read the all buttons again, then you see that we only have 8 elements in here, while before we had 9, right? So that's something very important to keep in mind when you use this selector here, okay? And sometimes it's actually quite helpful to have an HTML collection like this, which updates automatically. Because of course, we can also delete elements from the DOM programmatically, not just manually, like I just deleted this button here earlier. All right. Now the same does not happen with a node list. So if I take this whole section here and delete it, and if I then try to read all sections, then I still have the same 4 elements here in the node list. And that's because this variable here was created by the time that this section still existed. And it didn't update itself as I deleted one of its elements. All right. So again, that's important to keep in mind. Okay. And finally, I also want to show you get elements by class name. So this is similar again to get element by ID and get elements by tag name. So here we can now specify a class name. So let's say button. And once again, we don't need the selector. So it's not a dot, it's simply the name of the classes. And this one will also return a live HTML collection. So just as I explained you earlier. Okay, so this is how we select elements. Selecting elements. Once of these you already knew. So basically these two more modern ones, but these ones also have a place. So this one and this one, in case that you really need an HTML collection, which in some situations is useful, but most of the time I simply keep using query selector and query selector all. Okay. Next up, let's talk about creating and inserting elements. Now, we can create HTML elements using the insert adjacent HTML function that we used before in the Bankist application. Remember? So we used insert adjacent HTML to create movements, right? And this is a quick and easy way of creating elements that I really like a lot and use the most, actually. So please go back to the Bankist application and remember exactly how it works. All right. So I don't need to talk about this one here again, and I will instead focus on some other ways of creating elements, because sometimes it's more useful to actually build the element a bit more from scratch, like more programmatically using a combination of some other methods. So let's see how, and then it will all make sense. Okay, so let's use document.createElement. Okay, and then here we need to pass in the string of basically the tag name. So I want to create a div here now. And so this will return a DOM element that we can then save somewhere. And I'm calling this one message, and I will explain why in a second. Okay. So again, this here creates a DOM element and then stores that element into the message. Now that element is not yet anywhere in our DOM. All this is a DOM object that we can now use to do something on it, but it is not yet in the DOM itself. So it's nowhere to be found on our web page here. Okay, if we want it on the page, then we need to manually insert it into the page. But first, let's actually do something with it. So for example, we can add classes. And so now this is like any other selection that we have. Okay, so if we have an element in our DOM and select it, for example, using query selector here, like this, then the result is also a DOM object that we can use in our code. And this here is now just the same. It's just an object that represents a DOM element. And so, just like before, we can use, for example, class list on it. So class list, and then we can add, and I will add a class called cookie message. And that's because here we will now programmatically build an element which will display a small cookie message on the bottom of the screen. So I'm sure you've seen these on all web pages these days. They are quite annoying. So let me search here for cookie, and here you go. So this is the class that I created for this cookie message. And so this is the one we are adding now to our newly created element. Okay, let's get rid of this here. And now we can keep going. So for example, we can add text into the element. And as always, we do that using text content. So let's just say we use cookies for improved functionality and analytics, something like that. Analytics. Okay, so this inserts simply text, but of course we can also insert HTML. And so that is then inner HTML which we also already used before. And remember that we can use both of these properties to read and to set content. Okay. And so here, let's now write a string of HTML. So let's copy this. And then we can also like add a button. Okay, missing the colon here. So let's add a button element. Okay, so I'm just writing some HTML here. This doesn't matter, just copy this code. All right, it's just so that it will have the correct formatting then based on the CSS that I wrote before. So this will basically just display a nicely formatted button saying, got it. Okay. But anyway, we now have this element, and all we have to do now is to insert it into our DOM. And let's do that here in our header. So give it some more space. So all of this here is our header element. So this takes up so much space. Can't get rid of it for some reason. So all of this is our header. And so we can now select this header and then append our message to that element. And we already have that here. Let's call this the header. And now we can say header.prepend. And now, indeed, here it is. So here is our message. So maybe you saw it being added here. So indeed, it's now also really in our DOM. Now, for some reason, I think this doesn't look quite right. Well, maybe it does. So what matters here is that we just inserted this element really into our HTML. So right into our DOM. So prepending basically adds the element as the first child of this element. Okay, but we can also add it as the last child. And so that is append. So header.append message. And what happens now? So now we see that it's really appended. So it's the last child. So it's gotta be, yeah, it's here. Now, what we see here is that the element was actually only inserted once. Now, that's because this element here, so message, is now indeed a live element living in the DOM. And so therefore, it cannot be at multiple places at the same time. It's just like a person that also cannot be at two places simultaneously, right? So what happened here is that we first prepended the element, and then we appended it. And what this append did here was to basically move the element from being the first child to being the last child. All right. So basically it moved the element and didn't really insert it because it was already inserted here by prepend. So what this means is that we can use the prepend and append methods not only to insert elements, but also to move them. And again, that is because a DOM element is unique. So it can always only exist at one place at a time. But now, what if we actually wanted to insert multiple copies of the same element? Well, in that case, we actually would have to first copy the first element. So let's comment out this part here and say header.append. And then instead of appending the message directly, we first clone it. So that's clone node. And then we need to pass in true, or we can pass in true, which simply means that all the child elements will also be copied. And so now, as you see, we get the same cookie message in both places. But usually this is not what we want. So let's actually only append it. So having it here at the bottom where it makes the most sense. Now, to finish, there are actually two more methods, and that is before and after. And as the name says, this one will insert the message before the header element, so as a sibling, and this one here after the header element, so also as a sibling. Let's just get rid of this so we can see it here before. And so now it's actually really before the header. So first a cookie message and then the header, but they are siblings. And now the same here. It's now after the header. So we have the whole header and then we have this cookie element. All right. So that is how we create and insert elements programmatically. And now to finish, let's also delete elements. Okay. So what I'm going to do is to remove this element when we click this button. So let's select this button and then as we click it, remove the message. So document.querySelector, and we gave it the class of button close cookie, right? And then add event listener and now all we have to do is message dot remove. And again, here we don't have to select the message element again because we already have it in memory. So we already have it stored in a variable. So there's no need to run a document.querySelector. Of course, we could do it, and it would work as well. So we could select the element with the class of cookie message. But again, that's not necessary because we already have it stored in memory. Okay, and so if I click this, then it's gone. All right, it's nowhere to be found now. Now, this remove method here is actually very recent. Before this method existed, all we could do was to remove child elements. And so back then, we had to select the parent element first and then remove the child from there. So that would look like this. So message, and then we would move up in the DOM tree, remove child. And then again, the name of the element that we want to remove. So this is a bit cumbersome, but again, this is how we used to do it. And I'm sure you will see this in some code bases because many people also don't yet know about this newer way of doing things. And by the way, this way of moving up and down in the DOM tree, like selecting the parent element, is called DOM traversing. And there is a whole lecture on that a bit later in this section. Let's just see if this works as well. And indeed, it does. So this is how we select, create, insert, and delete elements. And to make this 100% complete, just make sure that you review the insert adjacent HTML method as well that we used before in the Bankist application. I promise that we're gonna start working on the project really soon. But for now, we need another reference lecture. So here we're gonna learn about styles and attributes and classes, and you will be able to keep all of the relevant tools here in one simple lecture so that you can reference all of them in the future. And some of these tools we will use later in a project, but it's impossible to create examples for all the functions and methods that I'm going to show you now. But they are still important. So let's go. And let's actually keep working on our cookies message banner here. Okay? So we're going to start by talking about styles. And we already set CSS styles before, but there are still some more things to learn. But first, let's go back to the basics. So to set a style on an element, we get the element, dot style, and then dot the property name. And remember, this will have to use the camel case version. So background color, and then a string with the value. So here the color that I want is this one. So it's this kind of dark blue. So indeed, now this style nicely got applied to our element. And again, we didn't have to select it manually first because we already had it stored here in this message variable, which is this element that we created manually, right? We can also set the width dot width. And remember that we have to write the CSS value exactly as we would do in CSS. And so we always have to include the unit. So in this case, I'm going to set it to a larger percentage so that it occupies this white gap here. And so now it got a little bit wider. Okay. And remember that these styles are actually set as inline styles. So styles set directly here in the DOM. So here in the style attribute of this element, we now have the background color and the width. Okay, and so these again are called inline styles. Now you might think that we are able to also read styles using this. So using the style property. But let's see what's gonna happen. So message.style, and let's say we want to get the height. So let's see what we get. And we get, well, basically nothing. And that's because using the style property like this here only works for inline styles that we set ourselves, also using the style property. So it's gonna work, for example, for the background color. So let's copy this one. And now, here you actually get the background color. And again, because it is an inline style. So a style that we set manually ourselves. But we cannot get a style that is hidden inside of a class, or maybe that doesn't even exist. So for example here, let's say we wanted to get the color. So the color is defined in the style sheet, but if we try to log it here, then it's nowhere to be found. Now we can still get the styles if we really want to. All we need to do is to use the getComputedStyle function. So that sounds a bit weird. And this is how it works. So getComputedStyle, and VS Code already suggests it here to me. And so here we need to pass in the element. So that's message. And now you see we get this huge object here. And so this contains all of the properties with all of the values. So this is huge. And so in practice, what we then do is to simply take a certain property like color from there. And so you see, this here is the color. Or let's say we wanted to height. And so this is the computed styles. So you see computed, which means that it's the real style as it appears here on the page. And even if we do not declare it in our CSS. So for example, the height, we didn't define ourselves, but the browser, of course, needed to calculate the height to display it. And so we can then get access to that value. And so you see it's this amount of pixels. So let's now say we wanted to increase the height of this message banner here by 40 pixels. So we could get this height and then simply add 40 to that. So let's create a variable called height, or actually let's do it directly. Let's say message.style.height should be equal to getComputedStyle.height plus 40, and then don't forget the unit. So 40 pixels. But now we're going to run into a problem, because as you see, this value here itself comes in pixels. So this here is a string, okay? Or actually all of this here, which is the same as we had before up here. So the result of this is a string. So here we are trying to add a number to a string, which of course is not going to work because, well, it has this pixel here. So let me show you that nothing here happened. But remember that we already learned about a nice function which can essentially take the number out of this string. So basically parse the number from here. And that is, remember, number.parse int or parse float. In this case, it's a floating point number. So let's use parse float here actually of this value. And then we need to specify also the number 10 in this function, remember? And so now it actually works. All right. So beautiful. It took that number here and only this number part without the pixels, added 40, and then added the pixel there. So that's a bit too much. So let's leave it like this. Okay, beautiful. So this get computed style can become in really handy. But now finally, let's also work with CSS custom properties, which we usually just call CSS variables. So what I mean here is these variables that we have here. So all of these. They are called custom properties, but again, they are more like variables. And the idea of CSS variables is, of course, very similar to the idea of variables in JavaScript. So this way, we can change a value in many places all over our CSS files by simply changing the value here. Now, if we can change the value here, so here in our CSS, then we can also change it right from JavaScript. So let's go back here. Or actually, let's first see where these properties are defined. So they are defined in the document root. And so in JavaScript, that is equivalent to the document. So basically the document element. All right. So document.document element, as we learned in the last video. Okay. So that is the root that we just saw in CSS. And now again, style. But now we can do set property. Okay. And then the name of our custom property. So let's say we want to change our primary color. So color primary, and then the value that we want to set it to. Let's say orange red. But of course, any color value would work here. And so you see that everywhere in our style where we used this color, which is a nice green color, now turned orange. So here, here, and really all over the place. All right. So with this, we can easily change the style of our page simply by setting one property. All right. So with custom properties, we cannot do it like this here, but instead we need to use set property. And then we pass in the name of the property and the value. And by the way, we can do the same for all properties. So we could also use set property to set the color or the background color or the width or really whatever we want. Okay, but usually it's just easier to simply do it like this. And that's why I always do that. Okay, so that's it for styles. Let's talk a little bit about attributes now. All right, so in HTML, just to remember, all of these are attributes. So this source, alt, even the class and the ID are simply attributes of this element. And so in JavaScript, we can of course access and change these different attributes. So let's actually select that logo that I just showed you. And the class of that is nav __ logo. So that's 2 underscores. And so now we can access some of these, let's say, default properties. So like the alt or the source attribute. So you see, here we get the alternative text, which is this alt, and then also the source. Now this looks a bit different than the one we have here, but more about that in a second. All right, so this works because on images, they are supposed to have the alt anti-source attributes on them. And so if we specify them in HTML, then JavaScript will automatically create these properties on the object. Okay, but if we add some other property that is not a standard, then JavaScript will not automatically create a property on the object. So let's add, for example, designer and set it to Jonas. Okay, and so if we now tried to read logo.designer, that's not going to work. So you see, it's undefined. And again, that is because this is not a standard property that is expected to be on images. All right, just another one that works here, and that's a bit different than you might expect, is class name. So the class name of this element is just this class. And so you might think that it should be just class, but for historical reasons, it has to be class name, like this. Okay? So this is a non-standard, and that's why it doesn't work. Okay? At least it doesn't work like this, but of course there is another way of reading this value from the DOM. It's just a little bit more difficult, but it's not a problem. So we can use get attribute, and then here we can pass in the string designer, and that indeed, it returns to us Jonas. All right. Now, just as we can read these values for these attributes, we can also set them. For example, we can say logo.the alt text should be beautiful minimalist logo. And so now, let's check that out. And so indeed, that is the, well, that's actually the hero. So what I want is this. So yeah, it says beautiful minimalist logo now. All right. Oh, and by the way, there's also the opposite of get attribute, which is set attribute. So we can also say, for example, company, and then set it to Bankist. And so again, if we check it out now, then there should be this new attribute created right here. All right. Now, remember that I told you that the URL here, so basically, actually the source is different than what we have in the HTML. So this URL here of this image is basically the absolute URL, while what I have here, so this one here is just the relative URL, so relative to the folder in which the index.html file is located. So that's completely different. And if we want to get just literally this URL that we have here, then we also have to use a get attribute. Okay? So get attribute and then src. So let me actually put these together so we can see the difference. And of course, I need to log this to the console as well. Okay, and so here you see the absolute version and then here the relative. So sometimes we really need the relative one, and then make sure you use this one. So get attribute. All right, so sometimes that's very important to keep in mind, and so that's why I showed it to you here. And the same is actually true for the href attribute on links. So where is the link? I think down here I have a Twitter link. So yeah, that's this one. So let's get this class here. So very quickly, just to show you, because on links, this is also sometimes very important. Query selector So just so you can see what I mean here. So link.href and link.get attribute and then href again. Well, in this case, they're probably the same anyway. Yeah, because both of them were already absolute anyway. So in this case, that is not a big deal. But for example, in one of these links here in the top, there it might be relevant. Okay, so let's actually try that. So let's use this one. So the button show modal, so the nav link button, which here you see is simply this hash. So let's put that here. Oh, we're missing the dot. And now indeed you see that the href property is the absolute URL once again, while using get attribute simply returns the URL as I wrote it in the HTML. Okay. Finally, there is also a special type of attributes, and that's data attributes. So data attributes are a special kind of attributes that start with the word data. So let's add one here to our image here. And let's say, so data version number equals 3.0. Okay. So again, it has to start with data. All right. And then dash and then whatever we want. Okay. And what's special about this is that now this attribute is at logo.dataset and then .version number. And here that's dataset. Don't know where that came from. Okay. And so here we use camel case, where here we have the dash. Okay. So just like property names, we need to transform this here into camel case. So that's important to keep in mind. Okay. So for these special attributes, they are always stored in the dataset object. And indeed, then down here we have that 3.0. So we use actually data attributes quite a lot when we work with the UI, especially when we need to store data in the user interface. So basically in the HTML code. And we will see how useful that can be throughout the rest of this project and of the course. Finally, to finish this here, just to make it complete, let's talk about classes. And even though at this point we actually already know all there is to know about classes. So you know that there is logo.classlist.add, and I will not do anything here. So there is add, remove, there is toggle, and there is contains. Okay, so these are the four that you really need to know. And here apparently we need to pass in something. Maybe the empty string works, but I'm not sure. Well, apparently it doesn't. Let's just write some name here. Just C for class. Okay. And keep in mind that you can also add multiple classes by passing in multiple values. And of course, here I'm just writing completely fake class names just to make a point. Okay. Now, just as we could read the class name here using the class name property, we could also use that to set a class. So we could do logo.className and then set that, well, let's say to Jonas. Okay. However, don't use this. Don't use. Okay. Because this will override all the existing classes, and also it allows us to only put one class on any element. All right. So again, only one class, and it will override whatever is already there, while these four methods here make it really nice to work with the classes by simply allowing us to add and remove classes based on their names, without interfering with the classes that are already there. Just keep in mind that this one here is really called contains and not includes like it is called in arrays. So I hope that this serves as a nice reference for all these different ways of working with classes, attributes, and styles in JavaScript. But now in the next lecture, let's finally start to work on our project here. Let's now start working on the Bankist website. And we're going to start by implementing smooth scrolling. And the functionality that we're going to implement now is when we click on this button, then it will smoothly scroll to this first section. Okay, so that's it. Simple effect. All that happens is one click, and the effect is that it smoothly scrolls here to this first section. So we're going to see two ways of doing this. First, one a bit more old school, which will allow me to show you a couple of interesting stuff. And then finally, I will show you the more modern way, which only works in super modern browsers. So let's start by selecting the button and the section that we want to scroll to. So that button is, it's this one, button scroll to, all right. And then the section is this one, section 1. So with this ID of section 1. So const button scroll to is document.query selector. All right. And now section 1 is document.query selector. And now it's the ID, so that's the hash, and then section --1. So that's the easy part. And now, as always, we need to start by adding an event listener to the button. .add event listener on click, and then our function. And let's actually give it the event. So in the first way that we're going to do, we need to first get the coordinates of the element that we want to scroll to. So let me show you how. So S1 coords, and that's section 1 dot get bounding client rect. All right, that sounds like a mouthful. It's actually pretty straightforward. Let me show it to you actually first. So when I click this, then we get this DOM rectangle. All right, and it has all of these properties. So the X position, which is measured from the left side, the Y position, which is measured from the top, and then the width of the element, the height, and then a lot of other properties. All right, and this element is probably not the best one to understand this. So let's get this rectangle for the button. So that's the element we just clicked. So e.target, remember, so e.target is essentially this element here. So the one that was clicked. And now get bounding client rectangle as well. And so let's take a look at that second one. So this 30 pixels here is the distance between the border here of the browser. All right. And then this Y is this distance from the top. Then we also have the width, which is this 112, the height. And yeah, here we also get the top, which is in this case similar to Y. Okay, but it isn't always, because when we scroll, then X and Y actually change. Let me show that to you. And if I click this again now, then let's take a look here. So you see that Y is now only 168 pixels. And so that's the distance between this element and the top of this viewport. So this bounding client rect is basically relative to this visible viewport. All right. And in fact, we can also get the current scroll position. So since we're talking about scrolling, let me show that to you as well. So current scroll, so that's the X and the Y positions, just so we see what we are looking at. So these values are at window, page X offset, and page Y offset. So let me just scroll somewhere here, click this, and so we get that the current scroll is at 0 from X. So there's no horizontal scroll, and vertically we already scrolled 290 pixels here at this point. So when we're at the very top, then these two values should both be 0. And so yeah, now they are. So basically this Y coordinate here is the distance between the current position here of the viewport and the top of the page. So here at this line, for example, when we're here, if we get to scroll now, well, now we can't because we can't click on the button. But yeah, you get the point. So the distance, for example, here is now 421. So that means that from this very edge of the browser right now, all the way to the top of the page, it is 421 pixels. Okay? And sometimes that's very important to know in certain applications. And if you're even more curious, then since we're talking about coordinates and stuff, we can also read the height and the width of this viewport. So again, of this rectangle in which we can see the current portion of the page. So height and width of viewport, and they are at document.documentElement.client height, and then the same with client width. Client width. All right. So you see that this height here is 588 and the width 1067. So if I change this here, so this is kind of half now. So let's see what value we get now. And so now it is 276. Okay, and so that's because I decreased that visible box there. And so the height of the viewport is of course different. So let's reload here, click again. And so, yeah, here we get all kinds of interesting information about coordinates, scrolling, and dimensions of the viewport. All right. But anyway, the goal of actually getting these coordinates is because we need them to scroll to this first section here. All right. So basically, we need these coordinates here to tell JavaScript where it should scroll to. So let's now do that, actually. So scrolling, and we use window.scroll to. Okay, so that's a global function that's available on the window object. And here the first argument is the left position. And so that is at S1 chords. And let's take a look here. So this is the one. Oh, now it's gone. So we are interested here in this left value right now. So it is 0, and that's good because we don't want any horizontal scroll. Then for the second one, we're going to be interested in the top, which is, again, the position from the top of the viewport. So the section starts here, so it's basically these 270 pixels right there. Okay. So left and S1 chords dot top. So let's give it some more space and let's try it. And indeed, now it worked. So we are now here at the top of section 1. Okay. And so that's because the top was at 730 pixels. And so that's the distance that was scrolled. However, watch what happens when I click again. So now it doesn't really work, does it? Well, that's because this top here that we specified is always relative to the viewport, but not to the document. So not to the top of the page, basically. Right? So let me show it to you again. So it works when we are here. All right? And that's because this Y position here, which is the same as this top, is 429, which is basically the distance between this point and this point. Okay? But if we're doing it here, then the distance between the line and the top of the viewport here is a lot less. So it's only like 200 or something. So let's see. It is only, actually it's only 112. Well, that doesn't make sense. Well, actually it's this one. So it's only 333. All right. And so basically it only scrolled to position 333, while in fact we wanted to scroll all the way to here, which was at something like, so it was at 492, or actually at 713. Okay, so I know it's all a little bit confusing, and in order to really understand all of these numbers, you have to play around with this a lot by yourself. Otherwise, it's going to be hard to make sense of this. But the solution to this problem is to simply add the current scroll position to the top value here. And with this, we will then determine the position of this section here, not relative to the viewport, so to the top of this browser window here, but instead to the top of the page. Okay? So again, the position of this section here is always this top, which is from here to the viewport, plus the current scroll position. And so that's the distance from here all the way to the top. Okay, so let's add that here. And again, to really make sense of all I'm saying here, please play around with this a lot by yourself. Okay, so page Y offset. And here it should actually also be window. And then we also, just for the sake of completeness, add it here as well. So window.page X offset. Okay, so let's see if it still works here. And it does. And now let's try it from somewhere else, like here. And now it works. Now it goes to the correct place. And so by doing this here, we basically determined the absolute position of this element relative to the document, so to the entire page. And that's important to note. So if you need that, then this is how you calculate it. So again, the current position plus the current scroll. All right. Now we can even make this better. So dot scroll to again, because there is a way of making this animation nice and smooth. And this works by passing in an object now instead of just one argument. So let's get these two, and then let's comment all of this out. And so the properties that we need to specify are the left. So this is the left. This is the top. And so this is actually called top. And then we also have a property called behavior. And so here we can now specify smooth. All right. So to implement smooth scrolling like this, we need to specify an object with the left, top, and behavior properties. So let's try it out. And it works. Great. So that is a lot better, isn't it? And again, it also is going to work from this position. And the browser automatically figures out the speed it should go to make this look really nice. All right. So this is kind of the old school way still of doing it. So manually calculating all of these values here and then saying that we want to scroll to this position. All right. But there is a more modern way, and it works like this. we simply take the element that we want to scroll to, and that is section 1. And on that, we call scroll into view. And then we pass in an object and specify, again, behavior and set it to smooth. And that's actually it. Then we don't need any of this. Okay, let me prove it to you. And it works just the same. So without any of these weird calculations here with these weird positions and all of that, it's all unnecessary if we are able to use this function here. And again, this only works in modern browsers, but if you only need to support these, then you are 100% fine using only this method. But I think it was still a good idea to show you all of these different numbers here. So like calculating the current scroll positions or the current window positions and sizes, and also all the sizes of the elements that we can get using this function. And by the way, these client height and width here are not counting with the scroll bars. It's just the dimensions of the viewport that are actually available for the content. And of course, that excludes any scroll bars. In this lecture and the next ones, we're going to talk a little bit more about events. Now, we already worked with events before, of course, but now let's add some more important concepts and also make things a bit more clear. So, an event is basically a signal that is generated by a certain DOM node. And a signal means that something has happened. For example, a click somewhere, or the mouse moving, or the user triggering the full screen mode, and really anything of importance that happens on our web page generates an event. And as we already know, we can then listen for these events in our code using event listeners, so that we can then handle them if we'd like. But no matter if we handle a certain event or not, for example a click, that event will always happen when a user clicks. So it doesn't matter if we're actually listening for it or not. All right? And that's going to be important to understand also in the next video. Now, we already worked with a couple of different events earlier in the course, but now let's take a look at another type of event, which is the mouse enter event. But let's start by selecting an element, and let's use the h1 element this time. So we have an h1, which is this here. And so let's just say document.querySelector h1. And now we can listen for that event. So we already know about this one. So add event listener. But in this video, we're going to take a look at 2 more ways of listening for events. All right. But anyway, let's now use mouse enter as I said previously. So mouse enter, and then as always, a function with an event. So the mouse enter event here is a little bit like the hover event in CSS. So it fires whenever a mouse enters a certain element. So just as the name says. So whenever that happens, let's create an alert which says add event listener, just so we know where this one is coming from. Great. You are reading the heading. Okay. And let's try it out now. And indeed, as we hovered over it, we got this alert. And if we do it again, it comes again. So that works just fine. Let's now actually take a look at a list of different events on MDN. Let's say JavaScript events. And yeah, this is what I was looking for. So this event reference. So let's take a look at some of the more important ones. So we see that we already used the click events. So where are they? So here, mouse events. So click, this is the one we have been using all the time. But this time we used mouse enter, and as you see, there's then also mouse leave, which is fired off when the mouse is moved off the element. And then you have all of these, and of course you can take a look at this list here by yourself. And you see that there is all these different kinds of events that we can eventually learn how to respond to. But usually the most important ones are the ones related to mouse and the keyboard ones. Okay? But for example, there are also some for the clipboard and for full screen and for resizing the page and for when we scroll the page and so on and so forth. Okay? So here is the warning again. But anyway, let me now show you another way of attaching an event listener to an element. And that is by using the so-called onEvent property directly on the element. So for example, when we want to listen for mouse enter, there is a property called on mouse enter. And then we can simply set that property to this function. All right. So here, let's do that. Just to see. And so now we get, of course, the alert from before, but we should get a second alert as well. And indeed, here it is. Okay. And so actually for each of the events that we just saw in the table, there is one onEvent property like this one. For example, also on click. All right. However, this way of listening to events is a bit old school. So it used to be done like this in the old days, but now we usually always use add event listener. Okay, so I'm just showing you this in case you ever come across this way of listening for events. Now there are two ways why add event listener is better. And the first one is that it allows us to add multiple event listeners to the same event. So we could do this here again and simply change the function here. But if we did the same with this property, then the second function would basically simply override the first one. All right, so that's one advantage of add event listener. And the second one, even more important, is that we can actually remove an event handler in case we don't need it anymore. And this is something that we hadn't done before, but it's actually very simple and very useful from time to time. And to do that, first we need to export the function into a named function. So we cannot just write, for example, the same function and expect it to work. That's not going to work. So let's take this here out. And let's say alert h1 is this function. And then on h1, here I want to pass in that. Let's just comment out this one so it doesn't get in our way. And so let's see. And indeed, it still works. That was not on purpose, but we can now actually prevent that from happening. So after we listened for an event and then handled that event here in this function, we can then remove that event listener. So here we can say h1 and now remove event listener. And again, we have to say mouse enter and then the name of the function. And so this is why we had to export the function into its own function. All right. And so let's see. So indeed, we got this alert now. But if I now hover this again, then nothing happens. And that's because in the same event handler function, we also then removed the event listener. And so this makes it that we can only listen for the event once. So this is a nice pattern whenever you only want to listen to any event just once. But of course, this doesn't have to be in here. So you can remove the event listener at any place in our code. For example, we could remove it after a certain time has passed. So let's use setTimeout here and a simple arrow function. And let's say that after 3 seconds have passed, we want to remove the event listener. So now we get it, and right now apparently 3 seconds have already passed, and so now it's gone. All right, so this is another pattern of removing the event listener, but of course there are going to be other situations where this is helpful. Finally, there's also a third way of handling events, which is by using an HTML attribute. Now this one should actually not be used, but just for the sake of curiosity, I'm going to show it to you here. So let's actually this time use the onClick, just so we have a different one. But so this is quite similar to what we did here before in the JavaScript with the on mouse enter. We're simply defining it directly in HTML. Then here we basically specify a string, and then we say what we want to happen. So this is pretty weird, but well, this is kind of old school JavaScript from the early days. Alert. Okay, and so now when we click here, then we get HTML alert. All right, but anyway, we don't need to bother with this one, but I'm just going to leave it here for you as a reference. And so that's different ways of handling events and also how to remove event listeners in case we don't need them anymore. Next up, you will learn about the most important property of events, which is bubbling. So let's move on right to the next video. JavaScript events have a very important property. They have a so-called capturing phase and a bubbling phase. So what does that mean? Well, let's find out. So here we have a very simple HTML document along with a DOM tree, but only for the anchor element that's represented in red here. So here we can see exactly all the parent elements of that red anchor element. And that's because we're going to simulate what exactly happens with an event when someone clicks on that link. So maybe pause the video for a minute and analyze this structure here. But anyway, let's now say that a click happens on the link. And as we already know, the DOM then generates a click event right away. However, this event is actually not generated at the target element, so at the element where the event happened, in this case the click on the anchor element. Instead, the event is actually generated at the root of the document, so at the very top of the DOM tree. And from there, the so-called capturing phase happens, where the event then travels all the way down from the document root to the target element. And as the event travels down the tree, it will pass through every single parent element of the target element. So in our example here, the HTML element, the body element, the section, then the paragraph, until it finally reaches its target. As soon as the event reaches the target phase begins, where events can be handled right at the target. And as we already know, we do that with event listeners such as this one. So event listeners wait for a certain event to happen on a certain element, and as soon as the event occurs, it runs the attached callback function. In this example, it will simply create this alert window. All right? And again, this happens in the target phase. All right. Now, after reaching the target, the event then actually travels all the way up to the document root again, in the so-called bubbling phase. So we say that events bubble up from the target to the document root. And just like in the capturing phase, the event passes through all its parent elements. And really just the parents, so not through any sibling elements. So as an event travels down and up the tree, they pass through all the parent elements, but not through any sibling element. But now you might be wondering, why is this so important? Why are we learning about all this detail? Well, it is indeed very important because basically it's as if the event also happened in each of the parent elements. So again, as the event bubbles through a parent element, it's as if the event had happened right in that very element. What this means is that if we attach the same event listener also, for example, to the section element, then we would get the exact same alert window for the section element as well. So we would have handled the exact same event twice, once at its target and once at one of its parent elements. And this behavior will allow us to implement really powerful patterns, as we will see throughout the rest of this section. So this really is very, very important to understand. Now, by default, events can only be handled in the target and in the bubbling phase. However, we can set up event listeners in a way that they listen to events in the capturing phase instead. Also, actually, not all types of events do have a capturing and bubbling phase. Some of them are created right on the target element, and so we can only handle them there. But really, most of the events do capture and bubble, such as I described it here in this lecture. We can also say that events propagate, which is really what capturing and bubbling is. It's events propagating from one place to another. Alright, so I hope that all of this made sense, and so let's now actually see this in action in the next video. So let's now see event propagation in practice, and mainly event bubbling. And we're going to do that by attaching event handlers to this navigation link here, and also all of its parent elements. Then, as we click this link, we will give all these elements random background colors, and this will then allow us to visualize exactly how event bubbling is happening. And it will make sense once you see it actually working. And let's actually start by creating that random color that I just mentioned. And the random color is basically just a string like RGB, and then with a value between 0 and 255. So here with commas, actually. And so you see that VS Code is already showing this as a color. So let's start with the random number generator. And this one I will simply write now because we already did it in the previous section. So that's going to be math.floor. So maybe I could have just copied this code here, but then it would appear that this code simply magically appears, and I don't really like that when I'm watching a tutorial myself. Okay, so this was the formula that we used before to generate a random integer, and now we can use that to create a random color. So random color, and let's use another arrow function here. And so now we simply need to follow this formula here. So here we need random int, and as I said, with a value between 0 and 255. So this, and then 3 times. Okay, and that's it. Let's just check it out. 255. Oh, that's not what I wanted. And so you see that random colors keep appearing down there now. Okay, but now let's actually attach the event handlers that I was mentioning. So I want to attach an event handler to this link and then to the parent elements as well. So let's check our HTML. And so the link itself is the nav link. And then let's attach an event handler also to nav links. So that's going to be this entire header there. Let me actually show it to you here. So I'm going to use this link here. So you see it's appearing in blue up there. So this link, then this whole element, and then also this entire header here. So that's with the class of nav. So document.query selector. And here we are actually going to need the event. And then as always, just to see if it works. And it does. So let's now grab some of these others. So there's links and nav. Remember, so that's the three that we want to use here. And so anyone that we click now, we will see link. So for now, that doesn't really matter, because what I want to show you now is what happens when we assign a random background color to first starting with this one. So we can say this, and remember that in an event handler, the this keyword points always to the element on which that event handler is attached. So in this case, that's going to be this link. All right. So we say this dot style dot background color and set it equal to a random color. And for now, let's just get rid of these here just to see if this works. Oh, and now we see this is jumping around, and that's because of this hash there. So let me get rid of this for now. And this here as well. And now as we click, it reloads the page. So what we need here is this, I guess. And so yeah, now it works. And so as we click here, we see that the color of this element keeps changing. But now, what if we perform the exact same action on the parent element? So let's copy this and put it here. And again, keep in mind that this nav links element is the parent of this link. So it's all of this block here. So when I click this link now here, what do you think is going to happen to the nav links element? So to that whole container? Well, let's see. And you see that the container also got its own random background color. So based on what we learned in the last video, why do you think this is happening? Well, just as we learned before, the event actually happens at the document root, and from there it then travels down to the target element. And so in this case, that is this link. And then from there it bubbles up. And bubbling up means that basically it's as if the event had also happened in all of the parent elements. And so that is the reason why this exact event is now also being handled by this event listener here that is on nav links. Okay, so again, it is as if the click event here on this link had also happened right here in this element. So in the nav links element. All right. So both of these handlers here are now handling the same event which happened here on this link. And as we keep clicking, of course, the same keeps happening. Now, what do you think happens when we click only outside here? So only in the nav links? Well, let's see. So you see that the color on the link itself keeps unchanged. And that's because this is the parent element. And so from here, the event only bubbles up to its parent elements. So let's see what happens when we actually also paste this here into this whole nav bar. So let's see. And indeed, now the click event that happened here was indeed handled in all three places. So in all three elements which have a click event handler. Great. But let's now dig a little bit deeper and talk about the event target. So here let me log to the console, first saying that this is the link, and then event.target. And the target is essentially where the event originated, so where the event first happened. So this is not the element on which the handler is actually attached. Okay? So again, this is where the event happened. So in this case, where the click happened. And it is not the element on which the event handler was attached. So let me put the same here also. And let's call this one here the container and the nav. Okay. And now watch what happens again when I click on this link. Okay. So one more time, all the three elements got a random background color. And you see that the target, which is this one here, is always the same. Okay. So in all three handlers, the target element will always be the same. And that's, of course, the element where the click first happened. And it appears in all the three handlers because all of them are essentially handling the exact same event. So this E here, so this event that each of them receives, is indeed the exact same event. And again, that is because of event bubbling. So the event originates here in this link, but then it bubbles up to its parent element, which is this one, and from there to its next parent element. And from there, it will travel even further up in the DOM tree. And so we can then handle that event in all of the parent elements. And that is exactly what we did here. All right. Now, besides the target, there's actually also the current target. So let me log that here as well. And the current target is indeed the element on which the event handler is attached. So e.currentTarget, and here e.currentTarget. So if we do this now, then you will see that the current target is not the same. Well, in the link it is, of course, because that's where the event happened, and it's also where the handler is attached to. But then here, it is, of course, the nav links, so the container, and here the whole navigation element. All right, and so you might have noticed that the current target is exactly the same as the this keyword, right? So the this keyword is also the one pointing to the element on which the event listener is attached to, so such as we used here. And all of this is important to know when you really want to gain a deep understanding of the DOM and how it works. So here you see we got indeed true. So the this keyword and event.currentTarget are going to be exactly the same in any event handler. Another thing that I wanted to show you is that we can actually stop the event propagation. So let me show that to you. Propagation. And so all we have to do is to simply call on the event stop propagation. And that's it. So when we try to do the same thing now, watch what happens. So now the two parent elements did not change their background colors, which means that the event never arrived at those elements, right? That's why they weren't handled there. And again, that is because we stopped the propagation right here, okay? And so the propagation phase then never happened for this event. And therefore, these events never reached this element and also not this element. All right? Now, in practice, that's usually not a good idea to stop propagation, but I still showed it to you here in case you really need it sometime. So stopping the event propagation like this can sometimes fix problems in very complex applications with many handlers for the same events. But in general, it's not really a good idea to stop the propagation of events. So as we just saw, these three event handlers that we set up here receive events from the target elements and also from the bubbling phase, right? So in other words, the event handler functions are listening for click events that happen on the element itself, like this, right? Or like this, and where now, of course, only the background color of this one changes. And they're also listening for events that keep bubbling up from their child elements. And that's the reason why the color changes in all of the parent elements here as well. So the two phases that I just described are phase 2 and phase 3 in the slide that we saw in the last video, right? But now, what about the capture phase? So that was phase 1. Well, as we learned, events are captured when they come down from the document root all the way to the target. But our event handlers are not picking up these events during the capture phase. Remember that? So I mentioned that add-event-listener here is only listening for events in the bubbling phase, but not in the capturing phase. So that is the default behavior of the add-event-listener method. And the reason for that is that the capturing phase is usually irrelevant for us. It's just not that useful. Now, on the other hand, the bubbling phase can be very useful for something called event delegation. So that's something that we're going to do in the next lecture. However, if we really do want to catch events during the capturing phase, we can define a third parameter in the add-event-listener function. So, for example here, we can set the third parameter to true or false. And so let's set it to true. And so in this case, where this useCapture parameter is set to true, the event handler will no longer listen to bubbling events, but instead to capturing events. Now in practice, that's going to look the same here. Okay, but as we take a look here in our log, you will see that now the nav is actually the first appearing. And let's clear that here and see it again. So you see that now the first element through which the event passes is the navigation. And the reason for that is that this element is now actually listening for the event as it travels down from the DOM, while these other ones are listening for the event as it travels back up. And so that happens later, and therefore the nav is now the first one to show up, because this of course is the first one to happen. Because first the event travels down all the way to the target, and only then it bubbles back up. And so these other two event handlers here, they are looking for bubbling events, and so therefore they are going to happen after this first one. Now they're still all working with the same event, they're simply doing it in different phases of the event propagation. And if that sounds confusing, then please take another look at the slide that I showed you in the last video. You can imagine that slide maybe with these elements that we're working with here, and then picture the event traveling down and up again, and how we capture it here in the capturing phase. So with this flag here set to true. So I hope that made sense, but let's now actually get rid of this. So by default, this is set to false, and so getting rid of this is the same as setting this argument to false. So as I said, capturing is actually rarely used these days. And the only reason why both capturing and bubbling actually exist is only for historical reasons. So from the time where different browsers implemented different versions of JavaScript. But anyway, what really matters that you really understand here is that why these three boxes here get three different background colors, even though the click only happened on this element. And I think I made that really clear in this video and also in the last one. Let's now use the power of event bubbling to implement something called event delegation. So what we're going to do is to implement a smooth scrolling behavior in the navigation, so that when we click one of these links here, it will then automatically scroll smoothly to the corresponding section. All right. So right now, as we click one of these links, it actually moves there, but of course we want this to happen smoothly. And so let's now go ahead and use event delegation to implement this navigation. And actually, let's do that here at the top of the file. So here in the beginning, I will have all the code that is actually really related to the page, while down here we then have the code that we have been using to experiment with some stuff. All right. So page navigation comes right here after the model window. Let's grab this separator code here. And in fact, we can also put this code here, which was for scrolling. So this code, we also need it active in order to make this button here work, right? So let's put that actually here second. And okay, this here. All right. And these selections, I will put all of them here at the top. All right. So that's a little bit of a nicer organization, having, just like in the last project, all of the selection in one nice line. All right. Now we get this error here that button scroll to has already been declared. Oh, and that's because we actually wanted to cut this code. So we no longer want it here. Okay, so with this, we cleaned it up a little bit. And so let's now go actually to the place in code where we want to implement the page navigation. Now let's actually first implement this without using event delegation so that you can see the problem in the approach that we've been using so far. And so let's now select all of these 3 links here. So document.query selector, and actually it's got to be query selector all. And then, as we already saw in the previous video, they are called nav __ a link. Okay, so this will return a node list, and now we can use the for each method in order to attach an event handler to each of the elements that are in the node list. So actually just as we did up here, right? Okay, so for each, and so our callback function here, which gets access to the current element in a node list. And so to each element, let's now use the add event listener method. So a click, and then another callback function. So now we have callback inside of callback, but that's not a problem at all. All right, so here we again want access to the event. And now let's just start by logging to console link just like this. So indeed we get link here and on this one and also on this one. So 3 times link. Now you already start to see the problem, which is that by default, clicking one of these links will scroll to the position in the HTML. And that's because of these so-called anchors. Let me show it to you in the HTML. And so these here are called anchors. So hash and then some name here will automatically move the page to the element which has the ID of this. So let's see, down here we have, here we have this section with the ID section 2. And so as we click here then, it will automatically move to exactly that section. And we can see it here also in the URL bar, right? So we basically need to prevent that from happening. Let me just put this back here because in the last lecture, we deleted this section 1 that was here. And so, as I was saying, we need to prevent this default behavior. And so for that, we use once more event, or E in this case, dot prevent default. And so let's see now. And indeed, now nothing happens. So we no longer scroll to the page, and you see that the URL bar is actually also no longer changing as we click here. So that problem is fixed. And so now let's implement the smooth navigation, or the smooth scrolling actually. Because if we didn't want the scrolling to be smooth, then we actually wouldn't need any of this, because we already saw that the browser will actually automatically move to that place, so to that anchor that we defined in HTML. Now, that anchor, however, so basically this part here is still going to be very useful, because we can now take this href attribute. So basically we can take this value here and select the element that we want to scroll to based on this. Because if we think about this, this actually looks pretty much like a selector for an ID, right? So let me write the code here, and then I will explain a little bit more. So let's get that href actually, and I'm going to call it ID. So that is at this, which is the current element, remember, dot get attribute, and then the href. Okay, and I used the get attribute function here because, as we learned before, I actually only want that part that we literally write here. So I don't want the absolute URL, and so that's why I cannot write simply this dot href. Remember that? Anyway, let's now log this to the console to see again what we're doing here. And so you see we get now section 1 here, 2, and 3. And now, as I was saying before, this here looks pretty much like a selector already. And so we can now take this and select an element based on this, and then simply scroll to that element. So for that, we're going to use the scroll into view method here again. So let me show that to you. So document.querySelector, and now all I need to pass in is this ID, right? Because again, this exact string that we get from the href attribute is already the perfect selector, so we can just use that. Okay? And so this is a pretty common technique that we use for implementing a navigation like this. So we put the ID of the element that we want to scroll to here in the href attribute, so that then in the JavaScript we can read that. So we can read that href, and then we can select the element that we want to scroll to. So in this case, it's the element with the ID section 1. And that is exactly this one here. So exactly the first section. All right. So here we have the element now selected. And now all we need is to call scroll into view, and then with behavior set to smooth, just like we did already here before. Okay. And that's actually already it. So that worked beautifully, right? All right, and now the third one, and here we go. Well, that didn't really scroll to where I thought it should go. But now it did. Apparently, something weird happened there, but that's not a problem. Now, as you see, this actually works just fine, but the problem is that it's not really efficient. So we are adding here the exact same callback function. So this event handler here, we are adding it once to each of these 3 elements. So the exact same function is now attached to these 3 elements. And that's kind of unnecessary. I mean, of course, it would be fine for only 3 elements, but what if we had 1000 or like 10,000 elements? If we would attach an event handler to 10,000 elements like this, so like we did here with the for each function, then we would effectively be creating 10,000 copies of this same function here. And so that would then certainly impact the performance. And it's really just not a clean solution in that case. And so the better solution, without a doubt, is to use event delegation. So in event delegation, we use the fact that events bubble up. And we do that by putting the event listener on a common parent of all the elements that we are interested in. And so in our example, it's this container that's around all of these links that we saw in the previous video. So remember, that is this element here. So we will put our event handler on this element here, and then when a user clicks one of the links, the event is generated and bubbles up just as we saw in the last video. And then we can basically catch that event in this common parent element and handle it there, because we also know where the event actually originated, right? So we can figure that out by looking at the event.target property. So that's what event delegation is. And so let's now go ahead and implement it. All right. So in event delegation, we basically need 2 steps. First, we add the event listener to a common parent element of all the elements that we're interested in. So let me actually write that here, because this is a really important technique. So as I said, add event listener to common parent element. And then in that event listener, determine what element originated the event, so that we can then work with that element where the event was actually created. So let's do that. Document.querySelector. And so remember, the common element of all these links is nav links. So again, it's this. Yeah, it's this element. And so this is where we add the event listener. And now we just need to figure out where the event actually happened. And remember that that is stored in event.target, right? So event.target becomes really, really useful now in this strategy, because we can now use this information exactly to basically see where that event happened. So as I click here, we can now see well, that the event occurred from this element. And as we click here, then we see that it originated, of course, from this one. Okay? And as we click somewhere here in the middle, then we see that the click, of course, happened in this entire element, not in one of the links. And this part is actually important to notice, because now we actually only want to work with the clicks that happened on one of the links. So only this one or this one, but the click that happens here on this navlinks element is not relevant at all. And so now we need a matching strategy here in order to match only the elements that we are actually interested in. All right. And in this case, the best way to do that is to simply check if the target has this navlink class. All right. So this is the matching strategy. And this can sometimes be one of the hardest things to come up when you use this technique. But many times I actually do it like this. So I check if the target element contains the class that we are interested in. So class list, and then remember we can use the contains method. And then we can simply check if it contains the class navlink. And so that's then this one here, right? And only if it does, then let's log link. So let's see. So as we click, we get link, you see? Or another one, and we also get link. But then as we click somewhere else, like here in the middle, then we do not get link. All right? And so now we successfully basically only selected the link elements itself. And so now we can basically do exactly what we did here before. So we actually also need to prevent the default. And so let's get all of this. And replace that here. Get rid of the comments. And this one here, so preventing the default, we actually always want that, or to do that. So no matter where we are clicking, nothing should happen. All right. So let's try that. Oh, and here we get this error, and we get null on line 87. So that's this. Oh, and of course, we still have a problem here, because the href attribute is now not on this, but it is on the element that was clicked. And so that is again e.target. So that's the whole reason why we're using e.target in the first place. So let's try now. And beautiful. Now it actually works. So you see, we still get the same sections here also logged to the console, and it scrolls to exactly where we want it to go. Awesome. So this works beautifully, and yeah, we successfully implemented event delegation, which is a lot better and a lot more efficient than simply attaching the same event handler to multiple elements. Instead, we simply added one big event handler function to the parent element of all the elements that we're interested in, and then we simply determined where the click event came from. And then we also needed this matching strategy because we wanted to basically ignore clicks that did not happen right on one of these links. And coming up with this matching strategy, as I like to call it, is probably the hardest part of implementing event delegation. But don't worry, because there will be plenty of examples throughout the rest of the course. And so at some point, it will all make a lot of sense to you. So I hope that you're convinced that event delegation is a much better strategy, even though it requires a little bit more work than the first implementation that we did. And in fact, there is actually an even more important use case of event delegation, which is when we are working with elements that are not yet on the page on runtime, so by the time the page loads. And a great example are buttons that are added dynamically while using the application. So it's not possible to add event handlers onto elements that do not exist. But we will still be able to handle events on elements that don't exist at the beginning by using event delegation one more time. And we will actually do this later in this section. This lecture is going to be about traversing the DOM. So DOM traversing is basically walking through the DOM, which means that we can select an element based on another element. And this is very important because sometimes we need to select elements relative to a certain other element. For example, a direct child or a direct parent element. Or sometimes we don't even know the structure of the DOM at runtime. And in all these cases, we need DOM traversing. And this video is going to be another very nice reference lecture for you. And so let's now work with this h1 element here. And from here, we're going to go downwards, upwards, and also sideways. So let's quickly inspect this element. All right. So we see, so here we have the h1 element, and in there we have some text, we have some comments, then we have this span element, then some more text, and even more elements. And so this is going to be a lot of fun exploring a couple of different methods and properties to walk around this element. So let's start by selecting it. Maybe we already did that before somewhere, but yeah, that doesn't really matter. So let's start with going downwards. So basically selecting child elements. So the first way of doing that is to use query selector, because we already know that query selector also works on elements, not only on the document. So let's simply log to the console h1.querySelector, and then let's again see here what we could select. So we have this class highlight and this class highlight. So that's these two green ones. And so let's select them here. So that's actually query selector all, because there are two of them. And so class highlight. So let's take a look. And indeed, here they are. So this here indeed selects all the elements with the highlight class that are children of the h1 element. And that would work no matter how deep these child elements would be inside of the h1 element. Okay, and that's very important to notice. All right. Now in this case, these two elements here are direct children of the h1, but as I said, it would go down as deep as necessary into the DOM tree. Okay, and also if there were other highlight elements on the page, so elements with this class, they would not get selected because they would not be children of the h1 element. All right, so these are 2 points that are important to note here about query selector and query selector all. Now, sometimes all we need are actually direct children, and so for that we can use h1.childNodes. So let's take a look. And so here we actually get all kinds of stuff. So we get text, we get a comment, and we get then these elements. And that's because we already know that nodes can be anything. So they can be text or elements or even comments, as we have here. Okay, so this really gives us every single node of every single type that there exists. But many times we are simply interested in the elements themselves, right? So if we wanted the text, we could use .textContent or .innerHTML. So child nodes is not that used, but instead we can use children, just like this. And this then gives us an HTML collection, which remembers is a live collection, so it's updated. And so here we indeed only get the 3 elements that are actually inside of the h1. So that's this span, this breaking, and this span again. All right, but this one works only for direct children, so keep that in mind. Okay, finally, there's also first and last element child. So these names are a little bit confusing, but one more time, that's because of the messy nature of JavaScript, with all of these things being implemented at different points in time. And so therefore it was difficult to keep consistent naming conventions. But anyway, let's use first element child. And so here it already is, style.color, just so that I can show you that we can actually also set these properties or use them to set something like the style. So for example, we can do this, and then only the first child here gets now this color set to white. So basically that's this element here, which is the first element here of all the children. That's why it's called first element child. And we can of course do also last element child, and let's say this one to black. So it's a little bit different now. It used to be, let's say, orange red. I really like this one. And so now it looks a little bit more crazy. Okay, but now let's go upwards. So going upwards, so basically selecting parents. And for direct parents, it's actually very straightforward. So here we have h1 dot parent node. And so that one is similar to child nodes. So let's see. And so it's this header title. So as we open this up, we see that indeed this h1 here is inside of header title. And so this is the direct parent. And so that's why we get this. Then there's also the parent element, which is usually the one that we are interested in. But in this case, it's simply the same. All right, because this element is also a node in this case. All right. However, most of the time, we actually need a parent element, which is not a direct parent. Or in other words, we might need to find a parent element no matter how far away it is in the DOM tree. And for that, we have the closest method. So that's h1.closest. So let's say that on the page we had multiple headers, so multiple elements with the class of header. But for some reason, we only wanted to find the one that is a parent element of h1, so of our h1 element here. And so for that, we can use closest. And so the closest method receives a query string just like query selector and query selector all. All right. So dot header, and then let's do something with it. For example, change the background image, or just change the background. And I will set it here now actually to a CSS variable. So let me show that to you. So here we have all of these CSS variables, or as they are officially called, custom properties. And we use them in CSS by doing this. So by writing variable and then a color. And so, well, let's actually use a gradient. So gradient, yeah, so this one. Okay. Just so you can see that we can use custom properties also in CSS. So give it a save. And beautiful. Well, it's not that beautiful, I must say, but indeed it worked. So it selected the closest header to our h1 element, so the closest parent element that has this class, and then it simply applied our style to that element. So this is a very important one, and we're going to use it all the time, especially for event delegation. So take a note of that, or just keep it in mind. Now, if this selector here actually matches the element on which we're calling closest, then that's actually the element that's going to be returned. So let me also show that. So we are calling this on the h1 element. And so if we're looking for the closest h1, then that's going to be exactly the element itself. And so, as I just said, then that's going to be the one that will be returned. Let's make this a bit more prominent here. And so you see that indeed, now this is the h1 element itself. So we can think of closest here as basically being the opposite of query selector. So both receive a query string as an input, but query selector finds children no matter how deep in the DOM tree, while the closest method finds parents, and also no matter how far up in the DOM tree. All right. So very important method here to keep in mind. And now let's go sideways. So selecting siblings. And for some reason in JavaScript, we can only access direct siblings. So basically only the previous and the next one. So that's h1.previous element sibling, like this. And then there's also the next element sibling. All right. So the previous element sibling is null. And so if we take a look at that, it makes sense because there is nothing there. So this is the first child of this parent element, and therefore it doesn't have a previous sibling. but it has a next sibling. And so that's this h4 element, which comes after it. And just like before, we also have the same methods, or actually the same properties for nodes. So that's just previous sibling and next sibling. So let's see. And here the previous sibling is now actually text. So not sure what that is. Well, it's not really important because, again, most of the time we're going to be working with the elements anyway. Now, if we really need all the siblings and not just the previous and the next one, then we can use the trick of moving up to the parent element and then read all the children from there. So let's see. So h1 dot parent element. So that's just like we learned before. So the direct parent, and then from there we can get all the children. So just like we learned here also before. So dot children. And so now we get all of the siblings. And that of course is going to include itself. So that's all of these elements, and all of them are siblings. And just for fun, let's actually do something with them here. So this is an HTML collection, remember, so it's one more time not an array, but it is still an iterable that we can spread into an array. So we can do this, and it will then create an array from this. And then we can loop over that array and do something using the for each method. So let's say that we wanted to change some style to all the siblings, but except the element itself. And actually that's more straightforward than you might imagine. So we can simply do this here. So we can check if the element is different or equal also works than the h1. Because h1 is our original element itself. And so comparisons between elements actually work just fine. Okay? And so when the element is not the h1 itself, then let's change the style. And let's say we want the transform property just to scale them a little bit. Let's say 0.5. So scaling them by 50%. And indeed, all the other three siblings are now like 50% smaller. All right? And so this is how we can work with all the sibling elements of one element. Great. And that's actually the fundamentals of DOM traversing. And we're going to need them all the time, and especially when we're doing some more complex event delegation like we will do throughout the rest of this section. In this video, we're going to implement a very popular component, which is a tabbed component. And you will see tabbed components on many websites these days, so it's great to learn how to build one yourself. So the component that we're going to build in this video is this one. Now, a tabbed component can appear in many different ways, but what they all have in common is that they have some kind of tabs, like these here, and when you click the tab, then the content of this area below will change. And so that's exactly what happens here with these buttons. So basically these three are our tabs, and then as we click on one of the tabs, it will reveal the associated content. So a little bit like tabs here in our browser, right? So each browser tab has its own web page, and so here each tab has its own content area, basically. So I'm sure you've seen this on other websites, and so let's now go ahead and implement this ourselves. Okay. Now, for this component, we actually need a bunch of HTML. So let's first take a look at that. So the whole tabbed component in our case is called operations. So let's scroll down here also. And so this section here is about the operations we can do on a bank account, and therefore this component here is called operations. And you can also see that here on the page. Then we have the tab container, basically. So that's this element. And so you can also see it here again. And it's the element which will contain the 3 tabs. And so each tab is itself a button, and it has this class of operations tab. Okay. Then below that, we have the content. And in fact, we have 3 contents. So we have one content element here for each of the tabs. All right. So the first one here, as you see, is called operations content 1. Then the other one is operations content 2 and operations content 3. So as we click on one of these tabs, we will not create any new content. What we will do instead is to hide the other tabs, basically. So you see that right now, this first one here has the operations content active class. And so therefore, this one is visible and all the others are hidden. And what's also important here is that these buttons here, they have this data tab attribute. And so this one is number 1, and this will then be associated with this class name here. So operations content, and then again 1. But more about that in a minute when we actually implement this ourselves. So for now, we just need to get down the basic structure of the HTML here. And it might be a good idea for you to pause the video and take a minute or two to get yourself familiar with this HTML structure and all of the class names that are involved here. Okay, and you can even take a look at the CSS, because there's also a lot of CSS involved here. All right, so of course I couldn't write all of this code here together with you now, because that would take way too long. All right, but anyway, let's now build this tabbed component here. And we're going to start by selecting the tabs. Okay, and I will keep the elements here open so we can see it at all time. And so you see that the buttons, they have the class operations tab. So tabs equal document.querySelector all, and then with the class operations tab. Then let's also select the tabs container. And so that is this element here. Let's actually go ahead and copy it. And finally, also the 3 content areas. So that's here, operations content. You see, cannot copy it for some reason. Doesn't matter. So tabs content is document.querySelector all. So because again, we have 3 of them. All right. So we have our selections nicely done. And now we can actually work on the functionality. And let's start by adding event handlers to these buttons here, right? Because that is the action that we actually want to handle in this component. So we could do it like this. So taking all the tabs, and then on each of them, we could attach an event handler. So for example, like this. So for each, because we want to do it on each of them, so we get then each tab, and then tab.add event listener, click, and let's just use a quick arrow function here, because this is really just a demonstration. Well, nothing happens. Let's try to reload this page. Yeah, indeed. Now we get the tab locked to the console. Now, however, as we already learned in the last video, doing this here is a bad practice. Because what if we had like 200 tabs? Then we would have 200 copies of this exact callback function here, and that would simply slow down the page. So that's not at all desirable. And so let's get rid of this and one more time use event delegation. And remember that for event delegation, we need to attach the event handler on the common parent element of all the elements that we're interested in. And in our case, that is this tabs container, right? So we have our buttons here. So right here, our buttons, and the common parent of all of them is this tab container that we already selected previously. And so let's attach our event handler to that element instead. So tabs container.add event listener click. We need the event, of course, so that we can figure out where the click happened. And so let's now actually work on our matching strategy. Okay, so we already know that we are interested in the buttons. And so let's now figure out which button was clicked. So let's actually create an element called clicked that we can then use to work with. And so what about this? So what about simply using the e.target? Well, let's see. So in our console, let's now click somewhere here. And indeed, now we got the button that was clicked. Okay. However, there is a problem when we click here on this number. So you see that now we did not get a button, but we got this span element. And that's because inside of this button, we actually have another element. And so now, even though it looked like we clicked on the button here, or here, for example, actually we are clicking on this span element, right? So we are not actually clicking on the button, but we still need the button. So no matter if we click on this button itself or here on the span element, we actually need the button element itself, because from that button, we will need to read this data tab attribute here. Because as I mentioned earlier, this one contains the number of the tab that should become visible. And so here, this data attribute becomes really important to store information in the DOM. So basically, we need a way of finding the button element whenever we click on this span element, right? Now, one simple way to fix it, which would not really fix it actually, is to do some DOM traversing and simply select the parent element. We can move up the DOM tree, and instead of simply taking e.target, we can use the parent element of that. So let's see what happens then. And so now indeed, when we click on the number, we get the button. And so again, that's because that is the parent element of that span. Now the problem appears when we click on the button itself, because now of course we will also get the parent of the button element. And so that is this container. But of course that is not what we want. So basically what we want is to get the button no matter if we click here on the span or on the button itself. So we need a way of selecting the parent element that is always a tab. And can you think of a special method that we learned previously to do that? Well, the solution is right here in the previous video. Well, and that's down here somewhere. So remember that we want a way of going upwards, but we want to specify that we want to select an operations tab. And so we can use this closest method for exactly that. So remember that I said that this method is going to be really helpful in event delegation. And so now that's actually the case. Okay, so this method makes it really easy for us to dynamically get the element that we're interested in. So here, instead of always selecting the parent element, we will search basically for the closest operations tab. And so here we need the exact same query as that. All right, and this should actually now fix our problem. So let's see. When we click the button itself, then we get the button. And when we click the number here, so the span, then we also get the button. because now it finds the closest parent with this class name, which indeed is the button itself, so the tab. And here we get the tab number 2, as you can see down here. And here we get tab number 3. Great. And let's actually immediately do something with this selected tab. So the tab that is currently active here has a different style, as you can see. So it's a bit moved up. And so that's because the active tab basically has this class. So where's that? It has this class of operations tab active. All right. So we can simply add that to the element that was just clicked. So class list dot add operations tab active. Okay. And now as we click, you see that it activates basically this tab. Now, of course, later, then all the other tabs will have to move down, but we're going to take care of that in a second. Because now watch what happens when we actually click on the tabs container itself. So outside of any of the buttons, but still in the tabs container where this event listener is actually attached to. So you see that we get null here. And that's because null is the result of the closest method here when there is no matching parent element to be found. So, of course, when we click here in this tabs container, then there's going to be no parent with this class. And so therefore, as I just said, we get null. And so we need to fix that now in our code and basically ignore any clicks that happen on that area. So basically ignore any clicks where the result is then null. All right. So we can do that by saying if there is no clicked, then return immediately. And this is something that we haven't done before. So what I'm doing here is called a guard clause. So it's basically an if statement which will return early if some condition is matched. So in this case, when there's nothing clicked, then we want to immediately finish this function. And in this case, when we have null, which is a falsy value, then not falsy will become true, and then the function will return, and none of the code that's after it will be executed. But of course, if clicked does exist, then this return will not be executed, and the rest of the code will be executed just fine. So this is a more modern way of writing this. So we could have written instead also, if there is a clicked element, then do this. And this is the more traditional way, as we have been doing it all the time. But this is actually more modern because it looks a bit nicer, because we don't need to create all these additional blocks. So in this case, just this block. But sometimes when we have so many conditions, it can become a little bit confusing. And then it's a bit cleaner to simply return the function immediately if a certain condition is matched. And again, in this case, whenever there is no clicked element here, then we want to simply return the function right away. And so then that code here will not be executed. But otherwise, of course, it will be executed. And so let's now see what happens. So now clicking outside, nothing happens. Of course, we still get the null here, but no error occurs because now JavaScript is no longer trying to execute this line of code here. Okay. But now let's actually take care of basically putting all of these other buttons down, as I was saying. So when I click one of them, then the other ones should move down. So basically, we should remove this class from them, right? And so the solution to that is before we add this class here to anyone, we will simply remove it on all of the tabs. So we remove them on all. So that's all the tabs dot for each. And so each tab I'm simply calling T here, and then tab dot class list dot remove. And so now that should work. And yeah, it does. Okay, so this is something that we do quite usually. So basically clearing the class on all of them and then only add it afterwards on one of them. So let's add a comment here, active tab. But now finally, let's actually activate the content area itself, because that's the main part that we're actually interested in. Now, remember that the information about which content area should be displayed is here in this data attribute. So let me click again. And so in this case, we want the tab number 2. And so that's this number 2 is encoded here basically in this data attribute. So having the number 2 here means that we want to select the element which has the class of operations content 2. Okay, so let's do that. Let me grab this here. So this selector, and then let's select it. So document.querySelector. And now I'm using a template string here because, of course, we don't want to hard code the number 2 here, but instead we want to get that exactly from the data attribute that I just showed you. So let me just show that again to you. Now we get an error here. Let's just put something there for now. So it is called data tab. Okay. And so remember, all these attributes are in the element and then in the dataset property. So the element that was clicked is indeed stored in our variable clicked, right? So every time we click a button, that button is then stored in the clicked variable. And so then .dataset .tab. So that's only the part after the data, remember? So it's just tab. So in this case, it's going to be 2. And so we already have that now selected, and then we want to add a special class to it. So that's ClassList.add. And let's just check out the class that we need to add. So we can see that here on the first content area, which is already active. And so the class here is operations content active. Okay. And one more time, you can check out the CSS to figure out why actually this makes the element active. And we can quickly do that ourselves. So here it is, actually, the active, right? And so basically what this does is to change the display property to something which is not none. So previously, without this active part, so just operation content makes it display none, which basically hides it. But then as it becomes active, we give it display grid and then specify all of these properties there. All right. So this should actually already be working. Just to really see this a bit better in the console also, let's log this value also to the console. Okay. But let's see. And indeed, it now appeared down here. Great. So it's no longer hidden. And indeed, we successfully read that value here from the data tab, which is 2. And the same is going to happen here for 3. And so you see that the content number 3 also appeared down here. Now, of course, this is not quite finished yet, because we want the other ones to be hidden. So that's the whole idea of this component. And so basically all we need to do is to do the same that we did for the tabs. So basically removing the active class for all of them before then adding it to the one that we're interested in. All right, so basically just what we have here. So let's select all the contents, and that we actually already have here, right? So tabs content is also a node list because of query selector all, that we can now loop over and then remove that active class from all of them. So tabs content dot for each, and I'm just calling it C very short here. So C for content. So class list remove. And so you see that it's always the same idea. So it's all about removing and adding classes to manipulate the page to look just like we want. All right. So this comment is actually more here. So activate tab, and here remove the active classes for both the tab and the content areas. And with this, actually our component should already be working. So let's see. And yeah, beautiful. It works great. All right, let's just get rid of all these different console.logs here, because we only need them for development. But now we're done. So let's just quickly recap. And as I just mentioned a minute ago, the whole idea when we build components like this is to just add and remove classes as necessary to manipulate the content to our needs. And actually the exact same thing we did with the modal window. So if you take a look at the code, it's a bit similar. So to hide and display the modal window, all we do is to add and remove this hidden class. Now in this case, it's a little bit more complex, but the idea is always the same. It's to work with classes that have some styles for showing and hiding the classes. And so if you're not yet really familiar with CSS, it's also important that you really check out the CSS to build these components for yourself, and the same goes for the HTML. But of course, I could not write this code here as well, because then this tutorial would take like 1 hour instead of 15 minutes. But anyway, I hope that this was fun. Make sure to understand what we did here, including the HTML and CSS, and then let's go right to the next video. Let's now create a nice effect on our page navigation where all the links fade out when we hover over one of them, except for the link that we actually hovered over. And this will teach us something really valuable, which is how to pass arguments into event handler functions. And the effect that I mean is this one. So when we hover over one of the links, you see all the others fade out like this, and that includes even the logo there on the left side. So let's do that here in our page, and let's again start by taking a look here at the HTML. So we have these links. So each of them is a nav link. And so these are the elements that we're going to be working with. So menu fade animation. But now, of course, we do not want to attach an event listener to each of these links. So we already know that we should do event delegation here instead. So let's find the common parent element of all of the links, and also including the logo there. So if we were only working with the links, it would be this element, but we also want to work with the logo here. And so let's actually use this entire navigation here as our parent container on which we will handle the event that is going to bubble up from the links. So keep in mind that all of this works because events bubble up from their target. So let's select the navigation here and store it in a variable .querySelector.nav. Okay, and actually let me put this here at the very top because we are going to need this a bit later. And it is a good practice to have all of these at the top. And the same actually here. So why not have all of the selections right at the top? That makes it a bit easier to understand the whole file. Okay. But anyway, let's now attach an event listener to that navigation But now we're not going to use the click event, but instead the mouse over event. Okay? And I think that previously we have already used the mouse enter event, and mouse over is actually similar to mouse enter, with the big difference that mouse enter does not bubble. Okay? But here we need the event to actually bubble so that it can even reach the navigation element, and so therefore we use mouse over. All right. So then attach the function here. And there are also kind of opposite events of mouse over and mouse enter. And we use these to basically undo what we do on the hover. So the opposite of mouse enter is mouse leave, and the opposite of this mouse over is mouse out. And so we're also going to need that one. So let's put that here right away. So mouse out. All right. And as always, if you need to know more, then you can check out the MDN documentation. Great. So we have our parent element. And now, as always, we need to match the element that we are actually looking for. And so in this case, that are these elements with the navlink class on them. And so let's simply check for that. So if e.target, as you already know, .ClassList.contains the navlink class, well, then let's do something. So you see that this time around, I'm not using the closest methods. And that's because there are simply no child elements that we could accidentally click here in this link, right? So that was the reason why we needed the closest method here in this tabs, because we had this button, but then we could also click on the span element. And so here we then needed to find the closest element, so the closest button to both of these places. Okay, but here that's not necessary. And so therefore a simple check like we have here is enough. And so now we can actually say that the clicked is then e.target. Okay, so I called it clicked before. Let's call it now actually the link. But this is similar to what we did before also. So creating a variable which contains the element that we're working with. All right, and so now next up, we need to select the sibling elements. So basically all the other links. All right, and remember that we can do that by going to the parent and then selecting the children from there. Now, in this case, actually the parent of navlink is this nav item. And the only thing that nav item includes is always just one link. So you see that each of the link is actually inside of one nav item like this. And so now we would have to move up manually, not just once, but twice. And so instead of doing that, we will again use the closest method. Okay. So again, instead of moving up manually like 1 or 2 steps, we can simply search for a parent which matches a certain query. And so that's a bit more robust, because even if we would then at some point maybe change the structure of this HTML here, then our JavaScript would keep working. All right, so let's say or link, and then find the closest parent, and let's actually search for nav again. Okay, even though that's not the closest parent, I mean, there is another parent to these links, which is this one here, but it's no problem of also choosing an even higher up parent like we are doing here. So we are now at a parent of all of the links, and so now from there we can search for the nav links again. And so these are then going to be the siblings of our initial links. And so, as we already learned before, we can use query selector on an element to search for a certain query only in that element. Okay, and we are looking for these nav links, of course. And now let's actually also select the logo, and we could select it manually also by its class name, but let's just suppose that there are many navigations on this page. And so again, to make the solution really robust, it's best to simply move up to the closest parent, in this case the navigation, and then from there we simply search for an image. All right, and so this then will work not only on this navigation, but it would work also on others. So this selector here is simply for any image which has the image tag. Okay, all right, so we have all our elements selected. Now we just need to change the opacity, basically of the siblings of the selected link. So siblings.forEach, and now we actually need to do that comparison that we did before. So checking if the current element is not the link itself. Because of course this sibling here, so these siblings, they will contain our initial link as well. Okay, so it needs to be different from link. And actually here we need a query selector all, right? We want all the links, not just the first occurrence. Okay, but then for all the others that are not the original link, we want to change the opacity to 0.5. And indeed, we want to do the same with the logo. So logo.style. And let's see what we have already. And you see that it works, right? Beautiful. Now, the thing is that, of course, it doesn't go back. So once we have it at 0.5, it will not automatically go back to the opacity of 1, which is the original one. You see? So when I hover this, all the others become 0.5, but as I move out, then everything remains the same. Okay? And so that's why we have this mouse out event to basically undo what we did here. So let's take all of this, paste it here, and change this to 1. All right. And so let's see what happens now. And yeah, everything goes back to 1. And so this actually works. Now, of course, it doesn't work with the logo because this entire effect only works if the target contains the navlink class, right? But that wasn't the point anyway. We just wanted this to work on any of the links. And notice that this button here is actually also a link element, and so it also works on that one. All right. So our effect here is actually working already, but this is of course very repetitive. So the code here is always the same, and so we need to make our code a little bit more dry here, of course. So let's refactor this code. And usually refactoring works by creating a new function. And so let's do that here. Of function, and we will need some arguments here, but more about that later. So what we need to do now is to compare these two pieces of code that we are trying to refactor, and then figure out what is the same and what is different. So in this case, that's pretty simple. So all that changes is that here we have the opacity 0.5, and here we have the opacity of 1. And so we can simply take this code and create an argument or a parameter for that opacity. And we can then pass that opacity into the function. All right. So of course we also need the event here. So that's going to be the first one. And then we need the opacity. And so here we simply replace that by opacity. Okay. And so like this, we refactored our code very nicely here. But now, how do we actually use this function here? So usually when we have the event handler as a separate function, all we do here is to pass in that function, and then it's going to work just like this, right? So we have done this many times throughout this course, right? But now the problem is that we actually want to pass in values into this function, right? So we need to tell this function to use the opacity of 0.5 in this case and of 1 in this case. All right. Also, we need a way of passing this event. So right now, none of this would work. So let me show that to you. So not clicking, of course, but you see it would not really work. Okay. So maybe you would think that we could do this. So like maybe passing an event here and then 0.5, which is the opacity that we want. But this, of course, is not going to work. So the first problem is that E is, of course, not defined. But the main problem really here is that addEventListener here expects a function. So we need to pass a function. But if we call the function, then all of this here will become some other value. In this case, that's undefined because we don't return anything from this function. All right. And so this is simply not going to work. So we talked about this many times, but it's always good to remember that JavaScript indeed expects here a function and not just some other regular value, which would be the result of calling the function like this. Now the solution to this problem would be to still have a callback function here, like a regular one, which JavaScript will then call for us whenever the event happens. And then in here, we could then actually call this function with the event, which is this one, and then our opacity, so 0.5. And so this works because here we are basically calling the function manually. So this will only be executed as soon as JavaScript executes this function value. And so here we are back to working because here we are back to passing in a real function. Okay? And then let's right away do the same here. Set it to 1. And now it should be working again. And it does indeed. Okay, so that is the second version of our code working, but we can actually do even better and remove these anonymous callbacks functions here altogether. So this looks a little bit ugly, right? Like having just this one function, which in turn will call another function. And so as I just said, we can do even better, and that is by using the bind method that we already studied before. So remember that the bind method creates a copy of the function that it's called on, and it will set the this keyword in this function call to whatever value that we pass into bind. Okay, so let me just do that here in practice. So handle hover and then dot bind. Okay, and I think we actually already did an example like this. So using bind in an event handler. And so let's set 0.5 here just as before. All right, and now let's do the same here. So handle hover dot bind and then 1. And so this is going to work because this is going to be also a function, because bind, remember, returns a new function. Now in this function, the this variable will now be set to this value, so to 1 here and to 0.5. And so let's check that out. So the this variable, okay. And so now you see indeed that it is either 1 or 0.5. All right. Now remember that usually the this keyword is equal to current target. So let's also check that. Okay, but current target will of course remain unaltered. So you see that it is still of course the navigation element. Okay, so by default the this keyword is the same as the current target, so the element on which the event listener is attached to. But when we then set the this keyword manually, of course it becomes whatever we set it to. And so now, just like before, we can use that this keyword and use that here. All right, because the this keyword is now our opacity. And so essentially, we used the bind method here to pass an argument into a handler function. So let me just write that here. Passing an argument into handler. And I'm using quotes here because, of course, this is not really an argument. So in fact, we don't even need this here. And in fact, it is impossible to pass another argument into an event handler function. So any handler function like this one can only ever have one real argument. And so in this case, can only ever have one real parameter, and that is the event. But if we want to pass additional values into the handler function, then we need to use the this keyword like we just did here. And if we wanted multiple values, then we could, of course, pass in here like an array or an object instead of just one value. So this is kind of a workaround into the fact that the handler function can only take one argument. So it's a really nice effect, and as I said in the beginning, it also taught us how we can pass arguments essentially into handler functions. Let's implement another pretty common feature on web pages, which is that the navigation bar becomes attached to the top of the page after we scroll to a certain point. And this is called a sticky navigation, and so let's build one for our site. So the effect that I'm talking about is this one. So as we scroll down, once we then reach a certain point, the menu bar here becomes attached to the top of the page. And once again, I'm sure that you have seen this in many pages that you visit. Now let's just check out the HTML here, just to see how this works. So we make this navigation sticky basically by adding this sticky class whenever we reach a certain position. And so this sticky class, as you can see here on the right side, all it does is to set the position to fixed, and it also changes the background color to this transparent. So you see that we can actually see through this navigation a little bit, which gives it a really cool effect. Okay. So sticky navigation. And to implement this, we're going to use the scroll event for now. So there's actually a better way of what we're going to do in this video, but let's start by working with the scroll event now, because sometimes that's good to know as well. So the scroll event is available on window. All right, so not document, but really window dot add event listener and then scroll. Okay, so this event will be fired off each time that we scroll on our page. Okay, and let's start by taking a look actually at the event, just so you see that it actually fires each time that I'm scrolling. So I just scrolled this little bit and it already created all of these events. So it fired all these times. So the scroll event is not really efficient, and usually it should be avoided. But again, for now, let's use that. And now let's start by getting our current scroll position. So let's use window.scroll y, just as we learned before. And so this scroll position here is really on the window object and not at the event. So in the scroll event, this event object here is actually pretty useless. We don't even need it here. Okay, so let's just reload here. And so as we scroll, you see that each time the event is fired, we get the current scroll position. And remember that this is the position basically from the point in the viewport, so this point here, to the very top of the page. And that's why in the beginning we start at 0, because now the visible part of the site is exactly also at the top of the page. Okay, so remember, to make the navigation sticky, we will add that sticky class that I showed you earlier. But now the question is, when exactly should the navigation actually become sticky? Well, it should happen here as soon as we reach the first section. So basically as soon as we reach this position. So this line here marks the beginning of the first section. And so when we reach this position, we want to make the navigation sticky. Now, of course, we're not gonna like hard code the value here. So I could take like 565, but that doesn't work because the size of this element that comes before is actually dependent on the viewport size. So if I do this, then you see that the first section starts way earlier. So like at 300. And so we cannot hard code the value, and therefore we need to calculate it dynamically. So how do we do that? Well, remember that we can determine the position actually of this first section. So let's do that. And I think I already have it selected up here. Yeah, so section 1, which is this one. So we need to do this outside actually of this event handler. So that section 1 dot get bounding client rect, remember. And so let's call this initial coordinates. So just coords. And take a look at it. And so now we get this current top value here. Where is it? Ah, right here. So we get the current top value of this section. And so we can now work with that. And it's even better if we do this when scrolled to the top, because then basically this top position here is all the way from the top of the page all the way here. So all the way to the beginning of that first section. Okay, and so let's now use this value to add our sticky class. So we can say that whenever the window.scroll position in y is greater than the initial coordinates at the top, then we want to add this sticky class. Right? And if not, then we want to remove it. So I can use nav here because I already selected it in the previous lecture. So nav is of course this entire navigation bar that we also work with in the previous lecture. So remove here. And here indeed we need a new line. And so now that works. And so let's check this here. And wait for it. And indeed, now it's here. So now the sticky class was added because we reached the position in the page which is greater than the distance of this first section from the top. All right. So this works just fine now, but as I mentioned before, this is pretty bad for performance. So using the scroll event for performing a certain action at a certain position of the page is really not the way to go. And again, that's because the scroll event here fires all the time, no matter how small the change is here in the scroll. And so that makes for a pretty bad performance, and especially on mobile. Like on a modern computer, of course, you're not going to notice anything. But if you're using this page maybe on an older smartphone, then it's not going to be so nice. All right. And so in the next video, we're going to look at a better and way more efficient tool, which is the Intersection Observer API. All right, so let's now implement the same sticky navigation that we implemented in the last video, but this time using the new Intersection Observer API. But what actually is the Intersection Observer API, and why is it so helpful? Well, this API allows our code to basically observe changes to the way that a certain target element intersects another element, or the way it intersects the viewport. And so from this definition alone, I think you can see that this will actually be useful in implementing our sticky navigation. But let's actually start this video by learning how the Intersection Observer API actually works, but without our sticky navigation, because at the beginning, this can seem a bit intimidating and confusing. Okay, so to use the intersection observer API, we need to start by creating a new intersection observer. So that's intersection observer, just like this. And then here we will have to pass in a callback function and an object of options. But let's leave that for a bit later. Okay. So let's first store the result of calling this function into a new variable. So let's simply call it the observer. And so now we have to use this observer to basically observe a certain target. So observer, and then the method we call on that is observe. And then here the target element. And this one will be section 1. And so this is an element that we already selected before. So this will make a bit more sense once we actually create the callback and the options here. And let's start by the options. So const, let's call it the observer options. So ops options. So this is going to be an object, and we can also already create the callback function. Let's simply call this observer callback. All right. And of course, we could have created these right here, because this is where we will now pass them in. So first the callback, and second the options. Okay. And so once again, we could have written the function and the object directly in here, but I think it's a bit cleaner to have them separately. So let's now start with the options here. And so this object needs first a root property. And this root is the element that the target is intersecting. So again, this here is the target, and the root element will be the element that we want our target element to intersect. And again, this will all make more sense once you see this in action. So we could now here select an element, or as an alternative, we can write null, and then we will be able to observe our target element intersecting the entire viewport. All right. So basically this entire rectangle here, which shows the current portion of the page. Okay. And then second, we can define a threshold. Threshold. And this is basically the percentage of intersection at which the observer callback will be called. So this callback here. So again, that's very confusing. Let's just set it to 10%, which is 0.1. And then when we have this callback function here also created, then we will see what actually happens here in practice. All right. So this callback function here will get called each time that the observed element, so our target element here, is intersecting the root element at the threshold that we defined. Okay, so take note of this, because this is actually a bit hard to figure out from reading the documentation. And so it's a good idea to keep notes of what I'm saying here. So in the current example, whenever the first section, so our target here, is intersecting the viewport at 10%, so the viewport because that's the root, and 10% because that's the threshold. So whenever that happens, then this function here will get called, and that's no matter if we are scrolling up or down. All right. And this function will get called with 2 arguments. And so we can specify them here. And that's the entries and the observer object itself. All right. So this object here basically will also get passed into the callback function. All right. Now in this case, we're only interested in the entries, but sometimes using the observer is also useful. Now we can have actually multiple thresholds. So here we can have an array, and I will do that in a minute. And so these entries here are actually an array of the threshold entries. Okay. And so in this case, again, there's only one element there, but let's create a more general function already, which basically loops over these entries so that we can take a look at all of them. And so let's just do that. So basically simply log them to the console, and that will already be good enough for us to take a look at how this all works. So entry, and so you see I'm using an arrow function here, but of course any other function would work just the same. Let's give it a save now, and you see that already we get an intersection observer entry. And so that is this entry here. And so this is not really interesting yet, because this is just the first one that we got, and we see that the ratio here is at 0, but let's see in a second what that actually means. So I will start scrolling here, and you see that now we actually got our first real entry here, which appeared here because our target element came into the viewport. So our target element is this whole H1 that's down here, and so you see that it started intersecting the viewport. Okay, and so our observer is observing that. And so now here you see that the intersection ratio at the time that this callback here was called, so this one here, was at 0.10 and then this. And so that's exactly the 10% threshold that we defined over here. All right, we also get this is intersecting property, which in this case is true. And that is because indeed our target, so again this whole section here, is now intersecting the viewport. And we are looking for the viewport, remember, because we set the root to null. All right. So we also get the target itself here and a couple of other stuff, but the intersection ratio is actually the most interesting one, and also the is intersecting here. Okay, so let's scroll down a little bit more, and let's close this actually, and let's scroll up again. And so again, we get a new entry here. And so again, it should be close to 10%, but now it happened as we were moving up, right? And so again, it was at 10%, but now it is no longer intersecting, okay? And it's not intersecting because the threshold is at 10. And so now less than 10% basically of our target here are inside of the root, so inside of the viewport. All right, and so you can start to see why this is more efficient. So it's because we only get this kind of event here in the situation that we're actually interested in. So in this case, that's this threshold of 10%. Okay, and as we keep scrolling here, now it will come back again, and now it is again intersecting. Let's keep scrolling, and all of this here is section 1, and now we got another one. So let's see. And so now it is back to not intersecting, and because now we no longer have 10% visible. Okay, so you can think of this threshold here at the percentage that we want to have visible in our root, so in our viewport in this case. And so right now we are back to having less than 10%, and so it is no longer intersecting here. And again, if we scroll up a little bit more, then we get another event here, because now we are back to having 10% intersection ratio. Okay, so this is the very fundamentals of how the Intersection Observer API works. And I confess that it is a bit confusing, and it took me quite some time to figure all of this out. And so probably the best idea is for you to stop this video now and explore this a little bit on your own. So you can use different threshold values and maybe use different targets here. You can even use different roots. And so it would be a good idea to experiment a little bit more with this. Now what I'm going to do here is to now specify an array. So to specify different thresholds, and one of them is going to be 0 and the other one 0.2. So that's 20%. So 0% here means that basically our callback will trigger each time that the target element moves completely out of the view, and also as soon as it enters the view. Okay? And so that's because the callback function will be called when the threshold is passed when moving into the view and when moving out of the view. And this is really important to remember here. On the other hand, if we specified 1 here, like this, then that means that the callback will only be called when 100% of the target is actually visible in the viewport. So in the case of this section 1, that would be impossible because the section itself is already bigger than the viewport. But let's now experiment with 0, and let's get rid of this here. But let's now experiment with 0 here. And so right away, we again get this event here. And you see that the intersection ratio is exactly at 0, but it is already intersecting. And so it's because basically the threshold here was already passed. All right. So I think another one happened there. Let's just reload. Oh, and that was probably from our 20%. Yeah, so you see, this is the 20 threshold, the one that we set here now. And so this one now happened a little bit later than before, because before it was happening at 10%, but now only at 20. So that's a bit later. Let's just clear this and keep scrolling. And so now the section is almost scrolling out of view. And you see, we now get this 20% here. So a bit less than 20%. And as we keep scrolling, then as this line hits here the top of the viewport, we should get another one, which is when this 0 here is again reached. So let's try that. And indeed, here it is. So we are back to intersection ratio at 0, and the element is no longer visible. All right. So this is how the intersection observer API works. And let's now quickly use this in order to implement our sticky navigation. Because at this point, I'm sure that you can already imagine how this can be very useful for implementing this in an easy way. So let's think about this. When do we want our navigation to become sticky? Well, we want that to be happen essentially when the header moves completely out of view. So basically all of this part here, which is the header, when we can no longer see it, that's when we want then to display the navigation. Okay, and so this time we are going to observe the header element. So let's start by selecting that. And it is an element with the class of header. All right, let's actually get rid of this part here. Okay, and now let's create our observer. So this time I'm calling it the header observer, just so we know exactly what is being observed. So new intersection observer, and then I'm going to pass in the arguments later, and then I will use the header observer to observe the header. Okay, so this all kinds of sounds like normal English sentences if we read it like this, right? So here we again need a callback function. So let's just call this sticky nav, actually, and then again the options. Now this time I will just create the options object right here. All right. And so the root will once again be null because we are again interested in the entire viewport, and then the threshold. So I said that we are interested in showing the sticky navigation as soon as this header scrolls completely out of view. So what threshold does that mean? Well, that's just 0, right? So when 0% of the header here is visible, then we want something to happen. Okay, and now let's define this function here. And here we will have exactly the functionality that we want to happen. So to add and to remove the sticky class. So this function gets the entries, and this time I'm not going to specify the observer because in this case we don't need it. Also, there is only one threshold here, so I don't need to loop over the entries. We can simply get the first one, and let's actually use destructuring to get the first element, so entry, to get the first element out of entries. And remember that this is the same as writing entries 0, right? So let's just start by taking a look at this entry just to see if it works. And here, one more time, we already get something. So I'm not sure why that is actually, because this has nothing to do with our threshold. All right, but let's just wait for the next one. And so it should be appearing soon because our target, so this header, is almost moving out of the view. And indeed, here it is. So intersection ratio is 0 and it is no longer intersecting. And so now let's actually create the logic of adding and removing the classes. So basically what we want to do is to first add it here. And so let's start with that. But you see that now it actually already applied this class. And that's because right now our target element is intersecting the root, so the viewport. All right, so we will use that in a second. Let's just see what happens next. So here we will now get our next one, right? And so now it is no longer intersecting. So intersection ratio 0, but no longer intersecting. And so this is actually the condition that we are interested in, right? So only when the header is not intersecting the viewport is when we want to add that sticky class. Because watch what happens when we move back up. So right now, you see we got this new entry here. And so in this case, it is again intersecting. And in this case, where we are scrolling up is when we actually want to remove that sticky class, right? So we are entering the header again. And so that's the point in time where we want the sticky class to be gone. And so now we can use this intersecting property to do exactly that. So we can say that if the entry dot is intersecting is false, basically, then do this, right? So again, when the target is not intersecting the root, then we want the sticky class to be applied. And else, we want to remove it. So let's reload. And now, indeed, the sticky class is no longer there. Okay, and now watch what happens as this line reaches the top there. Then, yeah, here it is. So there is our sticky navigation. So that's great. And indeed, it is because it is now no longer intersecting. And so now the final test is when we move back up, then it is gone. And so as we scroll around this point, it will basically add and remove the class according to the scrolling direction. Now we're actually not really done yet because I want to make this a little bit different or a bit better. So let me show you the demo here. So just to make sure, I'm going to reload it here. Never mind this effect you just saw here, but watch when the navigation comes in here. So you see when that happens, it's basically when the distance between the start of the section and the viewport here is just the same as the navigation. You see that? And so like this, the navigation doesn't overlap this section here right in the beginning. So here the navigation comes exactly before the first section starts. And so let's implement it here as well. And thankfully, that's pretty easy to do. And we can do it by specifying another property here, which is the root margin. Okay, and this root margin here, for example, 90, is a box of 90 pixels that will be applied outside of our target element, so of our header here. Okay, and so now it is as if the header did not stop right here, but instead out here. All right, so as if the header went all the way here. Now we actually want the header to basically stop here. And so that's minus 90. Okay, and here we then need to specify also the unit, which has got to be pixels. So unfortunately, percentage does not work, and also rem does not work. So it has to be pixels. And so that's why I'm using 90 pixels here. And 90 is the height of the navigation. And so let's test this here again. So let's see. And so let's wait for it. And did you see that? Indeed, now the navigation appeared exactly 90 pixels before the threshold was actually reached. So you see, now we get the event here even later, and all the data here is still the same. This is simply a visual margin that gets applied. So you can play around with this as well, with the difference between a positive and a negative margin to figure out really how this works. Because this root margin here is very important to specify correctly, as we need it in many situations. Now, just as one final detail, let's actually calculate this height here dynamically. And for that, we can use again the getBoundingClient rect function. Because, for example, if you have a responsive site, then probably the size of all your elements will change at certain points. And then it's not a good idea to have this 90 pixels here hard-coded right there in the code. Let's just take a look so we see what we actually need to get. So this is the rectangle. And so here we actually have a height property. So this is where that 90 comes from. So let's read that directly here. Height. All right. And so now here we can use that. Let's create a nice template string here. Nav height. And with that, I believe we're actually done. All right. And of course, this works no matter how large or how small the viewport is. Okay, now it works beautifully and correctly in all situations, and this is a lot more performant and a lot better than the solution that I showed you in the previous lecture. So play around with this, but we will actually also have, I think, 2 more examples with the Intersection Observer API coming up. And so that's going to be another great opportunity to learn how this API really works. Because it's quite important actually to do things on certain positions on the page. So things related to scrolling. Let's implement another really cool and modern feature using the Intersection Observer API. And this time we're going to reveal elements as we scroll close to them. And this effect can give your pages a very nice touch, and you can in fact easily implement it without any external library. So the effect that I mean is this one here with the sections. So watch what happens here. So you see that we basically reveal each section as we approach it. All right. So I'm not talking about these images here yet. So I'm just talking about the sections. So see how it basically slides in like this. All right. And so that's what we're going to do now with all these 4 sections. Now the animation itself actually comes from CSS. And so once more, we will actually achieve this by simply adding a class to each of these sections as we approach them. And so we will do that using the Intersection Observer API once again, because that's really the perfect job for this tool. Okay, so let's actually take a look at our CSS here. So I'm going to write or to search for a section hidden. So this is the class here. And so basically all the sections by default have this class. So let me show that to you also. Well, actually they don't. And of course they don't, because then we could not see them right now. Okay, so we have to add them now as we build this. And so this will basically give them an opacity of 0, and it will move them a little bit down. And so then when we remove this here, it will then move them back up to a translate of 0 rem, basically. Okay, so what I'm gonna do is to start by adding this section, or this class actually, to all the 4 sections that we want to apply this effect to. So this one here, then the next one, number 3, and number 4, yeah. And so now all of them will disappear, okay? They're simply invisible. They're still there, so we are still like displaying them, and so they preserve their height, basically, but they are now invisible. And so our job is now to remove this class as we approach each of these sections. So reveal sections. So let's say a section observer, new intersection observer, and then here the callback, and let's already create it here. Let's call it reveal section, like this. Entries, and this time we will need the observer, and you will see in a minute why that is. So observer, and of course these parameters here, as always, can have any name that we want, right? So just like in the callback functions of the array methods, where we can also give them any name. And here it's the same, but this is kind of the standard, and so that's why I keep doing it like this. So reveal section, and then the object of options. So we want to observe all the 4 sections actually in this case. And it is indeed possible to observe them all using the same observer. So let's select all the sections, and then we will observe these as multiple targets, all using this observer that we just created here. So all sections is document.querySelector all. And so that's simply the class section. And now we can loop over this node list with for each. So we use for each whenever we want to do something which does not involve creating a new array. And so here the callback function, I will call it section. And then just like before, we will use our observer to observe section. And actually, since we're already looping over all these sections, it would probably be a better idea to add this class here, so the section hidden, also using JavaScript. So not do it manually here in the HTML, and instead do it in JavaScript. Because some people actually disable JavaScript in their browser, and then for those users, the page wouldn't really be visible, right? They would then have no way of removing this class. And so this is probably not a good idea. So I will copy it now, and then I will just undo everything we did. So yeah, so now it should be back to normal, and it is. And now I will do that programmatically here. So that's a lot better. Don't know why I didn't think of that right away. So class list add, and so this is nothing new at this point. Let's see, and now they are back to being hidden. So let's start by taking care here of these options. And as always, the root is going to be the viewport, so null, and then the threshold. We will set it to something greater than 0. And that's because we don't want to show the section right as it enters the viewport, but a little bit later. So let's say 15%, for example, for now. So this will make it so that the section is only revealed when it is 15% visible. All right. So this is all of the setup. And now let's create basically the logic. So in here. And once again, we have only one threshold. And so let's get that entry from the entries using destructuring. And as always, let's start by logging the entry here. Give us some more space. This 90 is coming from up here, so we don't need that anymore. Okay, and so now we see that some section here is already being intersected at 0%. And so now actually this target element will become important. And well, right now there is no target because this first, so to say, event is always triggered no matter what. So let's scroll a little bit until 15% of the first row is intersected. And of course, that intersection happens even though we cannot see it. So we don't see the row, but still it is now 15% intersecting. And now the target here is actually important. And so here we actually have the class name. So section and section hidden. And so this means that actually a certain section did now intersect the viewport. Maybe we can see the ID. Oh yeah, here it is. So it was the section 1 indeed. So the one with the ID of 1. And this target will now actually be important because now we want to make exactly this section visible, not all of the sections, right? But we are observing all of the sections here with this same observer here, right? And so now we need a way of knowing which is the section that actually intersected the viewport. And so that's what we can use the target for. And so let's do that. So that's at entry dot target. And now we can, as always, manipulate that class list and remove this section or this class that hides it. And you see that it's already working. Well, it actually happens a bit too soon, it appears. But on this one, it was perfect. Let's see the next one. And again, it worked just fine. And the last one as well. Let's try again this one here. And for some reason, it's already there. And I guess the reason for that is this first entry here that always gets printed in the beginning. So yeah, you see that the target here is actually this first section. Now it is not intersecting, and so let's now use that to our advantage. So we only want to trigger this removing here when the section, so when the target is actually intersecting. So if entry dot is intersecting, then do this. And actually, I'm going to use another guard clause here. So I will do the opposite. So I say, if it's not intersecting, then return right away. Okay? But if it is intersecting, then the function will not return, and simply the rest of our code is going to be executed. So let's try that one more time. And now you see it's not yet visible, but it will become visible soon. And there it is. Beautiful, and it still works. All right. So that's a really nice effect, right? We can just do one more small improvement, which is to now unobserve these sections. Because you see, as we keep scrolling, the observer keeps observing the sections. So you see, as we keep scrolling here, more and more of these events keep getting added. but in fact, they are actually no longer necessary because we already did all the work that we wanted. And so we can now unobserve. And so that is again by doing observer.unobserve, so the opposite of observe. And then again, we need to pass in which element should be unobserved. And so in this case, that comes from entry.target. So let's see what happens now. So the first time, of course, we get these logs here because, of course, work is being done. But right after that, each of these sections is being unobserved. So let's go to the end here. And when we clear this now and keep scrolling, you see that we get no more events here. And so that means that none of this section is being observed anymore. And so that's going to be even a little bit better for our performance. All right, and that's actually it. So another really cool use case of the Intersection Observer API. One of the most important things when building any website is performance. And images have, by far, the biggest impact on page loading. And so it's very important that images are optimized on any page. And for that, we can use a strategy called lazy loading images. So let me show you now how to implement that strategy in JavaScript. And the effect that I'm talking about is this one. So watch for what happens with the images in this section here. So you see, as we approach it, it basically starts to load. And then once it's finished, it will get displayed. And that placeholder, which is there in the beginning, gets replaced. So you see that? So let me quickly show you in the HTML how we implement that. Oh, and we're actually already here. So it's these features here. And so each of these features has an image. So the main ingredient to this lazy loading strategy is that we have a very low resolution image, which is really small and which is loaded right in the beginning. So that's this image here. And you see that the dimensions are only 200 times 120 in this case. So let's actually take a look at that image here. And so you see it's really small and it's only 16 kilobytes, while the real one, so this one called digital, is almost half a megabyte. So that's a huge, huge difference. And that image we then reference here in this data source attribute. So that's a special attribute that we can use, but any other would work as well. So this is not a standard HTML attribute, but instead it's one of these special data attributes that we can do ourselves. Okay? And so basically the idea is to, as we scroll to one of these low resolution images, we will then replace this low resolution image with the one that is here specified in the data source attribute. And we then also are going to remove this class here, which is kind of this filter which makes this image blurred. Because without this filter, let me show that to you. Without this, it would look really terrible. So, too small to change this now here. Okay, but let's just remove it here for a second, just so you can see what it looks like. And so maybe you can see, or maybe it's too small, but notice that it's like really pixelated and really ugly. Okay, and so I created this filter basically, and so it makes it look like this. So it hides the fact that it is actually way too small for its size. All right, so let's put it back here. And so this is what this class looks like. It's simply a blur filter. And so modern CSS allows us to do this really cool effect. Okay, so let's implement this. And that's actually not too hard, using the Intersection Observer API one more time. So lazy loading images. And so once again, this one is really great for performance, while the other things we did so far are more visual things, this one really impacts how your site works, and especially for your users who might have a slow internet connection or a low data plan or a slow cell phone. And we always have to think about these users as well. Not everyone has a super high-end computer or the latest phone. All right? Anyway, let's start by selecting our images. So let's call them image targets. And this selector is going to be a little bit different this time, because we don't want to select all the images. So we could simply do a selector of image, and that would then give us all the images. But however, not all of them are going to be lazy loaded. For example, this one here, or we have some down here somewhere. Yeah, so these avatars here, or even this logo. So these are not lazy loaded. And so the ones that will be lazy loaded are the ones that have this attribute here. So this data source attribute, because that's where we specify the real high resolution picture. And so we can actually select for elements which contain this property. So if you're familiar with CSS, maybe you know how to do that. But in case you're not, this is how it works. So we select all the images which have the property of data source. Okay, and that's it. So let's check that, just to be sure, so that it's going to work. And so indeed, here we have these 3 images. Okay, and nothing else. Then let's create our image observer. And so this is now always the same. Here our callback function, which I'm going to call load image in a second, and then our options. And now let's attach this image observer here basically to all these targets. Okay, so I'm going to loop one more time over our targets, just like we did with the section previously. And this time let's actually use an arrow function, because all we want to do is to use the image observer that we created previously to observe each image. Now let's create that callback function here also pretty fast. So it gets the entries and also the observer. Now, okay, as always, starting with the options here, and again the root set to the entire viewport. And let's start with the threshold at 0. And then we can adjust it as we go. But what matters really here is this callback function. So as always, this is where our functionality is. And so again, we have only one threshold, so only one entry. So I'm getting that here. And now let's check out actually this entry. Okay, so here we already got 3 of them, but all of them are not yet intersecting. Or actually it says that this one is. Well, but it isn't really, because it's down here. So that's a bit weird. Oh, but of course, this still comes from the sections. So this is still coming from up here somewhere. Okay, let's delete it here from the sections. And now let's see if it's working. And now it is indeed an image. Okay, now it appeared a little bit before, and that's because remember that our sections are actually a little bit shifted, right? Because of these hidden class that we added to them, they are shifted 8 rem down. So remember that from here. Let's see. Yeah. So because of this translate here, they are moved 8 rem down. And so then therefore this event will fire a little bit early, but that's not a problem at all. All right. What matters is that the event fired correctly and that it is indeed intersecting. Let's just clear it here to wait for the next ones. And so here you get the next one already. And so that is indeed this next lazy image here. And then the next one here as well. Oh, so this one. Okay. And then as we're moving out of them, then we get even more, because now they're no longer intersecting. And so once again, we need to only do something if they are actually intersecting. So we're going to use the same guard clause as before. So if they're not intersecting, is intersecting, then we want an early return. But otherwise, we now want to replace the source attribute with the data.source, right? So as we reach the image, it's finally time to replace the placeholder image, which is at the source, with the one we actually want, which is data source. So just like before, each of these images here is at target, or actually at entry.target. So that's the element that's currently being intersected. And then .source equals entry.target.dataset. Remember, that's where these special data properties are stored. And then .source from there. Okay. So this is already the main functionality right here. So let's try that. But you will not really see it happening because there's still this blurry filter here on top. But if we inspect this now, we should already see that the source is now actually already the original image. So you see that it's the really big one, while the other ones are still the lazy ones. Well, at least this one. The second one is already also the original one, because it's already in the viewport too. All right. So that's great. That's working just fine. Now all we need to do is to then remove that class that has this blurred filter. So that's the lazy image class. Now, how do we do that? Well, it's a little bit tricky because this replacing of the source attribute actually basically happens behind the scenes. So JavaScript finds the new image that it should load and display here, and it does that behind the scenes. And once it's finished loading that image, it will emit the load event. And the load event is just like any other event. And so we can just listen for it and then do something. So on that image, so that's entry.target, we can do add event listener and listen for the load event. Okay. And actually, let me show you why it is important that we do this. So let's say that we removed that lazy image class right away. So entry.target.classlist.remove lazy image. Let's scroll up here, reload. And then, well, in this case, the loading happens so fast that we don't even see a problem. Maybe we can change that here in the network tab. So this is a completely new tab, but what we can do here is to simulate or speed. So this is a bit too big here actually, I guess. So I'm not used to this size. Let me make it a little bit smaller. So let's change it here to fast or to slow 3G. And maybe then we can see what happens. So it's now faking that these images are loading really slow. So did you see them here blurred now? So it's really blurred. You see? But we already removed the filter. And so here you can see how the image is loading basically in the background. And so it's doing that really slow now because we said that we are on a slow network here. And now you see it's finished here, and now the original image is being displayed. So hopefully you could see that. I'm not sure if the resolution of the video is going to be good enough to see it, but I did for sure see it. And here actually now the same is happening. Let me increase the size of the window a bit maybe. So you see it's pretty blurred, but once it's going to be finished, you will then see the final and beautiful version showing up here. All right. So we're going to come back to this network tab later when we start loading data from remote sources on the internet. So this is a very important tab in the browser tools. But for now, it's also nice to see the images loading over time behind the scenes. Well, it's taking a lot of time. So let me just go back to the code here. And so, yeah, now it's finished actually. And so by the time this loading finishes, it will emit this load event. And so it is best to then only remove that blurry filter once that is done. All right. So it's loading again, very slow now. And you see that now it keeps being blurred and it will only disappear once the image is in fact loaded. So I'm not going to wait for that because it seems like it's going to take forever. Oh, actually it's already done here. And so you see now the image is done loading and at the same time the filter appeared or actually disappeared. Let's set it back to online. And so now all of it happens basically at the same time because we are working on our local development machine. And so there, of course, the image basically arrives instantaneously. Now, as a last step, we can just, as we did before, stop observing these images because it's no longer necessary. We already did our task of loading, and so we no longer need this. So entry.target, and that's it. So I hope that with this video, I could convince you that it's really important to implement this kind of functionality into your own sites. So all you really need to do is to generate these placeholder images and blur them a little bit, and then implement this kind of logic, which really shouldn't be too much work, right? Let me just get rid of this console.log here. Let's load it again, because actually we want probably to load the images a little bit before we actually reach them. So ideally, we don't want our users to notice that we are lazy loading these images, right? So all of this should basically happen in the background without our user noticing that. And so we should probably make these images load a little bit earlier. So to do that, we can again specify a negative root margin here. So root margin of, let's say, minus 200 pixels. All right. And so this is just the same as we did previously here with the navigation. So to make the navigation load a little bit before the threshold was actually reached. And here we are doing the same. So exactly 200 pixels before any of the images is loaded, it should already start loading. And by doing that, we don't see any delay in loading when we browse the page. Well, actually, that didn't quite work. Maybe it should be plus 200. So as you see, this is all a matter of trying out and figuring out as we go here. And so now, indeed, as we approach the images, they're already fully loaded. So now that happens 200 pixels before we reach them. All right. And with that, our functionality here is complete. And we are now indeed almost finished with this project. All that's left to implement is really this slider. So this component here. And so that is what we're going to do in the next video. Let's now build the really cool slider component. And this is going to be a lot of work. So we're doing that in two parts. And so here goes part 1. So this is what the final version of the slider looks like. So we can click these buttons here to move between the slides, and you see that also the dot down here then changes. And as we reach the last slide, as indicated by this last dot, if we then go to the next one, it will basically go back to the first one like this. And of course, we can also click on the dots like this. All right. So let's now understand how this is actually implemented in terms of HTML and CSS, because as always, that's a very important aspect to make this all work. Okay. So this is the slider component, and then each slider has a couple of slides. So 3 slides, and they are in fact all side by side. So we have slide 1, make this smaller here because the content doesn't really matter. So we have these 3 slides. And so you see here by this blue area that they are all side by side. So here in the slider, we can turn off this overflow property, which is set to hidden. And then you can actually see the next slide already waiting there, basically. So what happens when we click this button is that all the slides move a little bit to the left side. So watch. And so you see that now the first slide is here, the second is in the middle, and the third is right here. And that happens by using this transform CSS property, which we then set to translate X. And then here we define these values to basically move each of the slides as we click these buttons. So watch what happens here in these values as I click. And so now the last slide here is basically at 0%, the one before is at -100, and the one before is at -200. So minus is basically to the left, and the width of each slide is 100. And so basically, this is all we need to do in order to make the slide work. So basically adapt these percentages here as we go. So you see that now the first slide is at 0%, then the other one at 100, and the third one, which is all the way to the right side, is now at 200%. So this is basically the starting position of the slider. And let's compare that to what we have currently in our slider. So we have all of the slides basically on top of each other right now. And so the first thing that we should do here is to basically establish this initial condition where they are all side by side. So like this. And so what we're going to do on each of them is to set this transform property to these percentages. But of course, all automatically. So let's start here with our slider. And as always, I'm going to start with some selections. So starting with the slider, or actually with the slides themselves, so that we can then manipulate them. So document.query selector all. And so that's a slide. So with the class of slide. And we can also, of course, see that here in our own HTML. So you see, here we have the slide. Now the content that is inside of each of these slides is completely irrelevant for our purposes. All right, so all we are concerned with is the slider element and then this slide. So this one and all the others. So I can collapse these just to see. And so, yeah, we are only going to be concerned with the slides. And then you can maybe use this for your own projects in the future and put whatever you want inside these slides. For example, you could just have images or really anything that you want. And in fact, that's what I have down here. So here I only have some images. And maybe we should actually work with that. So let's actually try that. So I will comment out this part. So not really sure how that works anymore. Now, okay. And so now let's make this actually visible. Just to see. All right. So these are our slides now, but once again, they are all on top of each other. And we can see that here when we inspect them. So indeed, all of these slides are in the same position. And so let's create that starting condition that I mentioned a minute ago. So putting all the slides side by side. So let's take the slides and we're going to loop through them and set the style on each of them. So let's create a simple arrow function here. And the parameters I will just call s for slide. And then we also need the second one, which is the index. And you will see in a minute why that is. And so here we want to set the style on each of the sides. And remember, it is the transform property that we want to set. So transform. And then we want to set it to translate x. And then here is where we have to specify the value. Okay? And that value is going to be in percentages. And let me just write down here what we want. So the first slide should be at 0%. The second should be at 100%, then 200%, and then 300%. Okay? And so that's because translate x will basically move them to position 100%. So the width of each of these images is 100%. And so then the second image will start right here at the end of the first one. Then the third one will start right after the first one, which is at position 200%, and then 300. So how can we calculate these values here? Well, we can simply multiply 100%. So here we need now a JavaScript value. So we can multiply 100% by the current index. So in the beginning, that's going to be 0. So 0 times 100 is 0. And then, as you see, it will go all the way until 300, because in this case, we have 4 images, or 4 slides. But if we were working with the other slides, then that would only go to 200%, because we only have 3 slides. So that should already be enough. And now we have this problem that our sections here keep disappearing, and that's because the code we wrote earlier, so reveal sections. And so for now, let's remove this observer. All right. Well, the observer can actually stay. What we need to remove is these hidden classes. All right, so now that works. And so let's check out the images now. And we can't really see them. All right, but indeed, they have now 0%, 100, 200, 300, and so on and so forth. Let's maybe temporarily scale down the entire slider. So let's come here to, or let's do that actually here in JavaScript. So just to make this a little bit easier for us to see. So const slider is document.query selector slider. And then what I want to do is slider.style.transform and set it to scale, let's say 0.5. Yeah, so that looks a bit better. Now we just need to change that overflow that I just showed you before. So that overflow here, we need to set to visible. So also on the slider. So otherwise we cannot see the other slides, right? So let's do that as well. So overflow, and we need to set it to hidden, or actually to visible. Now, okay, let's make this even smaller actually. Even smaller, just so we can see all the images. So you see, now all the 4 of them are here, and our buttons are now really small, so they are still here, but I think we will be able to work with this. Maybe we can just move the whole thing a little bit to the left. So let's say translate x here as well. And keep in mind that this has nothing to do with the functionality. Okay, this is just so we can see what we are doing here. So this works. Or we can move it even further. And so now we can make it a bit bigger again. All right. So that's beautiful. That works for now. And then by the end, we will simply remove all of this. Okay. But now let's actually get to work and make the slider work. And so I will start by selecting these two buttons. So that's the button left, query selector. Let's see here. So that's slider button left and button right. And then simply duplicate it. Okay. So button right dot add event listener. And let's start by only working now to make the slide go right. So clicking just on this button here. And I think we're not even going to need the event for now. Okay, so this is basically to go to the next slide. So remember that going to the next slide is basically simply changing the value here in the transform property. So this translate x, all we will do is to change the percentages so that basically the slide that we want to move to is the one that has 0%. So remember that this is what we did here. So right now, the active one is the one that has 0%, and the previous one has -100, and the other 100. So again, that is the whole mechanism that we're using here to move the slides. And so this is what we will do now. So in the beginning, we are at slide 0, but then when we want to go to the next slide, we need to increase that. So let's outside here create a new variable for the current slide. So let current slide, and it is a let because we will of course then update it. So we start at 0, and then when we go to the next slide, we simply increase that by 1. All right, and so right now it is 1. And then what we need to do is to basically do the same as this, but with a small change. All right. So let's say that the current slide is 1. Then we do not want this here, right? We don't want this, but instead we want the first slide to be -100, this one 0, this one 100, and the other one 200. So how do we do that? Well, we take the current index, and then we subtract the current slide. So again, we will take this, so each slide that we're looping over, and then minus the current slide, so like this, and then this will give us exactly what we want. So again, let's say that the current slide is 1. Let's write that here, actually. And so then, as we loop over these slides, in the first iteration, this will be 0, and then 0 minus 1 will be -1. And then times 100 is, of course, -100. Then the next slide, the index is 1, and then 1 minus 1 is 0, and so that will then become 0%. And so remember that the active slide is exactly the one that we want to be 0%. And so this should now actually work. Let's see. And yeah, it is already moving. So the first part is already doing its job, but now we are kind of at the last slide here. So let's see what happens next. So it actually keeps going. So the number of slides keeps increasing, and so of course these values here also keep increasing because, well, JavaScript doesn't know that we are working a slider, and so of course it doesn't stop. We need to tell it to stop. So how can we do that? Well, the best way is to actually define the number of slides and then make it stop once we reach the last one. So let's say that the max slide, so the maximum slide where we can go, is slides.length. So basically the length of this node list here, and on node lists we can also read the length property just like on an array. So here when we define the value of the current slide, we now need to update this a little bit. And so if we are at the max slide, so if the current slide is equal to the max slide, then we want the current slide to become 0 again. And so that's how we return to the beginning of the slides. And otherwise, we will simply increase the slides by 1. Okay, so let's test that here. So everything keeps working. Now we are at slide number 3, and so we are at the end. But actually this max slide is 4. So the length is 4, but the index is 3. And so as always, that's because the length is not 0-based. And so probably it will keep going one more time, and then it will return to the beginning. Yeah, beautiful. All we need to change here is to add -1 to this to basically also make this 0-based. And so now, let's see. Well, our slider is basically already working. So at least in this direction. So this button, of course, not. But here, we can see that it's doing its job already. So that's really nice. Let's now just quickly refactor this code a little bit. So we have here basically the exact same code, or at least almost the same code as here. But we can refactor this into its own function. So let's grab this here. And I will create a function now called goToSlide. So that's a function where we pass in the slide. So basically the number of the slide where we want to go to. And then here we change the current slide to the slide that we are indicating. And here I can then call this goToSlide with the current slide. So far we didn't change anything. Just delete this comment here. And now to be able to remove this part here, all we need to do is to basically call this function here right in the beginning of our code with the slide set to 0. So this slide argument set to 0. And so what this will do is then basically once our application starts, it immediately goes to slide 0. And so that will then execute basically this code. So slide will be 0, and so I minus 0 is then of course just I. And so that's then exactly what we have here. So goToSlide 0. And so now I can delete this, and that's great. Then to make this just a bit more beautiful, let's actually also take this one here and create a new function for that. So const next slide, and then put it here. And this one doesn't need any parameters because the goal of this is really just to export the functionality into its own named function. All right. And so indeed it keeps working just as before. Next up, let's then work on this button here. And so all I need to do is to add an event listener to button left. Also click, and then I'm going to create a function called previous slide, or just prev slide. So let me create that here very quick as well. So const prev slide. And so in this case, the current slide will be decreased. And then here, I can simply reuse the same function that I already wrote before, and also with the current slide. So the functionality of moving to a slide is of course exactly the same, no matter if we go forward or upward. So all this will do is to update the transform property on all of the slides. And that works in always the same way, no matter if we're going forwards or backwards. So the main difference between the next and the previous slide is really the way in which we determined the current slide. So when we go to the next slide, we basically increase the current slide. And when we go backwards, so to the previous slide, we simply decrease it. So let's try that now. And first we need to go forward because our function there is not really complete. But in this situation, it already works just fine. But then as we keep going, we have the same problem as before, because we simply keep decreasing the current slide. And so we now need to fix that. All right. So in which situation does simply decreasing the current slide not work? So it works right now. So now it works, right? But now it does not work. And so that is in the situation where the current slide is already 0. So let's write if the current slide is 0. So in this case, the current slide should be equal to the max slide. And again, that's -1 because that max slide is not 0 based. And then else. And so now that should actually work. And indeed, beautiful. And so now our slider is actually working already. We are just missing a couple of features. So namely, these dots here, which is a little bit complicated to implement. And also in this version, we can use the arrow left and arrow right functions to move through the slider. All right, so now I'm just hitting the left button and the right button. Okay, but I'm gonna leave that for the next video. For now, let's just get rid of these things that we did in the beginning so that we can see the actual slider in all its beauty. So now it does indeed look like a real slider, doesn't it? So I'm really happy with this result, and I hope that you're as well. And of course, I wouldn't expect you to be able to write this code on your own just yet. So when we implement something like this, there is a lot of stuff to think about, and especially in this case, the most tricky part is, in my opinion, this here. And this probably comes from experience. And so at a certain point, if you practice enough, you will also be able to come up with a logic like this. So I just invite you to study this code here a little bit before we move on. And once you're done doing that, then let's move on and implement these dots at the bottom of the slider that I just showed you. Let's now continue building our slider component. And let's actually start by attaching an event handler to a keyboard event so that we can also slide through the slider using the left and right arrow keys. So let's do that after these ones here. And remember that we actually handle keyboard events right at the document. .add event listener. And then we're going to use the key down event. And so that's going to be fired as soon as the key is pressed down. And here we need the event. And let's start by taking a look here at the event so that we can figure out which keys we actually want to use. So I'm going to hit the right arrow key. And so you see that we get the key here as arrow right. And then the other way around, it is, of course, arrow left. And so I'm going to use that key, arrow left and arrow right. So that's very simple. If e.key equals arrow left, then what we want to do is to call the previous slide function, right? And so this is also a reason why I created a separate function for this. Okay, so otherwise I could also have left the entire code just here instead of exporting it into its own function. I still prefer it like this, but it wouldn't have been necessary. But now, as we need to reuse the same code here as well, then I really would have to create it its own function. Now, you might have noticed that here we also could have used like short-circuiting. So we could do e.key equal arrow right, and next slide. So this would work the same way because of short circuiting, right? At least I hope so. And yeah, it does. So I just hit the right key and here the left key. And so it works just as fine. So you can now choose which version you like the most. So I'm gonna leave both here and let you decide which one you want to use. All right, but now about the dots that I was talking about. Let's go here to our HTML, because here we actually already have a div, so an element for that. So we have the buttons, of course, these two, and then we also have this empty container in which we're going to create the dots. So let's start by selecting that element, and I'm going to call it the dot container. So that's just dots, I think. Yeah, that's correct. And so let's start by creating all these dots in there. So I'm going to create a new function here. So basically, I'm nicely organizing the entire code of the slider here into different functions. And so that's a good pattern to get used to, all right? So just so you see what these dots will actually look like. So each dot is going to be one element with the class of dots dot. And then it will have this data attribute of slide with the number of the slide that clicking the button will go to. All right. So one more time, the data attribute here holds some data that we need in order to make the functionality work. Let's actually grab this code here. So I'm copying all of it now. And so what we want to do here now is to create one element like this for each of the slides. So the easiest way of doing that is to simply loop over the slides, because then we can do something for each of them. And in this case, it's not even going to be about the slides. It's just so that we can do it 4 times, because we have 4 slides. So we have the slide again, and then the index. But in this case, we're really only going to be interested in the index. So missing the function keyword here. And actually, since we're not interested in the slides, we can again use this convention of the throwaway variable. So a variable that we don't even need. And so let's now say .container.insert adjacent HTML. So as I mentioned, this is my favorite way of creating HTML elements. And so let's say before end. So basically adding it as the last child always. And then here we need the HTML code itself. And so let me just paste that button, so that code that I copied from the demo site. And now here, all we need to do is to add the index. And so then the first button will get index 0, then 2, 3, and 4. So that in the next step, we can then read this value from here and move exactly to that slide once one of the dots is clicked. So let's check that out. Oh, and of course, we need to also call this function. So in the beginning, we need to call go to slides and also create dots. So create dots. And I will organize this a bit nicer by the end. For now, let's just leave it like this. Oh, and you see, we have the 4 dots now here. All right, let's check them out here just to see the data slide attribute. And indeed, 0, 1, 2, and 3. And now let's actually make them work. So adding another event handler here. And I like to keep the event handlers or event listeners here at the bottom. And so, of course, we are going to use again event delegation. So we're not going to attach one event handler to each dot, but instead to the common parent. And so that is, of course, the dot container into which we just added the dots. So add event listener waiting for a click. And now to actually match the element that we're interested in, we can simply now check for the class. So that's event.target.classList.contains, and then the class of the dots is dots underscore underscore dot. All right, and if so, let's just log that to the console pretty quick. So here we get dot. If we click outside somewhere, nothing happens. And then again dot and dot. All right, so let's get the slide. So const slide is equal e.target.dataset.slide. And so that's because it's called data slide. And so as always, all the custom data attributes are in the dataset and then dot this value, so dot slide. So dot slide. And to make it even better, we can now use destructuring because this value is exactly the same as this. And so we're reading from this object, and so we can simply do this. So another nice use case of destructuring right there. And so now what we want to do is to basically go to the slide that we just selected. And so one more time, it's now very handy to have this go to slide function here inside its own separate function. So go to slide, and then with the slide number that we just read from the dataset. So let's test that. And it works. So slide 2, let's see slide 1, let's go straight to the last one. And it jumped over all the others, and now we are at the last one. And of course we can combine this now with the buttons and with the keyboard arrows. And so, yeah, great. This works as well. Now all we need to do is to also show which is the current slide. So activate this dot, basically. So give it this different background color. So that's also pretty common in a slider like this. And let me actually show it to you. So all we do, as always, is to give it a special class. So the dots.active class. So let's go back and let's do that not here, but in another function, because we need this functionality in many places. So whenever we change the slide, we will also need to change the indicator here. So no matter if we click on one of the dots or if we just use these buttons here, whenever we change the slide, we want to change which slide is currently the active one. And so we're going to create a completely different function for that. And let's do it here after create dots. So activate dot. And here we need to, again, then pass in the current slide, basically. So how will we do that? Well, it's going to be a bit similar to what we have here with these buttons. So here we also had like an active class to show which one is the active button here. And to do that, remember, before we activated one of them, we first deactivated all of them. And so here we are going to do the same. So we will select all of the dots each time that we want to activate one, and we will then remove that active class and then add it only on the one that we're interested in. So let's select all the dots. So that's document.querySelector, and actually query selector all. And so the dots are the one that have this class. And then for each of them, so let's call it dot. We want to say dot ClassList remove this class -- active. So that's the first step of removing all the active classes. and then we will edit only on the one that we are interested in. So how do we select the one that we actually want? Well, we can do that also based on the data attribute. So that's going to be a bit complicated. So let me show you how. So document.querySelector, and so here the query is going to be a little bit more complicated. So it's still dots underscore underscore dot, but now we want to select based on the data slide attribute. So basically based on this attribute. And we can create a selector for that. So remember how previously we used these brackets to select for images with a certain attribute. And so here we can do that as well, and even check if they have a certain value. So data slide equals, and so they should have exactly the value of slide. And so then the selected dot we can add to the class list or class, so the active class, just like this. So let's say we pass in slide number 2. So we want to activate the dot corresponding to slide number 2. And so here in this query selector, we can basically select the element with this class and with this data slide attribute set to 2. So write like this. Okay, and here that's active. And so now that should actually be working already. All we need to do is now call this function here in all the necessary places. So when we go to the next slide, we go to the slide, of course, and then we also want to activate the dot. And also on the current slide. And then the same when we go to the previous slide. Activate dot with the current slide. And finally, when we click on one of the dots. So activate dot, and here it's just called slide. Okay, let's try that. And did it work or not? Well, it's hard to see actually here because of these images. But yeah, apparently it is working. Although it looks kind of the same as all the other dots. So let's change that here, the style. But yeah, it's very hard here. So let me change the class here. So let's actually change it to white. So reactivate this one here. Oh, and yeah, you can see that it actually works. So now that's a bit better visible. So that works just fine in all directions. So even with the arrow, of course. And when we click a dot, then the same works as well. There's just one problem, which is when we reload this, then none of the slides is active. So let's go back here and also in the beginning call this activate dot function with slide 0. So activate dot 0. And so now you see the first dot is now active. Great. So that's actually it. Our slider is working now. Let's just refactor our code just a little bit and make it a bit better. So for example, we have all of these function calls here. So let's put them all in the same function, which I'm going to call init. So an init function, an initialization function. So here we have our event handlers. And then here our functions. So I'm calling the function that doesn't even exist yet. So that's better. And now I will simply put all of these here, just so that we know a bit better what exactly we are going to do in the beginning, basically, to initialize our slider. And there should be one more. Yeah, that's to create the dots. And that should probably happen before we activate any dot. Otherwise, that's not going to work, probably. So here we have then our functions. Let's just write that here as well. This one we don't need anymore, in fact. And now, just to finish, let's actually put all of this code into a function as well. And so this way, we do not pollute the global namespace. So that's something we like to say, and we're going to talk a little bit more about this also later in the course still. But for now, just know that it is a good practice to keep this kind of functionality here, maybe in its own function. So let me actually delete this one and just put one curly brace at the very end here. And then all we need to do is to call that function. And that's it. So now we have our slider working, and we could now actually even pass in some values here. And to make this even more complete, we could actually pass in like some options here. So we could make this slider function accept a couple of options. So an object, for example, which contains these options, and then work with that. But that's a bit too much for this example. But just know that this is a pretty common thing to do. So great, this slider works. Let's just actually go back to deleting these slides. We don't need them anymore, and put back our original content. And so you will see then that it works just the same. And indeed, it does. So I'm just going to change the color of the dot back here. And then that's it. So everything works the same, no matter how many slides we have. So of course, now we have only 3 dots, but everything just works the same. So the slider is really being built dynamically based on the number of slide elements that we create in our markup. Okay. So we're almost done with this project now. There's just 2 more small lectures in which we're gonna learn a little bit more. And so after reviewing this code for this really cool component, let's then just quickly check out these final 2 lectures. Now, to close off this section, let's take a quick look at a couple of different events that occur in the DOM during a web page's life cycle. And when we say life cycle, we mean right from the moment that the page is first accessed until the user leaves it. And let's do that right here at the end of this file. Now, the first event that we need to talk about is called DOM content loaded. And this event is fired by the document as soon as the HTML is completely parsed, which means that the HTML has been downloaded and been converted to the DOM tree. Also, all scripts must be downloaded and executed before the DOM content loaded event can happen. And of course, we can listen to that event, and since it happens on the document, we call the addEventListener method on the document. And then the name of the event is, as I mentioned, DOM content loaded. All right. Now, this event does actually not wait for images and other external resources to load. Okay, so just HTML and JavaScript need to be loaded. So let's not take a look at this event, or basically just log something to the console. So HTML parsed and DOM tree built. And we can also take a look at the event. Okay, so let's see. And so indeed, we get the event here right basically at the beginning. And in this case, it's a bit hard to see. And so let's again go to our network tab. And I'm decreasing it here. And I will set it to fast 3G now. And down here, you can actually see the time that it takes for the event to be fired. So in this case, it was just 85 milliseconds. And so therefore, it was really fast. So let's try that again with a fast 3G connection. And so now it actually took 2 seconds for the JavaScript and the HTML to load, but you see that still after that, some other code here or some other stuff kept loading. So that's probably all these images that we have here. And of course, as we keep scrolling, then these other images also start loading. So that's what's happening here. All right. So with this here, we can now execute code that should only be executed after the DOM is available. And in fact, we want all our code only to be executed after the DOM is ready, right? So does that mean that we should wrap our entire code into an event listener like this? So with a function like this? Well, actually no, we don't need to do that. And that's because we have the script tag, which is the one that imports or JavaScript into the HTML right at the end of the body. So you see, it is down here. So basically, it's the last thing that is going to be read in the HTML. And so basically, the browser will only find our script when the rest of the HTML is already parsed anyway. So when we have the script tag here at the end of the HTML, then we do not need to listen for the DOM content loaded event. Okay. Now, there are also other ways of loading the JavaScript file with the script tag, but we're going to talk about that in our next lecture. All right. Now, if you're coming to vanilla JavaScript from jQuery, then you're probably used to wrap all your code into a document ready function, which in JavaScript, or actually in jQuery, looks something like this. And so this is equivalent to the DOM content loaded in vanilla JavaScript. Okay, but again, no such thing is necessary in regular JavaScript. Okay, anyway, next up, there is also the load event. And the load event is fired by the window as soon as not only the HTML is parsed, but also all the images and external resources like CSS files are also loaded. So basically, when the complete page has finished loading is when this event gets fired. So as always, we can also then listen to that. So load function, and then here we can log page fully loaded along with the event. So let's take a look here in our console. So we already got this event, and then at the end, when everything was finished, we also got this load event. So you see, it's just a regular event object like we already know. And again, this load time actually appears down here in the network tab. All right. We can also see the amount of kilobytes that was downloaded. And so this network tab is really nice, and it gives us a lot of information about loading our pages. And of course, you can try to explore this network tab a little bit more on your own. Now, finally, the last event that I want to show you is the before unload event, which also gets fired on window. So window.add event listener. And so that's before unload. And this event here is created immediately before a user is about to leave a page. So for example, after clicking this close button here in the browser tab. So we can basically use this event to ask users if they are 100% sure that they want to leave the page. Now, in some browsers, to make this work, we need to call prevent default here. In Chrome, it's not necessary, but some browsers require it. And then we can also take a look at the event itself. Here, let's remove that. And actually, in order to display a leaving confirmation, we need to set the return value on the event to an empty string. So return value and an empty string. And this probably looks a bit weird, but this is for historical reasons. All right, so let me show you what happens as we try to close the tab now. And so now we get this pop-up here indeed, which asks us if we want to leave the site. Now, a long time ago, developers were actually able to customize the message that was displayed here. But then, of course, many people started to abuse this. And so now we can only see this generic message. So no matter what we write here, we will always get this same pop-up. Okay. So let's remove this. And this can, of course, sometimes be useful, but sometimes it's also a bit too much. So let's actually remove all of this here. Okay. Now we cannot even reload the page here. I will actually have to open up a new tab with this and close this one. All right. So really, please don't abuse this kind of feature, because a message like this is, of course, pretty intrusive, and it should only be displayed when necessary. So don't be one of these developers who abuses of too much power. So the only time you should prompt the user if they really want to leave the page is, for example, when the user is leaving in the middle of filling out a form, or like writing a blog post or something like that. So a situation in which data could actually be lost by accident. And that's actually all I had to show you. So that's the 3 events that can be quite helpful in some situations, and especially this one, I would say. All right. And now in the next video, to finish this section, we will take a closer look at this event and at different ways of loading scripts in HTML. To finish this section, let's take a quick look at different ways of loading a JavaScript script in HTML. So up to this point, we have always used the regular way of including JavaScript files into our HTML, like we can see here. However, we can also add the async attribute to the script tag like this, or the defer attribute. And these attributes are going to influence the way in which the JavaScript file is fetched, which basically means downloaded, and then executed. Now in the HTML, we can write the script tag in the document head, or usually at the end of the body. So these are the 2 situations that we're going to be comparing in this slide. So when we include a script without any attribute in the head, what will the page loading process look like over time? Well, as the user loads the page and receives the HTML code will start to be parsed by the browser. And parsing the HTML is basically building the DOM tree from the HTML elements. Then, at a certain point, it will find our script tag, start to fetch the script, and then execute it. Now, during all this time, the HTML parsing will actually stop. So it will be waiting for the script to get fetched and executed. Only after that, the rest of the HTML can be parsed, and at the end of that parsing, the DOM content loaded event will finally get fired, as we learned in the last video. Now, this is not ideal at all, right? We don't want the browser to be just sitting there doing nothing, because this can have a huge impact on the page's performance. Plus, in this case, the script will actually be executed before the DOM is ready. And so again, that's not ideal. So never do this. Never include the script in the head like this. That's why we usually always put the script tag at the end of the body, so that all the HTML is already parsed when it finally reaches the script tag. So in this situation, this is how the page loading process looks like. The HTML is parsed, then the script tag is found at the end of the document, then the script is fetched, and then finally the script gets executed. And this is much better. So if you didn't know why we always put the script at the end of the body, well, now you know. However, this is still not perfect, because the script could have been downloaded before, while the HTML was still being parsed. So what about the async attribute? Well, this is what the loading process looks like when we use async script loading in the head of the document. So as you can see, the difference is that the script is loaded at the same time as the HTML is parsed, so in an asynchronous way. So that's already an advantage. However, the HTML parsing still stops for the script execution. So the script is actually downloaded asynchronously, but then it's executed right away in a synchronous way. And so the HTML code has to wait for being parsed. But anyway, as we can see from the length of the diagrams, this still makes page loading time shorter. But now, what about the defer attribute? Well, when deferring, what happens is that the script is still loaded asynchronously, but the execution of the script is deferred until the end of the HTML parsing. So in practice, loading time is similar to the async attribute, but with the key difference that with defer, the HTML parsing is never interrupted, because the script is only executed at the end. And many times, this is exactly what we want. Now, you might be wondering why I didn't show async and defer in the body yet, and the reason for that is that they simply don't make sense there. Because in the body, fetching and executing the script always happens after parsing the HTML anyway. And so async and defer have no practical effect there. Alright? And so the async and defer attributes have no practical effect here at all. They would make no difference. Alright? Now there are of course use cases for all these strategies. So let's now compare them, except of course the regular loading in the head, which is completely ruled out. So here is what we already know about the three strategies and also the three loading diagrams that we analyzed in the last slide. But let's now compare the async and defer attributes a little bit better. So one important thing about loading an async script is that the DOM content loaded event will not wait for the script to be downloaded and executed. So usually DOM content loaded waits for all scripts to execute, but scripts loaded with async are an exception. So with async, DOM content loaded is fired off as soon as the HTML finishes parsing. And this might actually happen when a big script takes a long time to load, like in this example. So notice how the DOM content loaded event appears right after HTML parsing in both these diagrams. Now using defer, on the other hand, forces the DOM content loaded event to only get fired after the whole script has been downloaded and executed. And so this is the more traditional way that this event works. Another very important aspect is that async scripts are not guaranteed to be executed in the exact order that they are declared in the code. So the script that arrives first gets executed first. On the other hand, by using defer, that is not the case. So using the defer attribute guarantees that the scripts are actually executed in the order that they are declared or written in the code. And that is usually what we want to happen. So in conclusion, and also keeping in mind what we learned in the last slide, using defer in the HTML head is overall the best solution. So you should use it for your own scripts and for scripts where the order of execution is important. For example, if your script relies on some third-party library that you need to include, you will include that library before your own script, so that your script can then use the library's code. And in this case, you have to use defer and not async, because defer will guarantee the correct order of execution. Now, for third-party scripts where the order does not matter, for example, an analytics software like Google Analytics or an ad script or something like that, then in this case, you should totally use async. So for any code that your own code will not need to interact with, async is just fine. So it's a good use case for this kind of scripts. And I'm saying this because, of course, you can use different loading strategies for different scripts in your web application or website. Okay? Now, what's important to note is that only modern browsers support async and defer, and they will basically get ignored in old browsers. So if you need to support old browsers, then you need to put your script tag at the end of the body and not in the head. That's because this is actually not a JavaScript feature, but an HTML5 feature. And so you can't really work around this limitation like you can do with modern JavaScript features by transpiling or polyfilling. Okay, and this should give you a pretty good idea about different ways of loading JavaScript scripts. So let's now quickly move over to the code and implement this. And here we still have the script at the end of our body. And of course, without any async or defer attributes. Now, before we move this to the head, let's quickly check out here our network tab one more time. And let's use the fast3g preset now, just so we can see these files here being loaded, and also to see this DOM content loaded event being fired. And so here we can actually see the different assets of the page being loaded over time. And let's search for the script. And so, yeah, here you see that the script actually only loaded, so only started to load after these first images here. And also the HTML itself, which is this one here. So only after they finished loading is when the JavaScript file started loading. That's why here we have this stalled time. And so this is a bit similar to the diagram that I showed you in the slide. Okay, now this time is probably different for you, but just take note of it so we can compare it to the next scenario. So let's now copy this, and I will comment it out using command/. And so now I'm moving it here to the head. Okay, and then I'm going to put the defer attribute, because as we just learned, this is the preferred way of loading our own scripts, and also when the order matters. So from now on, we will always load our scripts like this. So in the head with the defer attribute. So let's give it a save, and this will then trigger a reload here. And you see that now the DOM content loaded event here fired half a second earlier. And so that's because the JavaScript file could start it to load immediately. And so indeed, now here, as we hover this file, we don't have that stalled period. So that period in the beginning where the file isn't even being loaded, right? So this looks different. And in fact, it looks exactly as I showed you in the slide one more time. So the load time is of course different because the assets that we need to download are exactly the same. But what matters is that the page is basically ready earlier in this scenario. All right, so let's put it back. And yeah, with this, we actually finished one more section and one more really beautiful project, in my opinion at least. So one more time, you can add this to your portfolio or show off to your friends, or maybe even potential employees or employers. Just make sure about this notice that I have here at the bottom of this page and in all the other big projects, which is please don't use this project on your own to create your own course. Also don't claim it as your own product as if like you came up with this design on your own. So this is just for learning purposes or for your portfolio. All right, but I think that's pretty obvious anyway. I just wanted to make sure to mention it here because many people ask me questions about what they can do with the projects and what they can't. But anyway, congratulations for finishing one more section and actually by reaching the end of the intermediate part of this course. That's a huge milestone and you should really be celebrating. So great job of going through all these videos together with me, learning all of these important and valuable skills. So take a well-deserved break now, and after you're energized, let's move on together to one of the most important sections of this course, which is going to be about object-oriented programming in JavaScript. In modern JavaScript, there are two major paradigms: object-oriented programming and functional programming. And so, in this section, you're gonna learn everything you need to know about object-oriented programming in JavaScript. And this is absolutely essential if you want to become a professional JavaScript developer. So, we're gonna dive really deep into what object-oriented programming actually is and different ways of implementing it in JavaScript. And we're gonna start with constructor functions, then move to ES6 classes, and also talk about object.create. And by the end of the section, we will even implement inheritance between classes using all these different techniques. So this is going to be a full-packed section, and so let's dive right in. So this section is about object-oriented programming, and this lecture is going to be a very general, high-level overview of this programming paradigm. So we're going to talk about what object-oriented programming is, how it works in general, and about its 4 fundamental principles. So this is going to be a really important and valuable lecture, and so let's get started. So first of all, what is object-oriented programming? Well, object-oriented programming, or OOP in short, is a programming paradigm that is based on the concept of objects. And paradigm simply means the style of the code. So the how we write and organize code. Now, we use objects to model, so to describe aspects of the real world, like a user or a to-do list item, or even more abstract features like an HTML component or some kind of data structure. Now, as we already know, objects can contain data, which we call properties, and also code, which we call methods. So we can say that by using objects, we pack all the data and the corresponding behavior all into one big block. So again, that's data and corresponding behavior. And this makes it super easy to act directly on the data. And speaking of blocks, that's exactly what objects are supposed to be. So in OOP, which is the acronym that I'm going to use instead of object-oriented programming, okay? So in OOP, objects are self-contained pieces of code or blocks of code like small applications on their own. And we then use these objects as building blocks of our applications and make objects interact with one another. Now, these interactions happen through a so-called public interface, which we also call API. This interface is basically a bunch of methods that the code outside of the objects can access and that we use to communicate with the object. Okay, so let's take a breath here, because this all sounds kind of abstract, right? But don't worry, it will make more sense once we start developing these concepts using code throughout this section. But anyway, why does OOP actually exist? Well, this paradigm was developed with the goal of organizing code, so to make it more flexible and easier to maintain. So before OOP, we might have a bunch of code scattered across multiple functions or even in the global scope without any structure. And this particular, like crazy style of code is what we usually call spaghetti code. And spaghetti code makes it very hard to maintain large code bases and let alone add new functionalities to it. So the idea of OOP was basically created as a solution to this problem. And apparently it worked, because today OOP is probably the most popular and most widely used programming paradigm in large-scale software engineering. Now, OOP is certainly not the only way of writing organized and maintainable code. So in fact, there are many other paradigms that have become increasingly popular, and one of them is functional programming. And functional programming allows us to achieve the exact same goal of basically avoiding spaghetti code. And as I have been saying, we will talk about functional programming later in the course and compare it with object-oriented programming. But for now, let's focus on OOP. Now, actually, using objects is nothing new for us at this point, right? We have been using them all the time. However, up until now, we have basically only used objects as loose collections of data and without making them interact with one another. Also, we didn't have a way to generate objects programmatically. All we ever did was using simple object literals. But in OOP, we actually need a way to generate, so to create new objects from our code. And to do that, in traditional OOP, we use something called classes. You can think of a class as a blueprint, which can then be used to create new objects based on the rules described in the class. So it's just like an architecture where the architect develops a blueprint to exactly plan and describe a house. But the blueprint is really just an abstract plan, like a set of rules, but nothing tangible that you can actually touch. However, from that blueprint, many real houses can then be built in the real world. And with classes, it's just the same. So let's take a look at this fictional user class as an example. And I say fictional because this is not actual JavaScript syntax, okay? Because JavaScript does not actually support real classes like I'm explaining here. We do have a class syntax in JavaScript too, but it still works a bit differently from what I'm going to show you here. However, the idea of creating objects from a kind of blueprint is still a very useful mental model to have, because in general terms, this is still how OOP works across all languages, and that includes JavaScript. And so that's the reason why I'm showing you this here, so as a conceptual overview and for you to have this as a mental model. But anyway, back to our fictional class here, we can see that it kind of describes a user who has a username, a password, and an email. So it's a description of data about a user, but it's not the data itself yet. Because remember, the class is really just a plan, and the plan doesn't contain the real-world data just yet. On the other hand, we then have the behavior that is associated with the data. And in this case, that's just a login method and a method to send messages. So just like we learned in the last slide, this class has everything related to a user. So data and behavior all packed into one nice self-contained block. But now let's use this class and actually create a new object from this class. And you see that now we actually have real data about the user in the object and not just a description of the data like we have in the class, so in the plan. Now we call all objects created through a class instances of that class. So again, an instance is a real object that we can use in our code, which was created from a class. And the class itself is not an object. All right? So back to the blueprint analogy from earlier, this instance is like a real house which was created from the abstract blueprint created by the architect. And the beauty of this is that now we can use this class to create as many instances as we need in our application, just like we can build multiple houses from just one blueprint, right? And all of these instances, so these objects, of course, can have different data in them, but they all share the same functionality, which is to log in and to send messages. Okay, so now we know that we can create classes to generate objects from these classes. So we know how classes work, but the next logical question is, how do we actually design a class? Or in other words, how do we actually model real-world data into classes? So these questions are just like an architecture student asking, well, how do we actually plan and design a house? And that's, of course, a very good question. Now, the answer is, as you can imagine, not straightforward. So there's not a single correct way of designing classes. There are, however, 4 fundamental principles that can guide us toward a good class implementation. And these principles are abstraction, encapsulation, inheritance, and polymorphism. And these are actually techniques that can also be used outside of OOP, but they are especially relevant in this context. So let's now take a more detailed look at each of them. And the first one is abstraction. And abstraction basically means to ignore or to hide details that don't matter. This allows us to get an overview perspective of whatever it is that we're implementing instead of messing with details that don't really matter to our implementation. So let's say that we're implementing a phone for a user to use. And even though this doesn't make much sense in code, it's still a great example and analogy. So without abstraction, we could design our class to include everything that there is about the phone, including all the internal stuff like verifying the phone's temperature and voltage, turning on the vibration motor or a speaker, and other low-level details. But as a user interacting with a phone, do we really need all of this detail? Well, I guess not, right? So in reality, when we interact with a real phone, all of these details have been abstracted away from us as the user. And all that we're left with is a simple phone that we basically only interact with using the home button, volume buttons, and the screen. Everything else is gone because we simply don't need it as a user. So the phone then operates kind of as a black box without us seeing what is happening inside. Now, of course, internally, the phone still needs to vibrate and to measure the voltage or to turn on a speaker, but we can hide these details from the user. And that is exactly what abstraction means. Now, going back to the example of a user from the last slide, we could implement a user's phone number, mailing address, hair color, shoe size, and tons of other stuff that we might not need in our application. So we simply ignore these details. Now, abstraction is really important, not just in OOP, but in programming in general. In fact, we create and use abstractions all the time. For example, take the addEventListener function that we use all the time. Do we actually know how exactly it works behind the scenes? Well, we don't. And do we care? No, not really, right? And we don't have to, because once more, the low-level details of how exactly it works has been abstracted away from us. We are simply the user, and so we can simply use that function without completely understanding it and without having to implement it ourselves. So that's abstraction, which actually blends in with the next principle, which is encapsulation. And encapsulation basically means to keep some properties and methods private inside the class, so that they're not accessible from outside the class. However, some methods can of course be exposed as a public interface, which we call API. And this is exactly what I meant at the beginning of the lecture when I said that interactions between objects happen through a public interface. And going back to our example of a user from before, this is what private properties might look like conceptually. And again, I'm talking hypothetical here because this private keyword here actually does not exist in JavaScript. But anyway, as we already know, outside code now can't access these properties. However, inside the class, they are still accessible. For example, the password is of course necessary in the login method, right? And so there we can use it. And by having these critical properties nicely encapsulated like this, we prevent external code from accidentally manipulating this internal state. And by the way, the term state simply refers to an object's data. Okay? Anyway, this is really important because allowing external code to manipulate internal state directly can cause many kinds of bugs, especially in large code bases and developer teams. Now, as you see, there's also a private method here, the check spam method. Again, it's not accessible from outside the class, but it's used internally to check if a comment is spam or not. So we want no one else outside of the class to be able to use this method. And so basically, we don't make it part of the public interface. So the public interface is essentially all the methods that are not private, so that are not encapsulated. So making methods private makes it easier for us to change our code without breaking code from the outside, which might rely on some of these methods. For example, if the check spam method was public, then it could be used anywhere in our code. And if we then change the implementation of the method, it might break that code that is relying on it. So again, this helps avoiding bugs and also spaghetti code. And really, this is not just some theory, this is a real practical scenario. All right, so there is a real reason why encapsulation and private methods and properties exist. So in summary, we should always have the goal to nicely encapsulate most of our state and methods and only leaving essential methods public for the reasons that I just explained. Next up, we have inheritance. So let's say we have these two classes, user and admin, which stands for administrator. And as we can see, they have actually a lot in common. In fact, admin has all the properties and methods that user has, right? And that actually makes sense because if you think about it, an admin is also a user. So an admin also needs a password and an email, and he also needs to log in, for example. However, if we design our classes like this, so as two separate identities, we will end up with a lot of duplicate code. And we already know that that's bad, right? But well, that's where inheritance comes into play. So in OOP, when we have two classes that are closely related, like user and admin here, we can have one class inherit from the other. So we will have one parent class and one child class. And the child class then extends the parent class. Okay, great. But what does all of that actually mean? Well, it's actually quite intuitive, I think. So just like you as a child probably inherited some features of your parents, a child class inherits all the properties and methods from its parent class. Now, in more formal terms, inheritance makes all properties and methods of a certain class available to a child class, which, of course, then forms a hierarchy between these two classes. And the goal of this is to reuse logic that is common to both of the classes. In this case, both the admin and the user need to log in. And so instead of writing that logic twice, it makes sense to inherit the login method from the more global class, which is the parent class user, to the more specific class, which is the child class admin. Now, of course, a child class can then also have its own methods and properties. So at the end of the day, the child class ends up with some methods and properties from its parent and some of its own. So we can say that the admin is also a user, but basically an extended user, so with some added functionality. Okay, and finally, the last principle is polymorphism. And polymorphism sounds a bit weird, which is because it comes from Greek, where it literally means many shapes. Now, in the context of OOP, in simple terms, polymorphism means that a child class can override a method that it inherited from a parent class. And here are our user and admin classes again. But now we also have a third class, which is the author. Now, admin and author are both really just special kinds of users. And so it makes sense that they both inherit from the user class, just like we studied in the last slide. Therefore, they inherit all the properties and methods from the user class, but we're going to focus on the login method now. Now, let's say that an admin requires a different kind of login method. For example, a more secure one, which has two-factor authentication. And let's say that we also need a special login method for authors. So how do we give them different login methods? Well, it's actually quite simple. In each class, we simply just write a new method, which is also called login, and then, according to polymorphism, that login method will override the login method that has been inherited from the user class. And that's actually it. That's all you need to know about polymorphism. And actually, that wraps up this introduction to object-oriented programming. So I know there was a lot to take in here, so make sure to understand everything before actually moving on in this section. Now, next up, we're going to talk about how object-oriented programming actually looks like in JavaScript. Because, as I said in the beginning, it is implemented in a bit different way from what I explained here in the beginning with classes and instances. It's still crucial to understand that, but again, in the next video, we will see how JavaScript does it. Welcome back to the second part of the introduction to object-oriented programming. And in this lecture, we will learn about OOP specifically in JavaScript. So how it's different from the more traditional OOP, and also different ways of implementing this paradigm in JavaScript. And don't worry, this will be a lot shorter than the last lecture. So just to review, in the last lecture, we talked about the classical object-oriented programming model with classes and instances created from these classes. And remember, a class is like a blueprint, which is a theoretical plan, and that we use to build many houses in the real world. And in the same way, the theoretical class can be used to create actual objects, which are called instances, and which we can then use in our code. And this process of creating an instance is called instantiation. Now, earlier I said that in JavaScript, things work a bit differently. So why did I first tell you about classes and instances? Well, it's because we do have similar concepts in JavaScript, and so it's very useful to first understand the class instance model. Plus, many people also just use this terminology in the context of JavaScript. And finally, JavaScript syntax itself uses also some of these terms. For example, instances. And so you really need to know what a class is and what an instance is. Now, anyway, how does OOP actually work in JavaScript? Well, in JavaScript, we have something called prototypes. And all objects in JavaScript are linked to a certain prototype object. So we say that each object has a prototype. And now here comes the magic. So the prototype object contains methods and properties that all the objects that are linked to that prototype can access and use. And this behavior is usually called prototypal inheritance. So again, prototypal inheritance means that all objects that are linked to a certain prototype object can use the methods and properties that are defined on that prototype. So basically, objects inherit methods and properties from the prototype, which is the reason why this mechanism is called prototypal inheritance. Just note that this inheritance is actually different from the inheritance that we talked about in the last lecture. So that was one class inheriting from another class. But in this case, it's basically an instance inheriting from a class. So that's very different, and so keep that in mind. Or maybe in your notes. Alright? Now we can also say that objects delegate behavior to the linked prototype object. And behavior is just another term for methods here. So besides prototypal inheritance, we also call this mechanism delegation. And that's also the reason why this arrow is pointing upwards, because technically objects delegate their behavior to the prototype. On the other hand, in classical OOP with classes, the behavior, so the methods, are actually copied from the class to the objects. And so that is completely different. Now, I don't want you to stress out about the exact terminology here, okay? So I know that this is a lot of new stuff to take in, so a lot of new words and new concepts. But this is just to paint a very clear picture and to give you the complete overview. What matters to me is that you understand how this prototypal inheritance actually works. Because when we actually start using this in practice in the next lecture, it won't really matter if it's called inheritance or delegation, as long as it just works as intended, right? But since you came to this course to learn how things actually work in JavaScript, I'm giving you all that information here. Even though for now it looks a little bit too much, but I'm sure you will find it useful eventually. So actually, we will come back to this diagram and fill it with some more detail after we have actually implemented prototypes in JavaScript. So after you have actually see how they work in practice. And by then, I'm sure that all this will make 100% sense to you. But anyway, we have actually already seen this mechanism in action many times before, but without knowing that it was happening. For example, each time that we use an array method like map, we are able to use that method because of prototypal inheritance. So when you go to MDN to check the documentation for any array method, what you will see there is that it's actually called array.prototype.map. But why is that relevant? So what does this mean? Well, array.prototype is the prototype object of all the arrays that we create in JavaScript. So just like this example array called num here. Now this prototype object contains all the array methods, including map. So this is where they are actually defined. So since array.prototype is the prototype of the num array, it means that num is linked to that prototype, and therefore it has access to all the methods that are defined on the array.prototype object, just like the map method. So in a sense, our array inherits the map method. Or again, we can also say that the array delegated the behavior of mapping to its prototype. So you can choose whatever makes more sense in your mind. But what matters is that the map method is actually not defined on the num array itself, but on its prototype. And of course, we're going to check out this behavior also in our code in practice. Okay? Now, right now, you might have a ton of questions in your head. Like, how do we actually create prototypes? And how do we link objects to prototypes? And how can we create new objects without having classes from which we can instantiate objects? So, in summary, the question is, how do we implement object-oriented programming in JavaScript in practice? Well, in JavaScript, there are actually 3 different ways of doing all this: the constructor function technique, ES6 classes, and also the object.create function. So first, constructor functions are a way of creating objects programmatically using a function, which will also set the new object's prototype. And this is actually how built-in objects like arrays or maps or sets are implemented. Also, this is how OOP has been done in JavaScript basically since the beginning. Next, the ES6 release introduced classes into JavaScript. And so now, ES6 classes are actually the more modern way of doing OOP in JavaScript. However, keep in mind that these are actually not the kind of classes that we talked about in the last lecture and in the last slide. They are, instead, just so-called synthetic sugar over constructor functions. So this means that ES6 classes are basically just a layer of abstraction over constructor functions. So it's really just a nicer syntax that makes it easier for newcomers to do OOP in JavaScript. But behind the scenes, ES6 classes are actually implemented with constructor functions. And so they also use prototypal inheritance, just like we learned in the last slide. Finally, there's also the object.create function, which is basically the easiest and most straightforward way of linking an object to a prototype object. However, it's not as used as the other 2 methods, as we will see over the next couple of lectures. Now, to finish, one important thing to keep in mind is that the 4 principles of object-oriented programming that we learned in the last lecture, so that's abstraction, encapsulation, inheritance, and polymorphism, are still valid and important with prototypal inheritance. And throughout this section, we will of course learn how to use and implement these principles. Alright, and with all that being said, let's now finally put OOP into practice and get a bit more technical. Let's finally implement object-oriented programming now, and starting with constructor functions. And as always, I already have the starter files open here in my VS Code editor. So please go ahead and do the same now. And we can actually already also open up a new terminal and start our live server. So we can close that, open up the console here, increase it a little bit. And now we're all set up and ready to go. So we actually kind of used object-oriented programming before, but in a very limited way, because we had no way of programmatically creating objects. And so all we did was to use some simple object literals, for example, in the Bankist app, right? But now that all changes with constructor functions. So we can use constructor functions to build an object using a function. Now, a constructor function is actually a completely normal function. The only difference between a regular function and a function that we call constructor function is that we call a constructor function with the new operator. But enough talk, let's now actually create a constructor function for a person. So that's person. And in OOP, there is this convention that constructor functions always start with a capital letter. And so we should always follow that convention too. And in fact, other built-in constructors like array or map follow that convention as well. Now here I'm using a function expression, but of course a function declaration will also work. Now an arrow function will actually not work as a function constructor. And that's because it doesn't have its own this keyword, and we need that. Okay, so only function declarations and function expressions. Now remember that this function is basically going to produce an object, and in this case for a person. So we want the person to have a name, or let's say a first name, and a birth year. And so we specify these two parameters for that here in our constructor function so that we can then pass in the name and the birth year. And now let's actually call this function. And so, as I said previously, the only difference between a regular function and a constructor function is that we call the constructor using the new keyword. So we write new, then person, and then let's pass in Jonas and 1991, let's say. So this new operator here is actually a very special operator, because what it does is to call this function here, so this person function, but it does a whole lot more than just that. So let's see what exactly happens when we call a function with the new operator like this. So behind the scenes, there happen 4 steps. And let me actually write them here because this is very important. So first, a new empty object is created. So an empty object is created. Then afterwards, the function is called, and in this function call, the this keyword will be set to this newly created object. All right, so let's write that here. So the this keyword is this new empty object. So basically, in the execution context of the person function, the this keyword will point to this new object here that was created in step number 1. And remember, all of this happens only because we are calling the function using the new operator here. So step number 3 is that this newly created object is linked to a prototype. So linked to prototype, but more about this in the next video. For now, we just care about creating the object itself. Finally, the last step is that the object that was created in the beginning is then automatically returned from the constructor function. So the function automatically returns that empty object from the beginning. But actually, at this point, the object no longer needs to be empty. And this is actually the trick of making the constructor function work. So let's go here now and log to the console the this keyword. And so we already know that it should be this empty object that was just created here in step number 1, right? Because the this keyword inside this function will be exactly that empty object. And again, that's because we are calling it with the new keyword. So let's see. And indeed, we get this empty object. And the browser console is actually already telling us that it's basically here of the type person. All right. And so this is just the name of the constructor function. All right. And now let's use this knowledge to our advantage, because we already know that in the end of this function, the this keyword will basically be returned. And so whatever we add to that empty object will then be returned from the function. And that returned object is going to be the object that we are trying to build here actually. So all we need to do is to now take that first name parameter, so the value that we receive, and then create a property on the this keyword with the same name and then set it to that value. And then the same with the birth year equal to birth year. And so now let's store the result here in some variable, and that's actually it. So let's see what Jonas is going to look like. Now, and we have to log it to the console here if we want to take a look at it. And indeed, here it is. here is the person object with the first name Jonas and the birth year that we passed here into the constructor function. So let's quickly recap what just happened here. So again, we're calling this constructor function with the new keyword or the new operator. And so therefore, a new empty object is created right away. Then the function is called, and in here, the this keyword is that empty object. And then in the function, we start to set properties to that object. And we give them the exact same name as the parameters that we're passing in here. And of course, they could have any other name, so it doesn't have to be the same name as our arguments. So it doesn't have to be the same name as our parameters, but this is kind of a convention. So if we pass in first name, then we should also create a property called first name. So then here, by the end of the function, or this keyword now has these two new properties. And then here in step number 4, that object that was created in the beginning is then automatically returned from the function. And so at this point, that is the object with these two properties. And so that's going to be the result of this function call. And so it will then be stored in Jonas. And then that's what we get here. Great. So I hope that made sense. And so now, of course, we can use this constructor function to create as many different objects as we want. So let's say we want to create Matilda, new person, Matilda, and then let's say 2017. And let's just do another one. Why not? Let's call it Jack, new person, just so you see that we can create as many objects now based on this constructor function. And so this is a bit like the analogy from before, where this constructor function is now the blueprint for a house, and then each of these objects that we create through that function, so through that blueprint, will be the actual house in the real world. So in this case, the actual objects with actual data in them. So Matilda and Jack. And so of course, now each of them is its own new object that we created programmatically using a function constructor. Now remember from one of the previous lectures that in classical object-oriented programming, an object created from a class is called an instance, right? Now we didn't technically create a class here because, as we discussed before, JavaScript doesn't really have classes in the sense of traditional OOP. However, we did create an object from a constructor function, and actually 3 objects, right? And constructor functions have been used since the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person. And the same goes for Matilda and for Jack here. And in fact, there is even an operator that we can use to test for that. So that works like this. So Jonas is an instance of, and then person. And so this will then return either true or false. Now, if we created something else here, let's say J, just like this, then if we do this, this should of course be false, right? Because of course we didn't create this variable here, so this object, using any constructor function. All right. And since we're talking about instances here, we can also say that these properties here will be the instance properties. Let's write that here. And that's because the properties first name and birth year will be available on all the instances that are created through this constructor function. So that's for properties. But now what about methods? So what if we wanted to add a method to our objects? Well, just like we added properties, we can of course also add methods. So let's again use our old friend calc_h here. And so here we are going to create a function and assign it to this property. And so this will then basically become a method, right? And this here should simply log to the console 2037, which is the year we've always been using, and then minus this dot birth year. And so this method is exactly the same that we've been using all the time, right? So this would work just fine here, but this is actually a really bad practice. So you should never do this. You should never create a method inside of a constructor function. That's because imagine we were going to create 100 or thousands or even tens of thousands of person objects using this constructor function. Then what would happen is that each of these objects would carry around this function here. So if we had 1,000 objects, we would essentially create 1,000 copies of this function. And so that would be terrible for the performance of our code. Again, don't do this. But instead, to solve this problem, we are going to use prototypes and prototypal inheritance, just like we discussed in the last video. All right, great. So this is the basics of constructor functions. Just note that function constructors are not really a feature of the JavaScript language. Instead, they are simply a pattern that has been developed by other developers, and now everyone simply uses this. And this now includes you as a new developer. So the real magic really here is this new operator. And so the most important thing to understand from this video is really these 4 steps. So make sure that you understand them, and then in the next video, we will work with prototypes and finally see the magic of prototypal inheritance in action. Now it's time to finally start using prototypes. And after this, you will feel like a real pro developer, believe me. And we're going to continue with the example from the previous video. Okay, but now we're going to talk about prototypes. So actually, we talked about prototypes, prototypal inheritance, and delegation earlier already. But how does all of that actually work? Well, it can be summarized like this. So first, each and every function in JavaScript automatically has a property called prototype. And that includes, of course, constructor functions. Now, every object that's created by a certain constructor function will get access to all the methods and properties that we define on the constructor's prototype property. So just to visualize, in our case, this would be person dot prototype. So the prototype property of the constructor function. So again, as I was just saying, all the objects that are created through this constructor function here will inherit, so they will get access to all the methods and properties that are defined on this prototype property. And so let's now actually add a method to this prototype property. And so this is actually an object, and so we can now say calc_h. And then we can simply set it to this same function here. So equal, and that's it. Now we get some error here, and that's because I misspelled prototype. So that's type right here. And let's actually take a look at this prototype property just for curiosity. So that's not comma, of course, it's the dot. And so here is that prototype property. And so you see that right now we already have the calc_h method in there. So before it was kind of an empty object. So never mind these two here. So Basically, it was empty before, but now there is the calc_h method already in here. So this one that we just defined down here. All right. And once again, remember how I said that each object created by this constructor function will now get access to all the methods of this prototype property. And so, of course, also to calc_h. And so we should be able to do this. So Jonas, which is this object here, which was of course created by this constructor function. And so calc_h. And let's see. And indeed, we get the correct h here. So it worked. Great. That's amazing. So we can now use this method here on the Jonas object, even though it is not really on the object itself, right? So if we check out Jonas here, then you see that it contains, of course, the birth year and the first name, but it does not contain the calc_h method. But still, we have access to it because of prototypal inheritance. Okay? And of course, the same is going to work for Matilda here, and of course, also for the Jack object. Beautiful. So that effectively solves this problem that we had before when we added the calc_h method directly to each of the objects. Remember that? So here we would have created a copy of this method here and attached it to every single object. And so that's why we don't do this. Instead, what we do is this, because now there exists only one copy of this function. So only one of them exists, but then all of the objects that are created using this constructor function can basically reuse this function on themselves. And so the this keyword, of course, in each of them is, as always, set to the object that is calling the method. And so here that's Jonas, and here that's going to be Matilda. So just like we learned previously, the this keyword is set to the object that is calling the method. All right, so in a nutshell, this is how we implement very basic prototypal inheritance in JavaScript in practice. So we just observed that the Jonas and the Matilda objects are kind of somehow connected to the person, right? That's why they can have access to these methods, or in this case, to just this method that is located inside the prototype property of person. But how and why does this actually work? Well, it works because any object always has access to the methods and properties from its prototype. And the prototype of Jonas and Matilda is person.prototype. And we can actually confirm that because each object has a special property called __proto. So like this, __proto, and then again __. So this looks a bit weird, but this is just kind of how it works. So let's take a look. And so this is the prototype of Jonas. It's not the prototype property, but it is simply the prototype. Okay, and so here again, we see the calc_h function, and that's why Jonas is able to use this. So the prototype of the Jonas object is essentially the prototype property of the constructor function. So let's quickly see that as well. So we can check that. So person.prototype. And so this should now be true. And indeed, it is. All right. But what I just said sounded incredibly confusing, didn't it? So shouldn't person.prototype be the prototype of person? I mean, should this prototype property here not be the prototype of person? Well, actually, no. So this is the confusing part. So person.prototype here is actually not the prototype of person, but instead it is what's going to be used as the prototype of all the objects that are created with the person constructor function. So that's a subtle but important difference that you need to keep in mind. And in fact, what I just said is confirmed by this comparison that we just did here. So we just saw that Jonas's prototype, which is this, is the prototype property of the person constructor function. And there are actually other built-in methods that we can use to prove this. So on any object, for example, object.prototype, we can test if this is a prototype of another object. So we can call is prototype, so is prototype like this of, and then Jonas. And so this should also become true, and indeed it is. So this confirms one more time that person.prototype is indeed the prototype of Jonas. And the same for Matilda, of course, as well. But person.prototype is not the prototype of person. So you see, it is false here. So this very common confusion comes from bad naming of this property. So the fact that it's called prototype kind of implies that this is the prototype of person. But as we just learned, it is actually not. Probably shouldn't be called prototype, but instead something like prototype of linked objects or something like this. So if this makes it easier, you can think of the prototype property as prototype of linked objects property. Even though, of course, it's not called like this, but this would be a more honest name. So take some time to really understand what the prototype of what object actually is here. Now, anyway, where does this property here on the Jonas object actually come from? Well, remember the new operator that we talked about before? Well, it contains this step number 3, which links the empty new object to the prototype. And so basically, it is this step number 3 which will create this proto property. So it creates this proto property and it sets its value to the prototype property of the function that is being called. And so that's exactly what is written here, right? So again, it sets the proto property on the object to the prototype property of the constructor function. And so this is how JavaScript knows internally that the Jonas object is connected to person.prototype. And in fact, when we check out the Jonas object here, we can indeed also see that property in here. So it's also right here. And if we open that up, then you see exactly person.prototype, which contains this calc_h function. All right. So I'm spending a lot of time here for you to really understand what this proto property here is and what the prototype of the constructor is and how they are all linked, because this is one of the most important things and also one of the most difficult things to understand in JavaScript. But I hope that it's becoming increasingly clear, and there will also be a couple of diagrams in the next video that will basically bring all this knowledge together in an easier to understand way. So by now you're probably sick of hearing the word prototype, but I just wanted to quickly show you that we can also set properties on the prototype. And so not just methods. So let's say person.prototype.species. And so this is something that all of the objects here will have in common. And so that's Homo sapiens. All right. And so if we now take a look at Jonas and at Matilda also, then we should see this property, so the species, on both of them. And actually not directly here, but indeed they will be here in this prototype. And so we will be able to do Jonas.species and Matilda.species. And both of these objects will then inherit, so they will get access to this property from the prototype. So you see, in both cases, we indeed get Homo sapiens. Now, however, since when we take a look at these objects, well, as we just saw, this property is not really directly in the object. So it's not its own property. So own properties are only the ones that are declared directly on the object itself. So not including the inherited properties. And actually in JavaScript, there is a way of checking for that. So we can do Jonas has own property. So that's with a capital P here. And so let's first check for first name. And indeed, this object does have its own property with this name. But now if we try species, then that is going to be false. And again, that's because this property is not really inside of the Jonas object. It simply has access to it because of its prototype. So because it's in the prototype property of person. So right here. Right? And sometimes this method here can be quite helpful in certain situations. All right. And that is probably enough for one lecture. And as I just mentioned earlier, in the next video, I'm going to show you a nice diagram of all of this. So stay tuned for that one. Let's now consolidate the knowledge that we got over the last two videos in a nice diagram that brings everything together that we know so far. And everything starts with the person constructor function that we've been developing. Now, this constructor function has a prototype property, which is an object, and inside that object, we defined the calcH method. And person.prototype itself actually also has a reference back to person, which is the constructor property. So essentially, person.prototype.constructor is going to point back to person itself. Now remember, person.prototype is actually not the prototype of person, but of all the objects that are created through the person function. And speaking of the created objects, let's now actually analyze how an object is created using the new operator and the constructor function. So when we call a function, any function with the new operator, the first thing that's going to happen is that a new empty object is created instantly. Then the this keyword in the function call is set to the newly created object. So inside the function's execution context, this is now the new empty object. And that's why in the function's code, we set the name and birth year properties on the this keyword, because doing so will ultimately set them on the new object. So next comes the magical step. So now the new object is linked to the constructor function's prototype property. So in this case, person.prototype. And this happens internally by adding the __proto property to the new object. So person.prototype is now the new object's prototype, which is denoted in the __proto property of Jonas. So again, _proto always points to an object's prototype. And that is true for all objects in JavaScript. Great. And finally, the new object is automatically returned from the function unless we explicitly return something else. But in a constructor function like person, we usually never do that. Okay, and with this, the result of the new operator and the person constructor function is a new object that we just created programmatically, and that is now stored in the Jonas variable. And this whole process that I just explained is how it works with function constructors and also with ES6 classes, but not with the object.create syntax that we're going to use later. So just keep this in mind once we reach the object.create lectures. But anyway, why does this work this way? And why is this technique so powerful and useful? And to answer that, let's move on to the next line of code. So here we are attempting to call the calc_h function on the Jonas object. However, JavaScript can actually not find the calc_h function directly in the Jonas object, right? It is simply not there. And we already observed this behavior in the last lecture. Remember that? So what happens now in this situation? Well, if a property or a method cannot be found in a certain object, JavaScript will look into its prototype. And there it is. So there is the calc_h function that we were looking for. And so JavaScript will simply use this one. That's how the calc_h function can run correctly and return a result. And the behavior that we just described is what we already called prototypal inheritance or delegation. So the Jonas object inherited the calc_h method from its prototype. Or in other words, it delegated the calc_h functionality to its prototype. Now the beauty of this is that we can create as many person objects as we like, and all of them will then inherit this method. So we can call this calc_h method on all the person objects without the method being directly attached to all the objects themselves. And this is essential for code performance. Just imagine that we had 1,000 objects in the code, and if all of them would have to carry the calc_h function around, then that would certainly impact performance. So instead, they can all simply use the calc_h function from their common prototype. Okay? So that makes sense, right? Now, the fact that Jonas is connected to a prototype and the ability of looking up methods and properties in a prototype is what we call the prototype chain. So the Jonas object and its prototype basically form a prototype chain. But actually, the prototype chain does not end here. So let's understand the prototype chain a bit better by zooming out and looking at the whole picture. So here is the diagram that we already had with the person function constructor and its prototype property, and the Jonas object linked to its prototype via the _proto property. So nothing new yet. But now let's remember that person.prototype itself is also an object. And all objects in JavaScript have a prototype, right? Therefore, person.prototype itself must also have a prototype. And the prototype of person.prototype is object.prototype. Why is that? Well, person.prototype is just a simple object, which means that it has been built by the built-in object constructor function. And this is actually the function that is called behind the scenes whenever we create an object literal. So just an object simply with curly braces. So essentially the curly braces are just like a shortcut to writing new object. Okay? But anyway, what matters here is that person.prototype itself needs to have a prototype. And since it has been created by the object constructor function, its prototype is going to be object.prototype. It's the same logic as with the Jonas object. So since Jonas has been built by person, person.prototype is the prototype of Jonas. All right? Now, this entire series of links between the objects is what is called the prototype chain. And object.prototype is usually the top of the prototype chain, which means that its prototype is null. So its _proto property will simply point to null, which then marks the end of the prototype chain. So in a certain way, the prototype chain is very similar to the scope chain, but with prototypes. So in the scope chain, whenever JavaScript can find a certain variable in a certain scope, it looks up into the next scope in the scope chain and tries to find the variable there. On the other hand, in the prototype chain, whenever JavaScript can find a certain property or method in a certain object, it's gonna look up into the next prototype in the prototype chain and see if it can find it there. Okay? So again, the prototype chain is pretty similar to the scope chain, but instead of working with scopes, it works with properties and methods in objects. All right? And now let's actually see another example of a method lookup. To do that, we call the hasOwnProperty method on the Jonas object. So just like in the previous slide, JavaScript is going to start by trying to find the called method on the object itself. But of course, it can't find the hasOwnProperty method on Jonas. So according to how the prototype chain works, it will then look into its prototype, which is person.prototype. Now, we didn't define any hasOwnProperty method there either, and so JavaScript is not going to find it there. And so, therefore, it will move up even further in the prototype chain and now look into object.prototype. And object.prototype does actually contain a bunch of built-in methods, and hasOwnProperty is one of them. Great! So JavaScript can then take this one and run it on the Jonas object as if hasOwnProperty had been defined directly on Jonas. And remember, the method has not been copied to the Jonas object. Instead, it simply inherited the method from object.prototype through the prototype chain. Okay, and that's actually it. That's all I have to tell you at this point. So this is, in a nutshell, the magic of prototypes and the prototype chain. And this will actually become even more interesting and useful once we add inheritance between two different kinds of objects, or two different classes, so to say. For example, having a student class inherit from a person class, just like we learned in one of the 4 pillars of OOP. Remember? So there is a lot of exciting stuff ahead, and so let's move on. Let's now check out prototypal inheritance and the prototype chain on built-in objects such as arrays. But actually, let's start this lecture by inspecting some of the stuff that we just talked about in the last lecture. And we will keep using this person example that we have been building. So let's start by taking a look at Jonas.__proto. And we already know that this is the prototype of Jonas, which is exactly the prototype property of person. And so therefore it is this object which contains the calc_h method that we defined earlier, so up here, and also this property, so this species property. But now let's actually move up in the prototype chain and essentially take a look at the prototype of Jonas's prototype. And do you remember from the last video what that's gonna be? Well, let's see. And it is indeed the prototype property of object. So that's why you can see that constructor is the object here. And then right away, we see this method that we actually already studied in the last video. So this hasOwnProperty. And so this is the reason why we can do this. So why we can call hasOwnProperty on Jonas, like we did here in one of the earlier videos. So again, we learned in the last lecture that this works because of the prototype chain. And in particular, because this method here is in this prototype of Jonas's prototype. And so Yeah, that's this object that we are inspecting right now. All right. Okay, but let's take this one step further and check out the prototype of the prototype of the prototype. And do you remember what this one is? That's right, it is null. And so that's because object.prototype is usually the top of the scope chain. So this one here, right? So this one is going to be object.prototype. And so that's the top of the prototype chain. Okay. Now we can also take a look at that strange constructor property that we also saw earlier. So remember, person.prototype itself has a constructor property, which, as we said, will point back to the person itself. So constructor like this. And so here we actually get the function itself. Now, if we want to inspect that function, here we need to use console.dir. And so here indeed, we see that the constructor property points back at person. So that's this. Now, to make things a bit more complicated even, let's now take a look at the prototype of a function. So any function, of course, is also an object, and so therefore it also has a prototype. But maybe this is a bit too confusing, so let's just leave it here. So I will first show you the prototype of arrays, and maybe then we can move a bit further to functions. So actually, let's do that now. So let's create an array, just like with any random numbers. So the values here don't matter at all. All I'm interested in is now to take a look at the property. So the prototype of the array. So let's see. And here it is. So this is the prototype of array. And you see that here we have all these methods that we already know. So we have fill, we have filter, find index, and all of these methods that we studied in one of the earlier sections. And so this is the reason why all the arrays get access to all of these methods. So each array does of course not contain all of these methods, but instead each array will inherit these methods from its prototype. All right. And we can also check out that this prototype has got to be exactly array, which is the constructor function, dot prototype. So one more time, the prototype property of the constructor is going to be the prototype of all the objects created by that constructor. And so let's see, and it is true indeed. And just like in objects, using this shorthand basically is the same as using new array. And so therefore, whenever we create an array like this, it is indeed created by the array constructor. And so that's why all of this works behind the scenes. But of course, this is not yet the end of the prototype chain, as we saw in the last video. So let's see. And so now we are back to having object.prototype. You see, so this again now has own property, and then all of these methods here that are available for objects. And one more time, that is simply because the prototype itself here is an object. And so any object has access to all of these methods. All right. Now we would be able to see the exact same thing also directly in the console. So if I check out the array here and open it, then here in the bottom, you will see that we have the prototype property right here. So if we click that, then here one more time, we get all these array methods that we already know. Okay. And if we check the documentation on MDN, for example, for filter, then you see that actually the name of the method is array.prototype.filter. And that is because this filter method does, of course, live in the prototype property of the array constructor. So, one more time, you can see that the prototypal inheritance is really a mechanism for reusing code. So all of these built-in methods here have to exist only once somewhere in the JavaScript engine, and then all the arrays in our code get access to the functions through the prototype chain and prototypal inheritance. Great. So let's actually take this one step further. So we know at this point that any array inherits all their methods from its prototype. And therefore, we can use that knowledge to extend the functionality of arrays even further. So all we would have to do is to say array.prototype, and then here we can add any new method to this prototype, and all the arrays will then inherit it. So let's say that we wanted to create a method which returns all the unique elements of an array. So let's add a method called unique. So we set the unique property to a function, and then to get the unique values of an array, all we have to do is to create a new set and pass the array in there. And the this keyword is gonna be the array on which this method will be called. And so now we just need to put this into an array and spread it like this, as we have already done multiple times before. And so we can now use that. So array dot unique, and this should now return an array with only the unique values. Well, we don't have a lot of duplicates here. Let's add another 6 here, and maybe another 9. And so let's see what happens. And indeed, that worked. Beautiful. So just to recap, we added a new method to the prototype property of the array constructor. And so therefore, now all arrays will inherit this method. And so we can then call that method on any array that we want. However, what we just did here, so extending the prototype of a built-in object, is generally not a good idea. I mean, if you're working just on a small project on your own, then I guess you could do this. But really, don't get in the habit of doing this for multiple reasons. The first reason is that the next version of JavaScript might add a method with the same name that we are adding, for example this one here, but it might work in a different way. And so your code will then use that new method, which, remember, works differently, and then that will probably break your code. And the second reason why you shouldn't do this is because when you work on a team of developers, then this is really going to be a bad idea. Because if multiple developers implement the same method with a different name, then that's just going to create so many bugs that it's just not worth doing this. So it's just a nice and fun experiment, but in practice, you should probably not do it. Now, for a little bit of fun, to finish this video, let's take a look at some more built-in objects here in the console. So for example, we can select this DOM element here. And so let's do that, this h1. So that's document.querySelector h1. And we already know that all the DOM elements are behind the scenes objects. And so let's take a look at this object. Well, that doesn't really work. So that just gives us the object. So let's try console.dir on this h1. And so now we get the actual object. So here we have all this different stuff and all these properties and methods that we already worked with. But what I'm interested in here is the prototype. And you see that the prototype is an HTML heading element. All right. And so that itself will contain a lot of different stuff, one more time. So let's scroll all the way down. And so this is now an HTML element. And do you remember these names here from somewhere? Well, these are exactly the types of objects that we talked about in one of the first lectures in the DOM section. Remember that? So we had this big diagram with all these different types of elements. And so now here we can actually inspect them. And so behind the scenes, these different elements are really different like constructor functions. So if we go down here, we should now see element. And indeed, here it is. And so again, you can recall that diagram that we inspected there. And then you will remember that HTML element was a child element of element. And element itself was a child of node, right? And so therefore the prototype of element is gonna be node. So if we scroll all the way down here, then you see indeed node. And now this one is event target. And so you see this is a huge, huge prototype chain. And only now we are at the end. And so the end is then object. And that's it. So this prototype chain has easily 6 or 7 levels. And so you see that it can go really, really deep. So if you want to go and check this out by yourself, then that would probably be a really nice exercise. And finally, let's just also console.dir some random function. So the function doesn't matter. I just want to be able to look at the function. Okay. And so as I mentioned a bit earlier in this video, the function itself is also an object. And so therefore, it also has a prototype. And in this case, the prototype will then contain the methods that we have used previously on functions. So that's apply, bind, and call. Remember? And so once again, this is the reason why we can actually call methods on functions. It's because they are objects, and objects have prototypes. And in this case, this function prototype. So you can spend a lot more time if you're really interested in exploring all of this. But once you think you have a good understanding of all the previous lectures, then you can move on to the next video, which is going to be the first coding challenge of this section. Welcome back to your first coding challenge of this section. So now it's time to finally put everything that you learned in this section so far into practice. So in this section, I want you to use a constructor function in order to implement a very simple car. All right. So for this purpose, a car has just a make and a speed property. And the speed is simply the current speed of the car measured in kilometers per hour. Then I want you to implement an accelerate method that will increase the car's speed by 10, and it should also log the new speed to the console. Then another method called brake, which will then decrease the speed, but only by 5. All right. And finally, I want you to use this test data down here to implement these 2 cars. So basically to create 2 car objects and then experiment with calling the 2 methods that we just created on each of the objects. And of course, you should use all the knowledge from the previous lectures to doing this. So I hope that this is a fun challenge that's not too hard. So take all the time that you need, and I see you back here when you're ready with my solution. All right. So hopefully you did that successfully. So let's get started here. So we create the constructor function for car, and one more time with a capital C. And then we want each car object to have a make and a speed. And so that's the arguments that we're going to pass into this function. And then just as before, on the this property, we will set the make to the make that we receive and the speed to the speed that we receive as well. And so this is basically always going to work the same way. So as I mentioned, this is a pattern that developers came up with. And so now we just simply follow this like a recipe. All right. And with this, we can actually already create our two cars. So let's say the BMW is a new car. And so remember, this new operator here is what's going to enable all of this to work. And so here the make is of course BMW, and the speed is 120 kilometers per hour, which for my American friends is 75 miles per hour, I believe. So the next one is going to be the Mercedes. So that's new car, and at speed 95 kilometers per hour. Okay, so let's just take a look. And so yeah, that appears to be working just fine. And so now let's implement our two methods here. So accelerate and brake. And of course, we are not going to add the method right here. So we will not do this dot accelerate, because as we just learned before, that would be terrible for performance, especially if we had many car objects. So instead, we will of course make use of prototypal inheritance. So we take the prototype property of car, and to that we add the accelerate property. Accelerate, that's correct. And we make it a method by passing in a function, or actually by specifying a function here. So once again, we can use the this keyword in here, because that is simply going to be the object on which the method will be called. And so that object will have the speed property. And so here we can then increase that by 10. And then we can also log that to the console. And we can even make use, of course, of the make. So this one wasn't specified in the text, but we can log a nice string like this is going at this dot speed, and then kilometers per hour. But again, this part you wouldn't have to implement like this. And now let's just take this here for the brake, because it's going to be pretty similar. So brake, and all we do then is to decrease the speed by 5. All right, and now let's just call this on the BMW a couple of times. So BMW dot accelerate, and let's do that 3 times. And so after 3 times, the BMW is going at 150 kilometers per hour. So apparently that works just fine. Let's just add a brake here in the middle. And so now we reduce the speed a little bit and then back up to 145. Okay, and that's actually it. That's all we had to do in this challenge. And maybe with this example, you can start to see the advantages of object-oriented programming in action. So all the advantages that we talked about right in the first lecture of this section. And essentially the part where we learned that in object-oriented programming, we pack both the functionality and the data into objects. And so that's exactly what we have here. So each of these objects, so BMW and Mercedes, contains the state of the car, so the current speed and the make, and it also contains the functionality to manipulate its own data. So the accelerate and brake methods in this case are able to manipulate the speed, right? And at the same time, these two methods also form the public interface of this object, right? So right now the rest of our code can interact with these objects by calling the brake and the accelerate methods. Now in this case, of course, this is just a very small and isolated example, so it can still be hard to see the advantages of this, but maybe you can take a minute or two and compare this style of coding with the code that we have written up until this point in the course. All right, so at some point you will see that this is really a completely different way of thinking about our code. But anyway, that's it for this challenge. In the next video, we are going to talk about ES6 classes. So I hope to see you there soon. So we learned how to implement prototypal inheritance with constructor functions and then manually setting methods on the constructor function's prototype property. But now it's time to turn our attention to ES6 classes, which essentially allow us to do the exact same thing, but using a nicer and more modern syntax. Now, as I mentioned earlier, classes in JavaScript do not work like traditional classes in other languages like Java or C++. So instead, classes in JavaScript are just synthetic sugar over what we learned in the last few videos. So they still implement prototypal inheritance behind the scenes, but with a syntax that makes more sense to people coming from other programming languages. And so that was basically the goal of adding classes to JavaScript. But anyway, let's now implement person using a class. So we can write class and then the name of the class. And let's actually call it person CL. So that stands for class. And then curly braces like this. And so this is actually a class declaration. But just like in functions, we also have class expressions. And so that would work like this. So class expression and class declaration. And so then you can pick whichever you like the most. So it would be person CL and then class. And then just like a function, but without the arguments. Okay? And that is because, in fact, classes are just a special type of functions. Okay, so although we use the class keyword here, behind the scenes, classes are still functions. And therefore, we have class expressions and class declarations. Now, for some reason, I prefer the class declaration, and so I'm going to use that right here. And so this is how we write a simple class. And then inside the class, the first thing that we need to do is to add a constructor method. So just like this, and this constructor actually works in a pretty similar way as a constructor function, so as we studied previously, but this one is actually a method of this class. And in fact, it needs to be called constructor, so that is the rule. But just like in constructor functions, we pass in arguments basically for the properties that we want the object to have. So that's again first name and then the birth year. Now the act of creating a new object actually also works in the exact same way as before. So using the new operator. And so therefore, whenever we create a new object, so like a new instance using the new operator, this constructor will automatically be called. So let's actually try that right away. And this time let's create Jessica here. So new person CL. And so as you see, everything here looks exactly the same as before. So it looks just like a regular function call. And again, we also use the new keyword here. And so therefore, just like before, the this keyword here inside of the constructor will also be set to the newly created empty object. And so just like before, we set the properties of the object like this. So this.firstName is equal to first name that we receive, and the same for the birth year. All right. So basically, when we create a new instance here, then it is this constructor that is going to be called, and it will return a new object, and then that will be stored here into Jessica. So let's just log this to the console. And so in fact, it looks just like before. All right. So here we basically have the properties that will be stored in the new object that we want to create. And so now it's time for the methods. And the methods we simply write like this. So we can simply add them here, and all we have to do is to write their name. So just like a regular function in here. So this is very nice and very convenient. And so let's simply do the same as before. So this dot birth here. Now, what's important to understand here is that all of these methods that we write in the class, so outside of the constructor, will be on the prototype of the objects and not on the objects themselves. So this is really just like before, prototypal inheritance. And in fact, we will be able to confirm that now. So as we open up person CL here, and in fact, we're going to be able to confirm that here. So as we inspect this Jessica object, when we look into its prototype, then we will once again see the calc_h function here. All right. And so therefore, of course, we're going to be able to do this. And actually, we don't even need to log it to the console because the calc_h method already does that on its own. And so indeed, we get an h here. And so one more time, let me prove to you that Jessica underscore proto underscore underscore is equal to person CL dot prototype. And it is true. And so as you see, person CL here acts just like any other function constructor, with the only difference that this looks a little bit nicer. So with this syntax, we don't have to manually mess with the prototype property. All we have to do is to write the methods here, so inside the class, but outside of the constructor, and then they will automatically be added to the prototype property of the class, basically. So let me actually write that here. So they will be added to the prototype property of the person class, which once again is going to be the prototype of the objects created by that class. And we can take this demonstration even further by also adding a method manually to the prototype. So that's going to work just as fine. So let's create a greet method here. So let's just say, hey, this dot first name, and then we can call this on Jessica. So of course, Jessica dot greet. And so, as you see, that works just as well. All right. And so this is proof one more time that the class really just hides the true nature of prototypal inheritance in JavaScript. So of course, we could now do the same like this. And notice how there are no commas between the methods. Okay, so we could do this, take out this, and it would work the exact same way. You see? So this is great for people who are coming from another language and have experience with object-oriented programming, because it's going to be a bit easier for these developers to start writing object-oriented code in JavaScript. Now, if you're one of these developers, then please make sure that before just starting to use classes, you really truly understand function constructors and the prototype and the whole prototype chain logic. Now, to finish, I just need to say a couple more things about classes that are important to keep in mind. So first, classes are not hoisted. So first, let's scroll a bit here. Classes are not hoisted. And so even if they are class declarations. So function declarations, remember, are hoisted, which means we can use them before they are declared in the code. But with classes, that doesn't work. Second, just like functions, classes are also first-class citizens. First-class citizens. And so what that means is that we can pass them into functions and also return them from functions. And as I mentioned before, that is because classes are really just a special kind of function behind the scenes. And third, the body of a class is always executed in strict mode. Classes are executed in strict mode. And so even if we didn't activate it for our entire script, all the code that is in the class will be executed in strict mode. All right? So keep these points in mind if you want to work with classes. So now at the end of this video, you might ask if you should use constructor functions like we have been doing, or if instead it's better to just use classes. And the first remark I want to do here is that constructor functions are not like old or deprecated syntax. So it's 100% fine to keep using them. So one more time, this is more a question of personal preference. Now, if you're asking if you should use classes without understanding prototypal inheritance, well then the reply is definitely no. Now, some people actually say that classes are really bad in general and that no one should ever be using them simply because they hide the true nature of JavaScript. But I actually don't agree with that, and I think it's absolutely okay to use classes in your code as long as you understand everything that I just showed you previously about the prototype and prototypal inheritance. So you cannot just skip that part because you want to become an expert in JavaScript, right? And you also want to feel comfortable while writing your code, and that essentially means to understand exactly what your code does. So that's super important too. And so if you want to be confident, you need to understand. And so that's also the whole reason why all over the course I am going into such deep detail into how everything works in JavaScript. Now, what I personally like about classes is that they visually put all the code that belongs to a certain class. So like all the data here and all the behavior all into one nice code block like this. With function constructors, in my opinion, it all looks just like a big mess. So like this. I mean, in this case, it's just a little bit of code, but this can get out of hand pretty quick. And in these situations, I think that this actually looks at least a lot better. But of course, that is just my personal opinion. What matters is that you start thinking about this yourself and take your own decisions based on what I'm explaining in these videos. Let's now talk about a feature that is actually common to all objects in JavaScript, and that's getters and setters. So every object in JavaScript can have setter and getter properties. And we call these special properties accessor properties, while the more normal properties are called data properties. So getters and setters are basically functions that get and set a value. So just as the name says, but on the outside, they still look like regular properties. And so let's first take a look at getters and setters in a simple object literal. And for that, I'm going to use the bank account example from the Bankist application. So, very simple object literal here. The owner is Jonas. Then some simple movements. So the values here don't really matter. Okay. Oh, and of course, I'm writing this object all wrong. Maybe you have already been noticing that. Okay, but now it should be correct. All right, but now to add a getter to this object, we can start by basically writing a normal method. So let's say that we want a method to get the latest movement. And so let's call it latest. And then to transform this into a getter, we simply prepend the keyword get. All right. And so let's simply return the last movement here. So that's this dot movements dot slice -1. But this is actually going to return an array. So an array with the last position. And so we can simply take that out using the pop method. And we could have used the structuring as well, but I didn't want to save this into an external variable first. And so now we can use this getter like this. So a count, and then we say latest, but we simply use it as a property. All right, so we don't call the method, but instead we write it as if it was just a property. So let's see, and indeed that returns 300. So this can be very useful when we want to read something as a property, but still need to do some calculations before. Okay, and now we can do the same also as a setter. So we say set latest again, and then here we can basically add a new movement to the array. And any setter method needs to have exactly one parameter. So in this case, that's simply a movement. So let's say this dot movements dot push, and then that movement that we just passed into. Now it is not mandatory to specify a setter when we have a getter for the same property. Okay, so just the getter or just the setter would be enough. And so how do we use the setter now? So if it was a regular method, then we would have to do this. So account.latest and then call it with the movement, let's say 50. But now this is actually like a property and not a method. And so we can simply set it just like we set any other property. So we essentially set it equal to 50. And so now if we take a look at the movements here, it will then give us the complete array with the 50 there at the end. And so in a nutshell, this is how getters and setters work for any regular object in JavaScript. Now, however, classes do also have getters and setters, and they do indeed work in the exact same way. And so let's try them out now here in our person class. So here we can, for example, add a getter for the age property. So we can say get age, and then we return the age. So this is of course very similar to the calc age method that we already have here, but that doesn't matter because this is really just a demonstration example. All right. And so like this, we will be able to basically read the age of any object using a property. So let's try that here. For example, Jessica.age, and this time we actually need to log it to the console. And you see here, we now get the same value. All right. So you see that the getter is indeed just like any other regular method that we set on the prototype. And in fact, we can also check that out here. So if we take a look at the prototype of Jessica, it will be right there. Now it has these dots here because it's only calculated once we actually click this. Okay. So here too, it already looks as if it would be a property and not a method. We still have the get method down here, but then it's also kind of added as a property. All right. So that's a very simple use case of a getter, but setters and getters can actually be very useful for data validation. And as an example, let's try some validation with the name. So for that, I will actually change first name here to full name. And so now here we expect a full name. So a name which basically contains a space. So let's say Jessica Davis here. And so now we can create a setter for the full name property, which will check if this is actually a full name. All right. So set full name, and then we need the name itself. And then here we need some logic. So to test if it contains a space, if the name includes a space, and I'm not sure if it is called includes actually. Now let me just test it here very quick. Okay, we have to comment out this part. All right, so this method actually does exist. So I wasn't sure if it only exists on arrays, but indeed it also exists on strings. And so in this case, then we actually want to set this dot full name to the name that was received. But if not, we want to give an alert. So the given name is not a full name. So in this case, what's really important to understand is that we are creating a setter for a property name that does already exist. So full name is already a property that we are trying to set here, but then we also have the setter. And so now what's going to happen is that each time this code here is executed, so whenever we set the full name on the this keyword, then actually this method here, so this setter, is going to be executed. And so that name that we pass in as full name will then become this name. All right, let's check that out actually. And so now as we create Jessica here, you will see, and indeed we saw Jessica Davis here, but now we got this crazy error here of maximum call stack size exceeded. Now that's a very cryptic error message, but what happens here is that there is a conflict. So right now both the setter function and this constructor function are trying to set the exact same property name. And so that gives origin to this weird error. So what we need to do instead is to here create a new property name. And the convention for doing that, so when we have a setter which is trying to set a property that does already exist, then here as a convention we add an underscore. So again, this is just a convention, it's not a JavaScript feature. So it's really just a different variable name to avoid that naming conflict. However, now when we do this, we are actually creating a new variable. So a full name variable. So let's try this now actually. So if we try to look at Jessica Davis, you see that right now the property that exists is underscore full name. And so right now we cannot do Jessica.fullName because that simply doesn't exist. And so to fix this, we now also need to create a getter for the full name property. And so that will simply return the underscore full name. So let's see. So return this dot full name. And so if we try to do the same now, then you see that we are back to having this full name here. All right. And of course, the actual property that is here is now still underscore full name because, well, that's what we do here in the setter, right? But then we can also compute this full name just as we can compute DH. So this pattern here is important to understand whenever we try to set a property that already exists. Now let's try another name here, just to see what happens. And actually, after all this, So let's create a Walter object here. New person CL, that's right. And now we're just using a name with one word, let's say 1965. And so now we get this error. So Walter is not a full name. And so right now, if we check out Walter, it probably doesn't have any name. And yeah, it doesn't. So just the birth year now. But if we then put it as a full name, so Walter White, then indeed Walter like this, then we get the underscore full name. But just like before, we can then also access Walter.fullname because of that setter, or actually of that getter that we just defined earlier. Okay, great. So this is another nice feature of classes that can be very useful sometimes. Now, we don't need to use getters or setters, and many people actually don't, but yeah, as I just said, sometimes it's nice to be able to use these features, and especially when we need like a validation like this by the time we are creating a new object. So that's essentially what this setter here does. Next up, we're going to take a look at yet another feature of classes, which is static methods. So let's check that out right now. In this short video, let's quickly gonna talk about static methods. Now, a good example to understand what a static method actually is the built-in array.from method. And let's just do that here in the console. So remember that we have the array.from method, which converts any array-like structure to a real array. So for example, document.query selector. All right. So that's an error right there. And so you see, this now returns an array to us. And for some reason it is empty. Oh, and that's because query selector doesn't return a node list. So let's try query selector all. And so now indeed we get an array here. But that's not really the point. What's the point is that this from method here is really a method that is attached to the array constructor. So we could not use the from method on an array. So this is not going to work. All right, so from is not a function. And so that is because this from method here is really attached to the entire constructor, so the array constructor, and not to the prototype property of the constructor. All right, and so therefore all the arrays do not inherit this method. Again, because it's not on their prototype. It's simply attached to the constructor itself. So array.from here is basically just a simple function, but it's a function that's attached to the array constructor. And the reason for that is simply so that developers know that it is related to arrays. We also say that the from method is in the array namespace. And we actually used that term before for some methods in the number and in the internationalization namespace. Remember, for example, number.parse float. So that's the same thing. Okay, so this method is another static method, and it's static on the number constructor. So it's not available on numbers, but only on this very constructor. All right, so these are some good examples that we understand what a static method is, and we usually use these kind of as helpers that should be related to a certain constructor. And so maybe you can imagine that it should be pretty easy to implement static methods or selves. And let's do that for both our constructor function and also for the class. So here I already have the constructor function that we wrote right in the beginning of the section. So this person here. And so to add a static method, all we have to do is write person, and let's say I want to create a very simple hey function. Okay, so which simply like waves when we call it. So let's just say console.log hey there, and then maybe some emoji so we can actually see it a bit better in the console. And so now, in order to call this, it is pretty easy. We just have to do person.hey, and that's it. So somewhere up here, we now should get this hey there. Great. But of course, this one is not inherited. So just like we cannot call the from method on an array, we cannot say Jonas.hey, because it simply is not in the prototype of the Jonas object. So there's no way that the Jonas object could inherit it. All right. Now, let's just take a look at the this keyword here. But this again should be pretty obvious. And so that's essentially the entire constructor function here. And the reason for that is because that is exactly the object that is calling the method. And so, as always, that is basically the rule. So whatever object is calling the method will be the this keyword inside of that function. And so here, that this keyword is simply that entire constructor function. Great. And now let's quickly take this and do the same in the class, where it is even easier. So here, to create a static method, all we need to do is to add the static keyword. So static hey, and then that's it. So let's just write that here. So that is a static method, while these ones is what we call instance method. So as it says here, these are methods that will be added to the prototype property so that all instances can have access to them. And therefore the name instance methods. Okay? And so now we can simply, let's do it here at the end. We can simply do person.cl dot hey. And so again, we get hey there. And this time the this keyword points to the entire class. All right. So keep in mind that these static methods are not available on the instances, and sometimes they are still useful to implement some kind of helper function about a class or about a constructor function. So we learned about constructor functions and ES6 classes, but there is actually a third way of implementing prototypal inheritance, or delegation, as we can also call it. And that third way is to use a function called object.create, which works in a pretty different way than constructor functions and classes work. Now, with object.create, there is still the idea of prototypal inheritance. However, there are no prototype properties involved, and also no constructor functions and no new operator. So instead, we can use object.create to essentially manually set the prototype of an object to any other object that we want. Okay, so if we can set the prototype to any object, let's actually create an object that we want to be the prototype of all the person objects. So essentially, let's recreate the person class from earlier. So let's say person, and then I'm calling it person proto, which stands for prototype, because again, this object is going to be literally the prototype of all the person objects. Okay? And now this is actually just a simple object literal. And so now what should we actually put in here? Well, we're going to put exactly what we put before into the prototype property. And so that was the calc_h method, right? So we did that actually here first manually. So we added calc_h to the prototype property of person. And then here we also did that, but in a more implicit way. So JavaScript did that for us behind the scenes. But now let's take this function here, or actually we can take all of this, because we can also write methods in this way in object literals. And so that's actually it. That's all the methods that we want the person objects to inherit. And so we put them in the prototype, and now all we need to do is to actually create a person object with this object here as the prototype. And for that, we can use object.create. So let's create a person called Steven here. And so now object.create, and here we pass in the object that we want to be the prototype of the new object. So that's person proto. And so this will now return a brand new object that is linked to the prototype that we passed in here. So Steven here is right now an empty object, and it will be linked to this person proto object, which will be its prototype. And we can actually already see that here in the console. So as I said, for now it is empty, but we already have the prototype, and in there we see we have calc h. All right. But now we don't have any properties on the object yet. So let's quickly fix that. So Steven.name. So I'm doing it here just like I would do in any other object literal. And so this is not ideal, of course, but we're going to fix that in a minute, because of course we want actually a programmatic way of creating new objects instead of having to do it like this. But again, for now, we are just worried about the prototypes and the prototype chain here. So we should now be able to say Steven.calcH, and yeah, that worked. And so you see that we, just like before, implemented prototypal inheritance, but in a completely different way. And now, just to make sure that we're all on the same page here, let's make sure that we really understand this big difference. And so let's take a look at a diagram of what's really going on here. So here at the right side, we have the way it works with the constructor functions, just as we have been doing it up until this point. So when we use the new operator in constructor functions or classes, it automatically sets the prototype of the instances to the constructor's prototype property, right? So this happens automatically, and so that's nothing new at this point for you. Now, on the other hand, with object.create, we can set the prototype of objects manually to any object that we want. And in this case, we manually set the prototype of the Steven object to the person proto object. And that's it. Now the two objects are effectively linked through the proto property, just like before. So now looking up properties or methods in a prototype chain works just like it worked in function constructors or classes. And so the prototype chain, in fact, looks exactly the same here. The big difference is that we didn't need any constructor function and also no prototype property at all to achieve the exact same thing. So this is actually a bit more straightforward and a bit more natural, and I guess that it might also be easier to understand. However, the reason why I'm showing you this object.create technique right at the end is because in practice, in the real world, this is actually the least used way of implementing prototypal inheritance. However, it's still very important to know exactly how object.create works, because you will still stumble upon this in the real world. And even more importantly, we will need object.create to link prototypes in a next lecture in order to implement inheritance between classes. So with that, we're going to take object-oriented programming to a whole new level And the object.create function is going to be crucial in that, as we will see. And of course, we can now verify everything I just said using code here. So we can do Steven.__proto. And so that is now exactly the object that we specified up here. So you see, this is exactly person proto. And that makes sense, right? Because here we said explicitly that person.proto should in fact be the prototype of Steven, right? And so therefore, this of course is going to be true, right? And it is. So now that we know exactly what's going on here, let's quickly create another person. So const Sarah equals object.create. And once again, here we use person proto. But now in order to set properties on this object, let's do it in a better way than what we did here. So doing this is a little bit weird, and it goes against the spirit of creating objects programmatically. So if we're serious about using object.create, we should implement a function that basically does this work for us. So let's create a new method here, and this can have any name. So I will call it init, but this is going to be a little bit similar to the constructor that we have in classes. So this one will also get a name, or let's say first name, and a birth year. And then just like before, we will use the this property and set first name to first name, and then this.birthyear, set it to birth year as well. And so you see that this looks a bit like the constructor function that we created earlier, right? However, this has actually nothing to do with any constructor function, because we are not using the new operator to call this, right? We will simply do Sarah.init, and then we will pass in the arguments. So let's say Sarah and 1979, for example. And so let's then use calc_h here as well. And so then that just works beautifully as well. So here the this keyword will of course also point to the Sarah object now, but it does so because we explicitly called init on Sarah. So again, this has nothing to do with the constructor functions that we saw earlier, and it's also completely different from the constructor method that we have in ES6 classes. This is just a manual way of basically initializing the object, and this here could be any name. And indeed, we could have a method like this in any other object literal. All right. So essentially, this is how object.create works. So the big takeaway is that object.create creates a new object, and the prototype of that object will be the object that we passed in. So that's what matters from this video, and that's very important to understand in the future when we will implement true class inheritance, because for that we are going to need object.create. Now it's time to practice everything that you just learned about ES6 classes. And so let's now do coding challenge number 2. And the goal of this one is to basically recreate challenge number 1, but this time using an ES6 class. Then besides that, I also want you to add a getter, which should be called speed_us, and this one should return the current speed in miles per hour. So remember that the original speed is in kilometers per hour, and people in the US are usually not used to that, and so we can create a special getter called speed_us. And to do the conversion from kilometers per hour to miles per hour, all you need to do is to divide by 1.6. Then you should also implement a setter with the same name of speed_us so that people can basically set the speed also in miles per hour. But of course, that value should then be stored in the class as kilometers per hour. And so before storing the value, you need to multiply it by 1.6, so to convert it back to kilometers per hour. And then take this test data number 1 here and create a new car and experiment with all of the methods and getters and setters. So have some fun with this one, and I see you back here once you are ready. Okay, so hopefully you did that without any problems and you don't even need my solution. But of course, as always, I will still show it to you. And what I'm going to do is to simply copy the code that we wrote earlier, and I will then convert it to a class, because that's actually not that hard. So here we just need to call it class, and let me call it CL again for class. Okay, so then the curly braces, so one in the beginning, one in the end. Then this function is actually called the constructor, and the rest is the same. Here we don't need these, and here we don't need the prototype. So that's the whole point of using classes. And then we don't need this function. And besides that, that's actually it. So that's the constructor function plus the methods that we added to its prototype property, simply converted to a class. All right, so that was pretty easy. Now let's talk about the speed_us getter and setter. So first up, the getter, which is easier. So speed_us, and this one does not need any input. And it will simply return this.speed and then divide it by 1.6 as I instructed up there in the text. All right, and let's already test this now. And the test data here is Ford going at 120 kilometers per hour. So that's a new car CL with the make of Ford and the speed of 120. So let's accelerate here a little bit. But before we do that, let's actually also read the speed in US, because I actually know that 120 is 75 miles per hour. And so then I can know if this actually worked. And this one here simply returns the value. And so we need to log it to the console. All right. So indeed, this 75 here coming from line 270 is this speed_us property. So again, we basically transformed a method here into a property so that we read like this by using a getter. Then we accelerate a little bit, so we increase to 130. And so that means that these methods, they keep working. And so our conversion to class works flawlessly. And now to finish, let's just implement the setter here as well. So set speed_us. And then remember, we always need to take exactly one argument. So that's going to be the speed, of course. And so here we want to set the speed, but of course, in kilometers per hour. And so we take the speed and multiply it by 1.6. And so now if we do Ford.speed equals 50 miles per hour, then let's take a look at the Ford object. And here, of course, it needs to be US. All right. And so here we set the speed to 50, and then what we get here is 80. And so 80 is indeed 50 times 1.6. And so I think that's actually it. And yeah. So, challenge number 2 completed. So, over the last couple of lectures, we explored how prototypal inheritance works in JavaScript, and we did that using a couple of different techniques. So we used constructor functions, ES6 classes, and object.create. Now, all of these techniques basically allow objects to inherit methods from its prototype, so to delegate their behavior to their prototype, right? But now it's time to turn our attention to more real inheritance, so in the way that we learned in the very first lecture of this section. So what I'm talking about is real inheritance between classes, and not just prototypal inheritance between instances and a prototype property like we've been doing so far. And I'm using class terminology here because this simply makes it easier to understand what we're gonna do. But of course, you already know that real classes do not exist in JavaScript. But anyway, here is what we're gonna do. So we will create a new student class and make it inherit from the person class that we have been using so far. So person will be the parent class and student will be the child class. That's because student is basically a subtype of a person. So a student is also a person, right? But it is a more specific person. And so this is an ideal child class. Now, this is really useful because with this inheritance setup, we can have specific methods for the student, but then the student can also use generic person methods like the calc_h method that we have been using. And that's basically the idea of inheritance that we're going to implement in this lecture. Now, just like before, we will start by implementing this using constructor functions. So in this lecture, we will inherit between classes using constructor functions. And this is going to be a bit of work, but it will allow you to understand exactly how we set up the prototype chain in order to allow inheritance between the prototype properties of two different constructor functions. Then in the next lecture, we're going to do the same thing using ES6 classes, which, as you would expect, is a lot easier. And finally, of course, we will go back to using object.create as well. All right, but enough talk, let's put this into practice now. So here I already have the person function constructor that we have been working with in the beginning of this section, and also the calc_h method that we set up on the prototype property of person. So this is just a copy of what we already did. And so now let's continue by building a constructor function for the student. So const student. Now usually we want a child class to have the same functionality as the parent class, but with some additional functionality. And so usually we pass in the same arguments, but then also some additional ones. So that's going to be again first name and birth year. And then we will also pass in the course. And so now everything works the same here. So first name is going to be first name. This dot birth year is birth year. And finally, this dot course is going to be the course that gets into the function. So you see that in fact, this student class here has kind of the same data as the person. So it also has the first name and the birth year, but then it has an additional property, which is the course. So now let's actually create a new student. So I'm calling him Mike here. Born in 2020 and studying computer science. And just to make sure, let's log in to the console. And here indeed it is. Let's now quickly add a method as well. So we take the prototype property one more time, and then let's create a method called introduce. And so here we're simply gonna log like an introduction phrase to the console. So for the student to introduce himself. So my name is this.firstname and I study, and then the name of the course. So let's call that here Mike.introduce. And all right, so that works just fine. Great, so far so good. However, there is one thing that we can and should improve here in our student constructor function. So right now, this part of the code here is basically a simple copy of the person function constructor. So of this one that we want to be the parent class, right? And as you know, having duplicate code is never a good idea. First, because it violates the don't repeat yourself principle. But second, and even worse in this case, is that imagine that the implementation of person here changes in the future. Then that change will not be reflected in the student. So instead of having this duplicate code here, let's simply call the person function. So person, and then we pass in first name and the birth year as well. Now, do you think that this is gonna work? Well, let's see, and then I'm gonna explain you why this doesn't work. So the problem here is that we are now actually calling this person constructor function as a regular function call. So we are not using this new operator to call this person function constructor. And so therefore, this function call here is simply a regular function call. And remember that in a regular function call, the this keyword is set to undefined. And so therefore, that's why we get this error here, that it cannot set first name on undefined. So instead of simply calling the person function here, we need to manually set the this keyword as well. So do you remember how we can call a function and at the same time set the this keyword inside that function? Well, we can simply use the call method. So the call method will indeed call this function, but we will be able to specify the this keyword here as the first argument in this function. And so, in this case, we want the this keyword inside this function to simply be the this keyword inside this function here, right? Because, as you know, the this keyword is going to be in the beginning this empty object that is being created by the new operator. And so it is on that new object where we want to set the first name and the birth year property, right? So if we check this now, then it is back to working. And so this is a much better and more robust solution. Okay, so far, this is what we have built. So it's simply the student constructor function and its prototype property, and then the Mike object linked to its prototype. And that prototype is, of course, the constructor function's prototype property. Now this link between instance and prototype has been made automatically by creating the Mike object with the new operator. So all of this is what we had already learned. So this is nothing new at this point, right? Now a student is also a person. And so we want student and person to be connected like this. So we really want the student class to be the child class and inherit from the person class, which will then function as the parent class. So this way, all instances of student could also get access to methods from the person's prototype property, like the calc_h method, through the prototype chain. And that's the whole idea of inheritance. It's that child classes can share behavior from their parent classes. So looking at this diagram, basically what we want to do is to make person.prototype the prototype of student.prototype. Or in other words, we want to set the underscore proto property of student.prototype to person.prototype. And if this sounds confusing, then please just pause the video here for a minute and keep looking at this diagram for some more time. So that's why I created it. Okay? Now, anyway, we are gonna have to create this connection manually. And to do this, so to link these two prototype objects, we are gonna use object.create, because defining prototypes manually is exactly what object.create does. Great, so let's go do that. So let's do what I just showed you on the slide here in our code. And it's important that you do this at exactly this point of the code. Okay? And I will tell you later why that is. So anyway, student.prototype should be object.create person.prototype. And with this, the student.prototype object is now an object that inherits from person.prototype. Now we have to create this connection here before we add any more methods to the prototype object of student. And that's because object.create will return an empty object. And so at this point, student.prototype is empty. And so then onto that empty object, we can add methods like this one. But if we did it the other way around, so if this was after we created this method here, then object.create would basically overwrite this method that we had already added to the prototype object of student. Now, you might be wondering why we even needed to use object.create. So why didn't we just do this? So student.prototype equals the person.prototype, right? This maybe would have seemed a little bit more logical to do. But in fact, this doesn't work at all. And let me actually show you why that is. So if we do student.prototype equal to person.prototype, then we will not end up with the prototype chain that we need. Instead, we would end up with this, which is a completely wrong prototype chain. And that's because here we're actually saying that the student's prototype property and the person's prototype property should be the exact same object. But in fact, that's just not what we want. What we do want is the person's prototype object to be the prototype of student.prototype. So we want to inherit from it, but it should not be the exact same object. And that's why we actually needed object.create. All right, so let's get rid of this bad code. And here let's just say linking prototypes. And so now with all of this in place, we should be able to do Mike.calcAge. And indeed, we get the age of 17. Beautiful. So this worked just fine. And so let's actually now go analyze what exactly happened here. And we already know that this worked because of the prototype chain, but let's see exactly how. So when we do Mike.calcAge, we are effectively doing a property or a method lookup. So that is JavaScript trying to find the requested property or method. Now in this case, as we know, the calcAge method is of course not directly on the Mike object. It's also not in Mike's prototype. That's where we defined the introduce method, but not calcAge, right? So just like before, whenever we try to access a method that's not on the object's prototype, then JavaScript will look up even further in the prototype chain and see if it can find the method, so in the parent prototype. And that's exactly what happens here. So JavaScript will finally find the calcAge in person.prototype, which is exactly where we defined it. And that's the whole reason why we set up the prototype chain like this, so that the Mike object can inherit whatever methods are in its parent class, basically. So in summary, we are now able to call a method that is on a person's prototype property on a student object, and it still works. So that's the power of inheritance. Great. And since we're already here, let's also quickly complete the prototype chain. So just like before, object.prototype will sit on top of the prototype chain. So of course, we could still call a method like the hasOwnProperty method on Mike2. It doesn't matter how far away in the prototype chain a method is. And with this, we now have the full picture of how inheritance between classes works with function constructors. And of course, with ES6 classes, it works exactly the same internally. All that changes is the syntax. So when we do the same thing in the next video using ES6 classes, then keep in mind that it's going to work just like I described here. And so now, just to finish this video, let's quickly inspect all of this also in the console. Let's say Mike.__proto. And so this is of course going to be this object here, which contains the introduce method, right? So this is nothing new, but you see here right in the console that this itself has a prototype too. So let's try this here. And so see the next prototype. And so now this is indeed the prototype which contains the calc_age function. And so in fact, that is exactly this object here, right? And maybe it's even easier to visualize in the console like this. So taking a look at Mike itself, and then Mike's prototype is a person here, which is actually not correct, and we will fix that in a second. So, I mean, the prototype chain, everything is correct, but here it should say student. So you see that right now it says person, but Mike is actually of the type student. Okay, but anyway, here you see the introduce method that we defined earlier. And then if we go even further into this, so not this one, but this one, then you see, of course, the calc_age function, which is in the prototype of the prototype, basically, right? So what I said that we need to fix is this. So when we take a look at student.prototype.constructor, then remember that ideally this should point back to the student, right? But here it points back apparently to person. So actually we should use console.dir. And so you see that JavaScript now thinks that the constructor of student.prototype is person here. And the reason for that is that we set the prototype property of the student using object.create. And so this makes it so that the constructor of student.prototype is still person. So we need to fix this because sometimes it's important to rely on this constructor property. And so if we want to rely on that, it should indeed be correct. But that's easy to fix. We can just say student.prototype.constructor and set it to student. But let me just try out some more things here. So just to make sure everything works. So we can again use the instance of operator here. And so this, of course, is going to be true because student is, of course, the constructor function of Mike. But if we try the same now with person, then that indeed should be also true. And so, in fact, it is. And so again, it's because we linked the prototypes together. So if we didn't have this, then this should be false. So of course, Mike.calcH is not a function in this case, because the prototype chain is now not correctly set up to find this method. But let's quickly take this out. And so now indeed Mike is no longer an instance of person. And of course, Mike is also an instance of object because that is also in its prototype chain. All right, so here we just proved that the prototype chain is in fact set up the way that we intended it to be. All right, and that's the end of a very long and, I admit, complex lecture. But I hope that I could still consolidate your knowledge about prototypes and the prototype chain even further, because now you know how to even manipulate the prototype chain yourself manually. And actually, let's now go test if you did actually understand right in the next coding challenge. Let's now immediately apply what you just learned here in coding challenge number 3. And in this one, I want you to use a constructor function to implement an electric car class. So a class that should be called EV and which will be a child class of the car class that we created in the first challenge. So in the first challenge, you used a constructor function to create the car. And now here you're going to use the same technique to create the subclass. So basically the child class called EV. Okay? Now the EV, which stands for electric vehicle, by the way, also has a make and the current speed, of course, but it also has the current battery charge in percentage. And so that's here the charge property. And so here, in order to implement this child class, you will have to do exactly what we did in the last video. So basically connecting the two prototypes of these two constructors. Then on the EV class, I want you to implement a charge battery method, which takes in an argument called charge2, and it then simply sets the charge of the battery to that received value. Then also on this class, I want you to implement an accelerate method, which will increase the car speed by 20. And at the same time, it will also decrease the charge by 1%. And finally, this method should also print to the console a message like this. So the Tesla is going at 140 kilometers per hour with a charge of 22%. And that's Tesla here because that's the test data that you're going to use here. So create an object based on this test data here, and then, just like before, experiment a little bit with the accelerate and the brake and also the charge battery methods. And one important thing that I want you to do is to notice what happens when you accelerate. All right, so review the definition of polymorphism that I gave you right in the first video of this section to make sense of this. So I hope that this is another fun challenge, and I see you here once you're finished. Okay, so let me start by getting the code that we wrote in the first challenge. So of course, there's no need to write it again. And so here goes my solution, which I hope you didn't need. But of course, it's always good to know how exactly I implemented it. So EV is this function which has the same parameters as the car constructor. So that's the make and the speed, but then the additional property of charge. And so now, just like we did previously, we will not manually define the make and speed properties on the this keyword, but instead we will basically call the parent class. And so that's car.call, but with the this keyword that we are actually using in the EV. So we pass make and speed. And so again, this is exactly what we learned in the previous lecture. And then, of course, we need to still set the speed. And now let's actually create the new car here. So the new object. So that's a new EV, Tesla, going at 120. And the charge should start at 23%. Okay, let's take a look here. And the charge is not in there. Oh, yeah, that's pretty stupid mistake here. So of course, that's gotta be the charge. And so now it's all there. Okay, so that was the easy part. Now comes the trickiest part, which is to again link the prototypes. So we want the prototype property of EV to inherit from the prototype property of car. And so, therefore, we say object.create, which will create a new object. So it will set ev.prototype to the new object, which has as a prototype car.prototype. Great. And so now let's actually add some methods to the prototype of EV. So ev.prototype.charge battery. And this one is a function which takes in charge 2. And all it does is to set the charge to the charge that we receive here. All right. So let's experiment with this one. So Tesla.charge battery to 90. And so now if we take a look at Tesla here, it indeed now has the charge set to 90. All right. Now let's take a quick look actually here at the prototype chain. So let's see the prototype here. And so that, of course, now includes charge battery. Okay. And that in turn will contain accelerate and brake, which is the one coming from the car. And so one more time, this is exactly what we had in the previous lecture. So we had the introduce in the prototype of the student, and then in the prototype of the prototype, we had the calc8 method. And so here that is accelerate and brake. And so of course, we can now use that here. So we can say Tesla.brake, and then through the prototype chain, the Tesla object will have access to that. And so indeed, now it is going at 115 kilometers per hour. Okay, but now let's take care of number 3 here, which is to implement an accelerate method. So let's do that after the charge battery. So ev.prototype.accelerate. And this one will set the speed to plus 20, so it will increase it by 20, and it should decrease the charge by 1%, remember. So just like this, and then we should also log a console, so a string to the console, similar to this one that we had before. So it's going at the speed, and then with a charge of, and then this dot charge. Okay, so let's call that right after the brake dot accelerate, and let's see what happens now. And it worked just fine. So we increased by 20, and the charge decreased indeed by 1. So indeed, it was this accelerate method here that was used, and that's important to notice, because the car itself also has an accelerate method, right? So we can see that here as well. So in the prototype of the Tesla, we now have accelerate, but in the prototype of that itself, and so that's going to be the prototype of car, we also have accelerate, right? But JavaScript, of course, used the first one. So when there are two methods or properties with the same name in the prototype chain, then the first one that appears in the chain is the one that's going to be used. So the same is true also for the scope chain. And this is the behavior that makes sense. So with this, basically a child class can override a method that it inherited from the parent class. So if we didn't create this accelerate method here, then this would still work, right? Because then the Tesla would simply inherit the accelerate method from the car, right? Of course, now this wouldn't manipulate the charge, it would simply increase the speed by 10. But it would work because it can still find the accelerate method in the prototype chain. But now, as we have this, then this accelerate method will override the one from the parent class. And remember that this is exactly the definition of polymorphism that we talked about at the beginning of this section. And it might seem obvious that it works this way, but it's still good to remind ourselves that we can actually do this. Okay, and with that, we finished yet another coding challenge, and I hope that now it's really clear how we can have one class inherit from another class using constructor functions. And also, of course, the object.create function, because without it, this would be completely impossible. So great job of doing one more coding challenge. Next up, we will see how we can implement the exact same thing using ES6 classes. Let's now go ahead and implement the exact same thing that we did in the last video, but this time using ES6 classes instead of constructor functions. So here again, I copied the initial person class that we built a bit earlier, so that now we can inherit from this class. All right, and so down here, let's now create the student class. So class student like this. Now, as we know already, the class syntax hides a lot of the details that are actually happening behind the scenes. Because classes are really just a layer of abstraction over constructor functions. But that's no problem because we already learned how inheritance between classes actually works behind the scenes. So that's what we did in the last lecture and the coding challenge. And so now that we know how it works, we are ready to implement the same thing using classes, even though that hides how it actually works behind the scenes. So, to implement inheritance between ES6 classes, we only need two ingredients. We need the extend keyword and we need the super function. So to make this student class inherit from the person class, all we need to do is to say extends and then the person class. So CL, and this one I'm also going to call CL here, just to follow the same name. And that's actually it. So this keyword alone here will then link the prototypes behind the scenes without us even having to think about that. Then, of course, we still need a constructor, and this one will, just like before, receive the same arguments as the parent class, but then some additional ones. So birth year and also the course. Remember? Now here, we actually don't even need to manually call like personCL.call like we did before in the constructor function, remember? So here we don't need to do that. What we do instead is to call the super function. And so super is basically the constructor function of the parent class. So the idea is still similar to what we did in the constructor function, but here it all happens automatically. We don't need to specify the name of the parent class again, because that already happened up here. So here now all we do is to pass in the arguments for the constructor of the parent class, and so that's these two, because that's exactly the parameters that are also specified here in the parents constructor. Now here in this constructor, so of the child class, this always needs to happen first. So let me even write that here, needs to happen first. And that's because this call to the super function is responsible for creating the this keyword in this subclass. And so therefore, without doing this, we wouldn't be able to access the this keyword to do this. So always first the call to the super, so to the parents class constructor, and from there we will then be able to access the this keyword. Now, of course, we could actually have no other properties here at all. So this is not necessary. I mean, it's not mandatory. And so the same goes for this additional parameter. So in this case, this new student class would simply have new methods and share all the properties with the parent class. So what we're doing here is really just an example, but the possibilities are endless, right? And actually, if we didn't want to do this, then we wouldn't need any constructor function at all. So in this case, the super function would automatically be called with all the arguments that are passed into this constructor. So let me just create a new student here. So that's Martha. So new student CL, let's say Martha Jones, born in 2012 and also studying computer science. All right, but let me duplicate this here very quick, take this one out and only call this with these two. And then, as I was saying, we could have no constructor at all. And this would still work just the same. So you see that now we would end up with a student with the full name and the birth year just as specified. Now remember that this underscore here still comes from this setter function here. So that's what we specified earlier. And so of course, now the student will inherit all of that. Because in the end, these are really just methods too. And so all the students will now inherit all of these methods from the parent class. But anyway, this was just to demonstrate you that if we do not need any new properties, then you don't even need to bother writing a constructor method in the child class. But now let's take this back. This as well, and of course also this. And now let's see if this worked. And yeah, so now we have all the three properties here. Okay, now let's just quickly add the introduce method. So let me copy that from earlier. There's no need to write the same code. So that's the simple console.log that we're going to execute here. So introduce. And so now we can call that on Martha.introduce. And we get my name is undefined here. But that's because here we actually have the full name and not the first name. And so now that actually works. And the same should work for the calcH method that is in the parent class. So Martha.calcH. And indeed, that works as well. And so let's now take a quick look here at the prototype chain one more time, just so you can see that the prototype chain is actually just the same as before when we created it manually. So you see that indeed in the prototype of Martha, we now have the introduce method. So that's this one right here that we wrote in the class. All right. But now in the prototype of the prototype, we have indeed the calcH method and also the greet method and the age and full name setters and getters. And so this proves us that the prototype chain was indeed set up automatically by basically by this extends keyword here, right? Now, finally, just like we did in the previous challenge, let's override one of the methods of the parent class. So let's override the calc_h method here. And so all we have to do is to add a new calc_h right here. And then let's simply log to the console im, and then the h, so 2037 minus this dot birth year, years old, but as a student, I feel more like, and then let's basically add 10 to this date, because when you are in university and you study a lot, then you will feel actually a lot older than you actually are. All right. And so now indeed, this new method overrode the one that was already there in the prototype chain. And again, that's because this new calc_h method here appears first in the prototype chain. And so therefore, it is essentially overriding the method coming from the parent class. And we can also say that this calc_h method here is shadowing the one that is in the parent class. And so that's actually it. That's all I have to show you about implementing inheritance between classes using actual ES6 classes. And just to make sure that you got this 100%, I invite you one more time to check out the slides from the previous lecture. So the lecture where we did the same thing using constructor functions. So these slides, so these theory parts of the video, I believe are really, really helpful to understanding this. Now, to finish this part of inheritance between classes, let me just say that this mechanism of inheritance that we explored here can actually be very problematic and dangerous in the real world when we are designing software. However, that's going to be a topic for another day, and we're going to talk a little bit about this when we talk about functional programming, which, as I've mentioned a couple of times, is kind of the alternative to object-oriented programming. Anyway, next up, let's do the same thing with object.create. So that's the third way of implementing object-oriented programming in JavaScript. And now finally, let's look at how we can use object.create in order to implement a complex prototype chain, so similar to what we implemented before with classes and constructor functions. And so here I already copied this object here, which will serve as the prototype to create a new person object using object.create. All right. And so of course, this will basically be our parent class. And we already know that object.create is a bit easier to use and to understand. And so it shouldn't be too hard to implement a similar hierarchy between a person and student. So here, person proto, so this object up here, used to be the prototype of all the new person objects. But now we basically want to add another prototype in the middle of the chain. So between person proto and the object. And so what we're going to do is to make student inherit directly from person. So we're going to create now an object that will be the prototype of students. So student proto. And this will be, for now, an empty object. So object.create. And the prototype will be person proto. And that's it. And so now we can use this student proto to create new students. So let's create J and object.create, and it will inherit from student proto. And so now the student proto object that we just created earlier is now the prototype of the J object. So again, the student proto object is now the prototype of J. And the person proto object is in turn the prototype of student proto. And so therefore, person proto is a parent prototype of J, which means that it's in its prototype chain. Whoa, but that once again sounded a bit confusing. And so let's make sure that we really understand this by looking at a nice diagram again. So it all starts with the person proto object, which used to be the prototype of all person objects. But now, using object.create, we make it so that person proto will actually become the prototype of student proto. And what this does is that now, basically, student inherits from person. And so with this, we already established the parent-child relationship that we were looking for. Now to finish, all we need to do is to use object.create again, but this time to create a new actual student object. And of course, we make this student, so J in this course, inherit from student proto, which is now J's prototype. And like this, we created a nice and simple prototype chain. So J inherits from student proto, which in turn inherits from person proto. And therefore, the J object will be able to use all the methods that are contained in student proto and person proto. Now, with the scope chain correctly established, let's also add an init method to student proto. So just like we did here with person proto, so that we don't have to manually specify the properties on any new student object. So let's add that here to student proto.init. So this is going to be receiving the first name, then the birth year, and again the course. And so now we can actually use the same trick that we used before when we use constructor functions. So what I mean is to take advantage basically of this init method so that we don't have to write this same code again. So basically the child prototype can reuse this init method here from the person prototype, which is the parent prototype, right? So that is person proto.init.call, because once again, we want to set the this keyword to the this keyword in this method here. So this, and then the first name and the birth year. And then, of course, we set the course property here, which is unique to the student. So let's now use that method, j.init. So J born in, let's say, 2010, and again, computer science. All right, so let's take a look. And yeah, that works. That's nice. And let's now add again the introduce method here, just so that it is similar to the other two techniques that we used earlier. So introduce is going to be a function. And let me just again grab that from here. All right. And now let's call j.introduce. And indeed, that works. And now, as you would expect, we should also be able to call j.calcH, because that method is up here in the prototype chain. And so that has got to work as well. And yeah, so 27. And one more time, just to take a look here at the prototype chain, we see that indeed it has a prototype which contains the init and the introduce methods. So these two that we just created. And this prototype in turn has its own prototype, which is then the one which contains the calcH method. And so that is indeed person proto. So this is exactly the prototype chain that we just saw earlier in the diagram. Okay, and that's actually it. So in this version, we don't even worry about constructors anymore, and also not about prototype properties, and not about the new operator. So it's really just objects linked to other objects, and it's all really simple and beautiful if you ask me. And in fact, some people think that this pattern is a lot better than basically trying to fake classes in JavaScript. Because faking classes in the way that they exist in other languages like Java or C++ is exactly what we do by using constructor functions and even ES6 classes. But here, in this technique that I just showed you with object.create, we are in fact not faking classes. All we are doing is simply linking objects together, where some objects then serve as the prototype of other objects. And personally, I wouldn't mind if this was the only way of doing OOP in JavaScript. But as I mentioned earlier, ES6 classes and constructor functions are actually way more used in the real world. But in any case, it's still super important and valuable that you learned all of these 3 techniques now, because you will see them all in the real world still. And this also allows you to think about this on your own and choose the style that you like the best. But again, in the real world, and especially in modern JavaScript, you will mostly see ES6 classes being used now. And so, since I want to prepare you for the real world, I will start using classes from this point on. There are a few more things that we need to learn about classes. And so let's actually create a new class now. And as an example, we are going to use the bank account that we implemented before in the Bankist app. Remember that? So let's say class account. And then, as always, we need the constructor method. And here, each account should have the owner name. It should have a defined currency, and also we want to pass in a PIN. And so let's say this.owner is owner, and the same for currency and the PIN. So we already know how to do all of this, right? And so now let's create a new account here. Let's say account 1. And so new account, and let's say that I am the owner, so Jonas. Then the currency is in euro, and the PIN, let's say, is this one. All right. So indeed, we have the 3 values that we passed into the constructor now inside of the object. But now, what about the movements array and maybe also the locale? So we want to start always with an empty array as the movements, and the locale we want to get from the navigator.language. So how should we do that? Should we add a new parameter like this? So movement, and then always pass in like an empty array in all the accounts that we create? Well, that would work. So let's actually see that. So movements should be equal to movements here as well. And so now, as you see, the movements is now this empty array. However, it doesn't make much sense to pass in this empty array into all the new accounts that we want to create, right? So we don't need this, and instead we can simply do this. And so this is something that we didn't do before, but of course we can create even more properties on any instance and properties that are not based on any inputs. And the same we can now do for the locale and set it to navigator.language, right? And so now all of that appears here as well. And in fact, we can even execute any code here in this constructor that we want. So let's say, thanks for opening an account. And then owner. And so when Jonas opens a new account, then he is basically greeted with this message here coming right from the constructor. All right. But now what about the deposits and withdrawals? So basically, what about our movements? Well, we could simply now go ahead and do this. So we can take account1.movements, and then if we wanted to do a deposit, we could push a value into this, let's say 250, and then when we wanted to withdraw something, we would simply push a negative value. And so if we then take a look at our account here, then of course we would see these movements right here in our array. However, it's not a good idea at all to do this. So instead of interacting with a property like this, it's a lot better to create methods that interact with these properties. And that is especially true for important properties such as these movements here. So this will for sure avoid bugs in the future as your application grows. So let's now actually create a deposit and a withdraw method here. So deposit, and then here the value that we want to deposit, and then this dot movements dot push the value that we pass into. And now the same for withdraw. So also a value. And so here we can now actually call this method because it's actually going to work basically the same way. So this dot deposit. And so as you can see here, we can actually call other methods inside of a certain method. So in withdraw, we are calling this dot deposit. But of course, we still need to use the this keyword to be able to access this other method. And then here we pass in minus the value that we received in this function. So let's try this now. So instead of doing this, we now can do it in a much nicer way. So account1 dot deposit 250, and then account1 dot withdraw 140. And so indeed, our movements array looks just the same as before, but now we are actually using this public interface that we built here, right? So basically these methods here are the interface to our objects, and we also call this API, remember? So we talked about this right at the beginning of this section. So again, let's actually write this here. So this is the public interface of our objects. And so, yeah, this is a lot better than having to manually manipulate these properties outside of the object as we did here. Also, this withdraw method here actually abstracts the fact that a withdrawal is basically a negative movement. So here, as we did it manually, we needed to pass in minus 140. But now, as we do a withdrawal, it's of course a lot more natural to write that simply 140 are going to be withdrawn. So what I'm trying to say is that this minus here is something that the user of this object shouldn't be caring about. And so now we actually abstracted that away right into this object, and in particular into this withdraw method. So just a very small abstraction here in this case, but it's still worth to notice. All right. Now, of course, still there is nothing stopping someone on our team from interacting with the movements array directly and potentially making mistakes and introducing bugs. So simply the fact that we have these methods doesn't make it impossible to still do this. And the same goes, for example, for the pin. So of course we can access the pin from outside of the account. So you see, but probably it shouldn't be accessible from outside of the class. But yeah, of course, right now it is accessible. And this is actually a very real and very important concern. So it's not just something theoretical that I'm telling you here. And the same, of course, goes for methods. So let's say we have a request loan method here for some value. And remember that this was also a functionality of the Bankist application. So we could make the approval of the loan based on some condition. And that condition could come from some other method. Let's say approve loan. Let's pass in a value here as well. And this one will simply always return true. So I don't want to implement any complex logic here now. But anyway, here we can now call this.approveLoan with the value. And so if the loan is approved, then this.deposit of the value, and we can log something to the console. So loan approved or something like that. Okay. Now in the public interface, we basically only want this method here. So we want to be able to do this here basically, account1.requestLoan, let's say of 1,000. And so we see that the loan was approved and it was pushed into our array. But of course, we are also able to do this. So approve loan. And so this, of course, doesn't do anything. But in the real world, we should not even be allowed to access this kind of method. So this is kind of an internal method that only the request loan method should be able to use. And so the reason why I'm telling you all this is basically just to justify that we really need data encapsulation and data privacy. And we talked about these topics in the introductory lecture of this section. And so as always, you can go ahead and review that. But anyway, in the next video, we will finally start implementing data privacy and data encapsulation. So let's move on there right now. In the last lecture, we implemented a new class which showed us the need for encapsulation and data privacy. So let's now tackle this very important principle of object-oriented programming. Now, first, remember that encapsulation basically means to keep some properties and methods private inside the class so that they are not accessible from outside of the class. Then the rest of the methods are basically exposed as a public interface, which we can also call API. So this is essential to do in anything more than a toy application. Now, there are two big reasons why we need encapsulation and data privacy. So first, it is to prevent code from outside of a class to accidentally manipulate our data inside the class. And that's exactly what we did by the end of the last lecture here. So this is also the reason why we implement a public interface. So we are not supposed to manually mess with this property, and therefore we should encapsulate it. Now, the second reason is that when we expose only a small interface, so a small API consisting only of a few public methods, then we can change all the other internal methods with more confidence. Because in this case, we can be sure that external code does not rely on these private methods. And so therefore our code will not break when we do internal changes. So that's what encapsulation and data privacy are and the reasons for it. And so let's now actually implement it. However, JavaScript classes actually do not yet support real data privacy and encapsulation. Now, there is a proposal to add truly private class fields and methods to the language, but it's not completely ready yet. I will still show it to you in a next lecture because it's really cool, but even when this feature ships in the browser, it will take some time until you can use it with confidence. And so in this lecture, we will basically fake encapsulation by simply using a convention. So the first candidate to protect here is again this movements array that we have been talking about. So the movements are mission critical data And so here we will protect this data so that no one can accidentally manipulate it. And for now, all we will do is to add this underscore in front of the property name, and that's it. Now we need to then go ahead and change it everywhere. So that's here. And yeah, that's actually it. So again, this does not actually make the property truly private, because this is just a convention. So it's something that developers agree to use, and then everyone does it this way. But since it is not truly private, we call this protected. So protected property. And so now if we wanted to get the movements outside here, we could of course still do this. So that's what I was just saying, which is that the data here is of course still accessible if we use this underscore outside here as well. But at least now everyone on your team, and that includes yourself, will know that this property is not supposed to be touched outside of the class. So you can still do it, but at least you will know that it is wrong, okay? Now, if we still wanted to give access to the movements array from the outside, then we would have to implement a public method for that. So let's do that actually right here. So let's say get movements. And of course, we could also create a getter here instead of this method, but let's just keep it simple. So it's very common to actually have a method that is called get or set instead of using a real getter or a real setter. And so all that this will do is to return this dot movements. And so now this would be the correct way to get the movements. So get movements. And so this one, everyone can still at least access the movements, but they cannot override them. So they cannot set the movements. Unless, of course, they use the underscore with the convention, but then at least they will know that it's wrong to access the property. Next, we could also protect here the pin. So this is also something that doesn't make much sense to be accessible from the outside. And in fact, we could make everything protected here, but I think that like this, we are good to go. So this is just a small example anyway. And so for now, let's leave it like this. To finish, let's just also protect then the approve loan method. So this one I also mentioned by the end of the previous lecture. So this is a method that is only supposed to be internally by the bank, let's say, basically just to check if a loan should be approved. So essentially, this method here should not be part of the public API, but all the others should be. So right now we are protecting this method, and so our public API right now consists of these other 4 remaining methods. All right. So this is how we protect fields from unwanted access. Now, as I said, of course, developers need to know about this convention and need to follow it, because otherwise everything will still be public. But now in the next lecture, we're actually going to talk about truly private fields and methods. And so with that, we will then fix this problem for good. All right, so let's now implement truly private class fields and methods. So private class fields and methods are actually part of a bigger proposal for improving and changing JavaScript classes, which is simply called class fields. Now, this class fields proposal is currently at stage 3, and so right now it's actually not yet part of the JavaScript language. However, being at stage 3 means that it's very likely that at some point it will move forward to stage number 4, and then it will actually become a part of the JavaScript language. And that is probably going to happen some point soon in the future. And that's why I decided to already include class fields in this course. And in fact, some parts of this proposal actually already work in Google Chrome, but other parts don't, at least not at the time of recording this video. Now, for starters, why is this proposal actually called class fields? Well, in traditional OOP languages like Java and C++, properties are usually called fields. So what this means is that with this new proposal, JavaScript is moving away from the idea that classes are just syntactic sugar over constructor functions. Because with these new class features, classes actually start to have abilities that we didn't previously have with constructor functions. And many developers consider this to be a big problem, but personally, I'm not sure if it is such a big deal for the average JavaScript developer. So as long as you still understand how prototypal inheritance and function constructors work, then I believe that you will be fine. But anyway, no matter if you end up using these new class features, let's now start exploring them. So in this proposal, there are actually 4 different kinds of fields and methods. And actually it's even 8, but in this video, I'm just going to focus on these 4. And that's public fields, that is private fields, and then we have public methods, and we have private methods. So essentially, there is a public and a private version of both fields and methods. And let's now start with public fields. So we can think of a field as a property that will be on all instances. So that's why we can also call this a public instance field. So basically in our example here, the 2 fields could be the movements and the locale, because these are basically 2 properties that are going to be on all the objects that we create with this class. Because we do not pass any of the values here in, so into the constructor, and so this array and this language, they will always be set for all the instances, right? And so let's now add them as public fields. So that works simply like this. We can say locale equal and then navigator dot language. And then here we actually need to write a semicolon, which is kind of weird because between these methods, we do not need commas or semicolons. What's also weird is that this kind of looks like a variable here, right? But we don't have to declare it using like const or let. So this is how we simply define a public field. So let's write that here. So public fields. And the other one is going to be this movements. And I will still, for now, call it underscore movements. And so I'm setting it to this empty array now. And so when we reload this now, you will see that then the account here works exactly the same. So we still have the locale here and also the movements. But now they are actually public fields. But in our final object here, that doesn't make any difference. Because again, these public fields here are going to be present on all the instances that we are creating through the class. So they are not on a prototype. So this is important to understand. So all these methods that we add here, they will always be added to the prototype, right? But again, the fields here, they are on the instances. Let me write that here as well. And so again, having this here is essentially exactly the same as this. And therefore, these public fields, they are also referenceable by the this keyword, and they are also referenceable via the this keyword. Great. So that's public fields. Next up, let's talk about private fields. So this is number 2. This is number 1. Let's add that here as well. So just to keep a nice overview of all the things that we are learning here in this lecture. All right, so private fields is the one that we have actually been waiting for. So with private fields, we can now make it so that properties are really, truly not accessible from the outside. So just like in the last lecture, let's start by now finally making the movements array private. So let's move it here. And now I will remove the underscore, and then I will use the hash symbol. And so this is the syntax that makes a field private in this new class proposal. So let's try and reload to see what happens now. And indeed, we get some error. And the reason for that is that the property is now really called hash movements. So we need to change that everywhere. So both here and here. Yeah, that's it. Give it a save, and now it all works. So let's see. Here we now actually have the movements in this array, which is called hash movements now, basically. And so now we are finally going to be able to see that this property is indeed protected. So if we try to read account1.movements, then we get a syntax error. So private field movements must be declared in an enclosing class. So basically JavaScript thinks that I'm trying to implement this private class field out here, and that's the reason for this error. But what matters is that in fact we cannot access this variable outside here. And of course the movement property from before does now no longer exist. So we get undefined there. Now the error message here might look different for you by the time that you're watching this video. Because as I said, this proposal at the time of recording is not really finished yet. And so some implementation details might still change. And so that might also affect the error message here. And speaking of implementation, I believe that right now only Google Chrome actually supports these private class fields. And so make sure to also test your code in Google Chrome. But anyway, the movements are now truly private and no longer accessible outside here, at least not by their property. We do still have, of course, this method here in our public API. And so this one we can still use to get the movements. So that's right here. And that was indeed the whole point of creating this method in the first place in the last lecture. Now the next candidate to make private is this pin. So in the last lecture we protected it, but now just like the movements, we want to convert it to a truly private field. However, this time the situation is a bit different, because now we are actually setting the pin based on this input value to the constructor. However, we cannot define a field in the constructor. So the fields, they really have to be out here, outside of any method. So what we have to do is to create the field out here, so the private field, again with hash, and then don't set it to anything. And so this is essentially just like creating an empty variable. So in the beginning, this will be set to undefined, and then here we can redefine that value basically. And so one more time we can see that these class fields are really just like any other property. That's why later down here, we can then access it on the this keyword and set it to the value that we received. So let's try that. And indeed, the pin here is now also a protected field, or actually a private field. And so when we try to access it, we will no longer be able to do that. All right. So that is truly private class fields. And again, these are going to be available on the instances themselves. So not on the prototype. And so, yeah, of course, that's why we have them right here in the instance. Now, some people don't like the way that the syntax looks here with the hash symbol and there has been a lot of discussion going on. Now, I don't mind it at all. I just like to focus on the benefits that this new syntax gives us. There is a slight change that it might still change before the proposal reaches stage 4, but in this case, I will simply go ahead and update this video. But anyway, next up we have public methods. And actually, that is nothing new at this point. So all these methods here that we have been using are indeed public methods. So in this case, there is not a lot to talk about. And in fact, we had already written something similar here. So saying that all of these methods together are basically the public interface of our class. And so therefore, let's move on to our final point here, which is private methods. So let's do that down here. And private methods, as we already mentioned earlier, are very useful to hide the implementation details from the outside. And that's why in the previous lecture, we already made this method protected with this underscore. And so let's now grab this and put it down here. And now to make a private method, the syntax is exactly the same as private fields. So just like with the hash. Now the big problem here is that right now no browser actually supports this. So I can just show you how it works in the code, but unfortunately I cannot show you how it works. So if I save this now, I will probably get some error. And so yeah, the first one is that this function now no longer exists. So let's change that here as well. And well, we don't get any error actually. So that's surprising to me. Let's see what we have here. So indeed, here we have the approve loan now. So I guess that right now Google Chrome simply made this method like a private field. So that's why it no longer appears in the prototype. Right? So it's not here, but now it's instead on the instance. So that's not really what we want. Let's just test if we can access it out here. So console.log account1 dot approve loan with some value. And then we get the same error as before. So private field approve loan. And so, yeah, it's just as I said. So Google Chrome right now basically sees this as a private class field and not as a method. And so that's why I was saying that the methods are not really yet implemented in Google Chrome. So private methods are not available. And so let me just leave it here as a comment, but I will go back to simply protect it with the underscore convention. All right. So at some point in the future, this will work. But for now, let's leave it just as it was before. Okay. So we talked about these 4 features here. So public fields, private fields, public methods, and private methods. Now, besides these 4, there's also the static version of the same 4. And that's why I said in the beginning that actually we have 8 new features. So there's also the private version. And actually, and that's not private, that is static. All right. And actually, we already used the static public method before. And so that worked by simply adding the static keyword in front of it. Remember? So just static and then some method name. And so usually we use this for helper functions because these static methods will not be available on all the instances, but only on the class itself. Remember? So this static one here only works like this. So account.helper. And so, as I said, there's also a static version for all the other 3 ones. but I'm not going to show them to you now in this video because they are really less important. And if you want, you can of course easily test them out by yourself. Okay, and that's actually it. So this is how we implement encapsulation and data privacy using the new class fields proposal that hopefully at some point will really become part of the JavaScript language. Do you remember how we chained array methods one after another? For example, filter, map, and reduce. So by chaining these methods, we could first filter an array, then map the result, and finally reduce the result of the map all in one line of code. And we can actually implement the same ability of chaining methods in the methods of our class. And so let's go do that now. And actually, this is extremely easy to do. So all we have to do is to return the object itself at the end of a method that we want to be chainable. So let's say that we wanted to do this. So let me take that away from here. So chaining. So let's say we wanted to do account and then deposit, let's say 300. And then right afterwards, we wanted to deposit again on the same account. So we would like to call deposit again right away. Let's say 500 this time. And then immediately after that, let's say we want to withdraw 35. Maybe we also want to request a loan in the middle of this. So request loan, let's say 25,000. And then finally, we want to withdraw some more. Let's say 4,000. So right now, this is not going to work. So let's see the error. And so the problem here is that this one here will work, but this will then return nothing because let's see, the deposit method does return undefined because we're not returning anything explicitly here. And so then undefined gets returned. And so then here in this next one, we are trying to call the deposit method on undefined, which is the result of all this. And therefore we get exactly that error here. So what we need to do is to call deposit actually on an account. And so what we want is for the result of this here to be again the account, right? And so let's do that. So all we have to do is return this, because this is of course the current object. And now we do the same on all of them. Okay. And here the same. And that's it. So returning this will essentially make the method chainable. And this makes most sense in methods that actually set some property. And so all of the three that we just did this actually do that. So this one sets the movements here, this one actually too, and this one also changes the movement array. And so all of these basically set some property, and so these are then very useful to make chainable. So let's see now. And, well, we get no error, and we get loan approved. So that means that probably everything worked here. So let's take a look at our account here. Actually, let's call account get movements. So that's why we have this method in a public API. And so indeed, all the deposits and withdrawals that we just did are now in this movements array. Great. So with this, you have yet another tool in your toolbox now. So experiment a little bit with this on your own, and maybe also when you start writing your own classes. All right. So with this one, I actually showed you all there is to show about object-oriented programming in JavaScript. So what a long section here, but also a beautiful one, if you ask me. Now, just to really wrap up this section, next up I have a nice overview of the entire class syntax, and then one final coding challenge. So as we reach the end of this section, let's quickly review all the terminology around classes, because there is so much different stuff going on, so a lot of different features that you can use. And since classes are probably the way you're gonna implement OOP by yourself, it's always good to have a nice overview of everything that we can do with them. So here we have a huge class which essentially contains all the features that we studied over the last couple of lectures. So this is how we define a class, and in this case it is actually a child class. So student is a child class of the parent class person, and that is because here we are using the extends keyword to set up the inheritance between these two classes. And remember that the extends keyword will also automatically set up the prototype chain for us, so we don't have to do anything manually. Next up, this is how we define a public field. So this is what we did in a very recent lecture, and so remember that a public field is very similar to just a property that we defined in the constructor. So it is available on every created object, so on every instance created by this class. Then, of course, we also have private fields, and they are almost the same as public fields, but they are not accessible outside of the class. And so therefore, this is perfect for implementing data privacy and encapsulation. We also have static public fields, and so these are fields, or like properties, that are available only on the class. And I didn't show them to you in the code, so in one of the lectures, but this is how we can implement them. So just like static methods, we use the static keyword to make any field static as well. Then here, this is the constructor method, and it is automatically called by the new operator whenever we create a new instance of the class. So basically a new object. And this constructor method is mandatory in any regular class, but it might be omitted in a child class if we wanted to have the exact same number and the exact same name of parameters. Then inside of the constructor, there is the call to the parent class, and so that is the super class. And this, of course, is only necessary whenever we are writing a child class. So when we're using the extend keyword. And remember that this one needs to happen before we can access the this keyword in the constructor. Then here we have an instance property. And so just like public fields, the property is also available on each created object. But the difference between this one and the public field is that we set these instance properties based on input data of the constructor. So basically, these properties are more personalized and unique for each object, while the fields are usually for something that is common to all the objects. For example, here, the university for all of the students is the University of Lisbon. And so that is not unique to each object. Okay? Then here, we are redefining a private field. And so this is what we did with the PIN in the bank account example, right? So this private field should be unique for each student. And so we created the private field out there without any value. And then here we are simply redefining it to the value that is coming into the constructor. Then here, as we already know, is a normal public method. Here we are referencing a private field and also a private method. And so about the private methods, this is how they look like. But as I mentioned, they will probably not yet work in your browser, at least if you're watching this close to the recording date of this course. So as an alternative, you can fake private methods by using the underscore convention instead of the hash. Next up, this is what a getter method looks like. And remember that a getter method is basically so that we can get a value out of an object by simply writing a property instead of writing a method. So in this case, we could simply write student.testscore, and that would then run this getter method. And the same for the setter method. So in this case, we can simply define the test score by setting it to some value instead of calling a test score method. And keep in mind that if you have a setter for a property that is already defined in the constructor, then you need to create basically a new property with the underscore in front of it. So again, that is kind of a convention that you should use in this case. And then in the getter with the same name, you also need to then return that new property. So we did that in one of the lectures when we did a name validation for the name that was passed into the constructor. Remember that? Next, this is how you write static methods. And a static method is available only on the class. So it cannot access the instance properties nor the methods, but only the static ones. So for example, that static public field that we defined there in the top will of course be accessible in the static method. And usually we use these static methods as helper methods for the class. Finally, this is how you then create a new object using the new operator. And so this should be nothing new at this point for you. Now, here is just a couple of things that we need to remember about classes and that I actually already mentioned before as well. So keep in mind that classes are really just synthetic sugar over constructor functions. Also, classes are not hoisted, they are first-class citizens, and the class body is always executed in strict mode. Okay? And there you have it. This is an overview and also a summary of the entire syntax of classes in JavaScript. And here it is, the final coding challenge about object-oriented programming. And in this challenge, the goal is to recreate the challenge number 3, but this time using ES6 classes. So basically what you should do is to create a class, EV, so electric vehicle, which is going to be a child class of the car class that we already created before as well. Then in that EV class, make the charge property private. So that's number 2. And then point number 3 is that I want you to implement the ability to chain the accelerate and the charge battery methods on this class. And the same also for the brake method in the car class. So that's actually called car.cl. So then go ahead and experiment with chaining, and all of that should be done using this test data down here. All right. So I already have the code here, and so this makes it a bit easier to understand what the goal is. So as I mentioned, we already have the car class from before, and so this one is basically going to stay the same, except for the brake method, which I want you to make chainable. And then here we have the EV already, as we implemented it previously using constructor functions. And so the big goal of this challenge is basically to convert all of this into a child class of the car class. All right. So let's do this. So class EV CL, and now this should be a child class, and so we use the extends keyword. So this extends the car CL class. And now let's put this curly brace actually down here, because all we need to do is to now modify this a little bit. So here we can transform this here into the constructor. So the constructor method, and we still need the make, speed, and charge, of course. Now here we don't need to call the car, but instead we call super, remember? And we do that, of course, without the this keyword, because all of this will automatically happen behind the scenes. Okay, so if I save this now, we get this error, but that's because we still have a lot of stuff to change down here. Next, here is linking of the prototypes, and none of this is necessary with classes because all of this simply happens automatically behind the scenes. We also don't need to set anything manually on the prototype properties. So let's get rid of this. And in here also, we don't need the function keyword. And so with this, I think for now, we should be good to go. So let's now create an object called Rivian, which is going at 120 with a charge of 23%. So Rivian, which is another electric vehicle brand. So EVCL Rivian 120 and 23% of charge. Let's check it out here. And yep, there it is. Great. So next up, the task is to make the charge private. So let's do that. So this is the car. So here we don't have the charge in the parent class, but we do have it here in the child class. Now we receive this charge actually as an input here. And so we still need to define all the fields outside of any method. So we do that up here, and that is true for both private and public fields. So in this case, we want a private field, and that's called charge. And then we don't give it any value, and here we simply reassign that. And then all we have to do is to change it everywhere. So that's here and here and here. Give it a save. If we now check this, then indeed, here it is, and we didn't get any error. But indeed, as we try to now access this property outside, then that is not going to work. So it is now truly private, and it is encapsulated inside of the class. So from outside, there's no way of changing it, except of course, by charging the battery or by accelerating. And so once again, this method here is basically a public API so that we can manipulate the charge property from the outside, but without being able to directly access the property from the outside. So next up, we want to implement a chaining on accelerate, charge battery, and brake. So on brake, we need to do it here. And so remember, all we have to do is to return this keyword, right? So that's very easy. Here the same, this. And again, we are doing this here basically on all the methods that actually set something. And so that's where this makes the most sense. Great. So now we are able to do something like this. So we can accelerate, and then we can accelerate again, and we can accelerate again maybe. Let's brake for a change. Then let's charge the battery, let's say to 50%. And then let's accelerate some more. And so this is what the result is going to be looking like. So here we are accelerating 3 times, then we are braking down by 5 kilometers per hour, and then immediately we add 20 kilometers per hour back again. And the charge then drops to 49, and that's because previously we had charged it to 50. And what's also interesting to see here is that our child class does also inherit the getters and setters from the parent class. So we can also do this. So remember, that is a setter and a getter that we defined previously. And so this is basically 195 kilometers per hour converted to miles per hour. Okay, and with that, this challenge is now completed. And I think we used all the things that we learned over the course of this section right here in all of these 4 challenges. So this should cover everything that you learned. And so by now, you actually already put everything that we learned about object-oriented programming into practice by yourself. So congratulations for that. That was a really great job and a great effort to watch this entire section until the end. And now it's time to make this even more exciting. And to do that, we will create an entire brand new project which will be completely based on objects in the next section. So that project is going to be one of the most exciting things of this course, in my opinion. So I hope to see you there soon once you finished basically digesting this section. So congratulations once again. I'm really happy to still have you with me here at this point of the course. And so I see you back here in the next section.